Welcome to this course. I'm extremely happy to welcome you on board. In this course, you will learn Flutter and Dart from scratch. No prior knowledge is required. We'll start at the important basics and then work our way through all the core features up to more advanced topics like working with native device features, the Flutter internals, state management, and much more. This course is fully up to date, and as I do it with all my courses, I will keep this course up to date, and you will learn all the things not just in theory, but in an example-driven, project-focused way. We'll build multiple apps throughout this course so that you have concrete examples of how and when to apply a certain feature, and you will learn all the things by applying features on your own. You can follow along and code along, and by the end of the course you will have built multiple apps and you will be well prepared to build your own apps with the knowledge gained in this course. This course also has tons of quizzes and a lot of attached documents that allow you to dive deeper and check your knowledge. Now in addition, you get Q&A support in case you should get stuck, and therefore I'm convinced that this course will turn you into a real Flutter developer. Now, who am I? My name is Maximilian Schwarzmüller and I'm a 5-star rated instructor here on Udemy. I got multiple best-selling courses, and this course here also is the best-selling Flutter course, and I'm super excited about Flutter. I'm working with it since its early alpha days, which actually already are a couple of years ago, and I enjoy working with Flutter. It's an amazing technology which allows you to build amazing mobile apps, and I can't wait to dive into that together with you. So I guess let's get started and let's dive into the most important question. What exactly is Flutter?
So what is Flutter? Flutter is a tool that allows you to build native cross-platform, and that means for iOS and Android, apps with one programming language and code base. So let's have a closer look at this nice sentence here. Important is that we build native cross-platform apps. So we build both an iOS app and an Android app. We're not building a web app that runs in the browser. We're not building an app that gets wrapped by native apps. We build real apps, two different kinds of apps in the end for iOS and Android, which you then distribute through the different app stores. So through the Apple App Store and the Google Play Store. That's what you get as a result. Now you get there by using one programming language, so that you don't have to learn two different programming languages, one for iOS and one for Android. Instead, you have one programming language, Dart, but I'll come back to that, and also one code base. So you work in one project, you write your code once, and you still get two different apps as a result. And that's the cool thing about Flutter. You only learn one programming language, you only write your code once, and you get two apps. Without Flutter, you would normally build an iOS app by writing some Swift or Objective-C code and using the iOS development environment. And for Android, you would be using Java with the Android framework, or you would be using Kotlin and also the Android development environment. And you would have to learn all these different languages and tools. And you would have to write two totally different apps or work in two totally different projects. And with Flutter, that's not the case. One programming language and one code base. If we have a closer look at Flutter, though, it's actually a combination of things. The term Flutter refers to two major things. One is a SDK, a software development kit. You could say a collection of tools that allows you to write one code base or use one code base with one programming language. Because it includes tools to then compile this code, which normally would not run on iOS and Android, into native machine code that does run on these platforms. Because if there would be one programming language that would work on both platforms, we wouldn't need Flutter, but there isn't. Now therefore, the one programming language Flutter uses doesn't work on iOS and Android, so it needs to be compiled to native machine code for iOS and native machine code for Android, so that we have code that does run on these platforms. And that compilation task, along with a couple of other things, that's all part of Flutter. But of course, it's not just a collection of tools. It also gives you everything you need to create beautiful applications. It gives you a framework, a widget library for that one programming language, which is called Dart, which you can use to build beautiful Flutter apps. And that's what we will spend the majority of time with, of course. It gives you a vast collection of reusable UI building blocks, these so-called widgets, So these are things like buttons, tabs, text inputs, drop downs. You get all of that out of the box. You can style them and customize them, and then you build user interfaces with these tools. In addition, you get a couple of utility functions and generally some packages that help you build what your users see and what your users interact with. And then that code which you build with the help of that framework, that is then compiled to native machine code with the help of the SDK. So that is what Flutter is. Now, as I mentioned, Flutter uses a programming language called Dart. Dart is a programming language which is focused on building front-end user interfaces, front-end apps. It's not limited to building mobile apps, that's just what Flutter uses it for, but Dart is independent of Flutter, and you can also build web apps with Dart. But we'll not focus just on Dart here, we'll focus on Flutter and how it uses Dart. And Flutter uses Dart mostly for building mobile apps. So it's a programming language built to make it really simple to build front-end user interfaces. It's a programming language which was developed by Google or is developed by Google, just like Flutter. So these are actually two independent teams in Google, but of course they're working together to improve each other. And therefore we have a hand-in-hand solution here. And in case you already have some programming experience, it's an object-oriented and strongly typed language. And its syntax is a bit like a mixture of JavaScript, Java, C#, but you don't need to know any of these languages. And actually you don't need to know anything about programming to follow along. In this course, I will teach you Dart from scratch along with Flutter. So we'll build Flutter apps and you'll learn Dart and the features you're using there along the way, because I think that's the most fun way of learning that programming language and already see nice results, the apps we're building. So Flutter and Dart are not really alternatives, instead they're working together. Flutter builds up on Dart. It's a framework for Dart, and Dart actually is the programming language which we're using. Flutter then just is a collection of tools, a set of features, utility functions, and these widgets which are implemented using Dart so that you don't have to reinvent the wheel there, but you can write your own Dart code and use these existing widgets in your code so that you don't have to, again, reinvent how a button should look like and work, but use the pre-built button instead and then just customize it to your requirements. That's how this works. And in addition, as mentioned, Flutter also gives you that SDK, so all these tools for compiling your code in the end. So now that we know what Flutter is, or that we at least have a rough idea about that, let's have a look at the architecture of a Flutter application. And there, the most important thing, which you'll see over and over throughout the course, is that Flutter has that idea of building user interfaces as code. That's called UI as code. You build a widget tree in your Flutter apps, and I'll come back to that in a second. In the end, the idea is that you will have no visual drag and drop editor for adding buttons or text inputs to your screens to what the user sees. Instead, you'll work only in code. We'll write everything in code, and whilst this might sound intimidating at first, you will see that Flutter has a really nice approach for that, which makes creating interfaces with this UI as code approach a breeze. Now, besides this core idea of how you build your apps in Flutter, this UI as code approach, it's also important to understand that Flutter apps do actually embrace platform differences whilst being based on one code base. So we work in one project, but we will still have the ability to create different user interfaces at some points or in some parts of our app if we need it for the different platforms. Because Android and iOS are not exactly the same. They're not just for different phones. They do have some small differences, and sometimes it doesn't matter to you, but if it does, Flutter gives you the tools to find out on which platform you're running, so that if you're on Android, you can execute code A, and if you're on iOS, you can execute code B. So Flutter gives you the full flexibility there. Now let's first of all have a look at that widget thing again. In Flutter, everything's a widget. That's important to understand. If you had an app that looks like this, then this is a bunch of widgets. For example, here, the app bar at the top with the tabs in there. That's one huge widget with a lot of smaller widgets in there. And all these elements on the screen are just widgets in the end. You build your entire screen, your entire app from such widgets. Actually, the whole page is a widget, and even the whole app is wrapped in one main widget. And a widget, as you will see throughout this course, is really just a code snippet, an instruction you place in your code. Something like, please render a button here. That's a widget. It'll be as simple as that. And your entire app is therefore built as a widget tree. You have this root widget, which is your app itself. Then you might have different screens there. On the different screens, you have different sections, and in there you might have text inputs, text outputs, buttons, tabs, drop-downs. And a widget might hold other widgets. For example, your tabs widget might hold individual tab widgets. But thinking about this in an abstract way can be really difficult, and therefore for now just keep that term widget tree in mind. We'll have a look at how this works and how this looks, and we'll actually write all the code for that together throughout the course. Now, this UI as code concept is also important. If you had an application that looks like this here, then, as I mentioned earlier, you don't build it by dragging and dropping elements into a visual editor. You have no visual editor indeed. Instead, you only work in code. The code for this could look like that here. And here you already get a brief preview at how these widgets work and how you structure your entire app with the help of these widgets, how you configure your app with these widgets. And as you can see, even without understanding that code, that probably doesn't look too difficult. In the end, here we just have a bunch of instructions on what should get rendered on the screen and how the different things are related. And of course, you'll learn all about that throughout the course. So this is an extremely straightforward way of building your app, and I will introduce you to this approach carefully, step by step. We'll build our apps from scratch, and I will introduce you to the core widgets and how they work together step by step in this course. Now, this one code base thing or concept is also important to understand. In the end, you will have a bunch of Dart files in your project, and these will make up your application, and you build an Android and an iOS app based on that one project. But as I mentioned, if you need to, you can still find out on which platform you are running and then render different content based on that platform. So these are the core Flutter ideas. Again, if they're not 100% clear at this point, that's normal. We just started. We'll of course use all these features and go through all these features step by step as we progress through the course. Now, how does Flutter and Dart therefore then work internally? How is your Flutter app actually converted to a native app which can be published to the app stores? Well, you have your Dart code, which uses the Flutter framework, or the Flutter API as I call it here, which stands for Application Programming Interface. In the end, that just means that Flutter gives you a collection of functions, of widgets, which you can use in your code to build the interface you want to build. So you have your own widgets in your own code then, composed of that set of built-in widgets or your own widgets, which you can also build. And you want to build for Android and iOS. Now, as I said, Flutter simply compiles that Dart code to native code for these different platforms. And that happens with the help of the Flutter SDK. And as a result, you get real apps spit out with highly optimized, high-performance code that's based on your code, but that's not your code itself. Instead, it's a compiled version of that code. And therefore, you really ship code that runs on the different platforms and that's optimized and high performance. Because performance is actually a huge advantage of Flutter apps. Flutter out of the box gives you high performance applications. Now, in case you worked before with, let's say, React Native, which is kind of an alternative to Flutter, and I'll come back to this in a second, it's important to understand that Flutter does not use platform primitives. Now, what do I mean with that? We're having our Flutter app and we're targeting iOS and Android. Now, if we want to add a button, then in Flutter, with this UI as code approach, we do so by adding a raised button. Now, this is just an instruction in your Flutter code which tells Flutter to render a button in that part of your widget tree. Now, you could think that what happens when the code gets compiled to that native code is that this raised button is translated to, hey, iOS, please give me your default button, which would be a UI button element in the iOS development world, and for Android, a widget.button, that we get these native buttons, which are of course part of the native development environments. And that's not what happens. Instead, Flutter has its own implementations because Flutter, and that's really important to understand and to keep in mind, directly controls every pixel on the screen. So Flutter does not compile your code to some native equivalents or native alternatives. Instead, Flutter ships with its own engine, which controls the entire screen, everything the user sees, and renders every pixel on its own. And that gives Flutter a lot of control and a lot of flexibility. Now, you don't have to care too much about that because Flutter does it for you, but it's important to be aware of that because that gives Flutter more control and less limitations, and therefore you implicitly, indirectly benefit from that. You have a good performance, you have a lot of power, a lot of things you can configure. You have full control over how you want to build your user interface. So now that we have a basic idea about what Flutter is and how it roughly works, it's important to understand how Flutter is versioned. Flutter is relatively new. It's been around for a couple of years, but especially over the last year, it got a lot of traction and is really pushed by Google now. And therefore, Flutter versions are changing frequently. Now, this does not mean, however, that Flutter changes all the time, that everything about Flutter changes all the time. Indeed, Flutter actually is pretty stable. And the core API, the core features, which you therefore also learn about in this course, will not change. Instead, new versions bring bug fixes, smaller improvements, often also some behind-the-scenes changes, which you don't even see, and maybe also some new niche features. So maybe some new features which you don't directly need in your app, or which now allow you to implement something in a different way than you did it before, but your old way also still works, but you could now also use a different way. These are typically the things that change. And therefore, you will of course also see that in this course, I record a certain video with version, let's say 1.6, and you're viewing the course when the latest version is 1.9, but this does not mean that what you learn is not accurate anymore. Instead, this course is fully up to date and I will keep it up to date. And actually, I already did replace all the videos in the course once to improve the overall course quality and reflect a couple of important new features. I wouldn't have needed to do so because what I taught still was right. As I mentioned, it's not like everything changing all the time, but there were some things that could now be done in an easier way since I recorded my first version of this course when Flutter was still in beta. Now it's been stable for a while and therefore no large changes are to be expected, but whenever something does change or does need updating, I will keep this course up to date. And now that we have that out of the way, it's time to set up Flutter, set up the development environment for Flutter, and build our first little Flutter application. And as a side note, the next videos actually are from my first version of this course. Therefore, there you still see the beta version of Flutter. The setup hasn't changed a bit. The look of the website has changed a tiny bit, but the steps are the same, the result is the same. That's why I kept these videos around. They're 100% accurate. Nonetheless, but really keep this version thing in mind. And whenever something changes and doesn't work anymore, I will fix it and update it. No worries. So with that, let's build our first Flutter app and see how Flutter actually works and how we can build Flutter applications together. So let's install Flutter then. And the installation actually differs between Mac OS and Windows. For the rest of the course, the code we write and so on will be the same. But here for the installation, it differs. So therefore, in this video, we'll set up Flutter and all the surrounding packages and dependencies we need for Mac. And in the next video, we'll do the same for Windows. So if you are a Windows user, you can simply skip this video. And if you are a Mac user, you can skip the next video. So let's proceed with the Mac setup then. On flutter.io, you can simply click on Get Started and then choose Install on Mac OS. By the way, if you're on Linux, the steps are pretty much the same, but you can also click on Install on Linux to see them in detail. And that's in general what I would recommend. Go through these steps in detail. The good thing is you can read them here. And I strongly recommend following along here and reading these whilst you also watch this video or whilst you are going through the installation process, because A, some tiny steps could change over time, and B, this is a great way of resolving issues since there might be something you overlook in the video which you can then simply read about in this article. So let's continue. First of all, let's check the system requirements. Well, we need the operating system Mac OS, obviously, enough free space on our disk, and then we depend on these command line tools, which actually should all be available by default. Now, Git might not be, so it's a good idea to download it before you get started. You can simply search for Git on Google and then actually pick that first or actually that second link to find the downloads page. And there simply choose Mac OS or Linux, depending on where you're on. And then the download should start automatically. If it doesn't, you can simply click here, obviously. And this will download an installer through which you can simply walk to install Git, which is a version management system, on your machine. Now, you don't need to use that version management system, but Flutter uses it behind the scenes. This is why you need to have this available. Once you got Git installed, with the help of that installer you can download, which I showed you a second ago, you can proceed with these steps. And the next step is to actually download Flutter. Now, at the point of time recording this, the latest version is 0.3.2 beta. Chances are that when you're watching this, there's a higher version available, but the code we write will still be the same. So download the latest version you're seeing here, of course. Now I'll go with this one. Simply download it to your machine. And this can take a while. As you can see, it's quite a big file. So I will jump forward to the point of time where this already is downloaded. The installation just finished for me. You can now simply unzip this, and you can do that with the command you see here, or simply, well, click on that downloaded file, simply open it in the folder where it was downloaded, simply click on it down there, and then unzip this. Now this can take a couple of seconds, of course, since it's a rather big file. Once it is unzipped, you have this Flutter folder, and now you should copy this somewhere where you want to store this. Now, this Flutter thing here is an entire tool set. It's the SDK, the software development kit you need for developing Flutter apps. It includes a lot of dependencies Flutter needs. So this is really a central package, a program you should store on your machine. And you can copy it wherever you want on your machine. Now I got that tools folder where I want to have it, so I'll just drag it over there. And now with Flutter added to that folder, we can proceed with, well, the installation or with using it. So the Flutter tool is actually a tool we execute from the command line. Therefore, we need to add it to our path. The path is basically a global variable which ensures that the Flutter program, or which ensures that any program, can be accessed through the command line. And we want to configure the Flutter program to be found there. Now, to be found there, we could execute this command in the command line if we navigated into the newly created Flutter folder, or we do something which is seen a little bit further down the article. Here, we update our path permanently. Now, how does that work? For that, you should go into your user folder, and there you need to turn on the setting to see hidden files. You should then see that bash profile file. Now you can simply open that with the normal text edit app or with any text editor of your choice. Now if you're using the text edit app, just make sure you're viewing this in plain text mode, not in rich text mode. So if you open this then, let me make this a bit bigger, you can edit this file. And this basically configures path settings for your terminal, for your command line tool on Mac or Linux. Now, we want to add something here. We want to add this line, which you can find in the installation steps. Simply add it at the bottom. And we need to replace this part here with the actual path, the folder path, on to that Flutter tool on our machine. Now, that, of course, depends on where you dragged it. For me, it can be found under users, then my username, then there's a development folder, and then there I created a tools folder. And again, you really have to pick your path there where you dragged that Flutter tool. You can view that also by clicking on Get Info here. Then you can see where it's found. In my case, users, my username, development, tools. With that, simply save that file and thereafter open your normal terminal app on Mac or Linux. Once you did open that, you should be able to run Flutter Doctor. Now, this is a tool which will also check if you need to do something to make Flutter work, and it should at least do something if you set up your Flutter installation correctly. By the way, the fact that my installation is 30 days old, we can ignore that here because we know we just downloaded the latest version, 0.3.2 in my case, so this is all fine. Now, this is already looking quite good here because I actually have a decent setup. I'll still walk you through the remaining steps here though. So we updated our path. We now ran Flutter Doctor 2. Now what we need to do is we need to configure our system to be able to build iOS and or Android apps. For that, if you want to build iOS apps, if you want to test your app on iOS and ultimately build it for that platform, you need to install Xcode, which is Apple's development IDE, but also an absolutely required tool for building iOS apps, even if you use Flutter and no native code for that. So install Xcode by downloading it from the Mac App Store. And once you got it installed, you need to make sure that you can use the so-called Xcode command line tools. And this can be done by simply copy and pasting this command into your terminal. So you can simply run this. You might be prompted to enter your password there. And then it might or might not do something, depending on whether you already configured this. It might prompt you to accept the license. Once you completed this step, you can continue to step number 3 and execute this command to accept the license agreements of Xcode build, which is the build tool we're going to use. Now here you can simply scroll to the bottom, which can be sped up by hitting space a couple of times, and then type agree down there. Now with that out of the way, we can continue and we can bring up the iOS simulator, which simply is an iPhone running on our machine. It can be started with this command. You could also start it from within the Xcode, by the way, but I will simply start it with this command, open-a simulator with a capital S. And now what this should do is it should bring up this iOS simulator here. Now this is the device running. You can change the type of phone you're emulating here from that menu, device, and then iOS, and then choose your favorite device here. And now with that up and running, what you can do is you can start your Flutter app by running flutter run in the command prompt. Now for that, we need a Flutter app though, right? Because right now we only installed Flutter, but we haven't set up a Flutter app, a new project. So let's quickly do that. And for that, you should first of all navigate into the folder where you want to create your Flutter app. Once you navigated into that folder where you want to create your new Flutter project, run flutter create and then the name. For example, first_app. Important, this project name must not contain dashes or white spaces. It should be using underscores instead, or be one word only. Hit enter, and this will now set up a new Flutter project in that specified location, a new subfolder which holds that project to be precise. Can take a couple of seconds. And once it's done, you can navigate into this newly created folder. In my case, it's named first_app, and then hit Flutter run. Enter this, hit enter, and with the iOS simulator up and running, you should be able to see that Flutter app on that iOS simulator momentarily. The first build or the first time you run this can take a couple of seconds longer, by the way. Here we are. Now important, keep that process running. Don't quit it. You could quit it with Control-C, but you want to keep that running so that you can always rebuild your project and instantly ship that new version to the device whenever you change something in your code. So with that, you should see this, your first Flutter app running on the iPhone. And you can hit that plus button to see a counter that is incremented. This is an app the Flutter tool created for you. We, of course, didn't write any code yet. Now that's cool. And we will actually edit this a little bit to see how we can, well, work with that first Flutter app. But obviously, we also want to build for Android, right? So let's go back to these installation docs. We're done with the iOS setup here. the simulator at least. Now, if you want to deploy to a real iOS device, you can follow these steps here. You will essentially need to plug in your real iPhone, then also again execute these steps to install Homebrew, and then these extra tools which you need to be able to ship your app to a real iPhone. And once you're done with that, you can continue with these steps, and you will need to do some tweaking in Xcode to be able to ship your app to your real device. Now, that is something I'll come back to later in this course when we will actually test this on a real device and also deploy the app at the end. But again, feel free to already go through these steps. They're really simple if you want to run this on a real device. Now, I'll move on to Android for now. And for that, we will need Android Studio. Just like Xcode is the official IDE and contains all the build tools for iOS apps, Android Studio is the same for Android. So click that link to be forwarded to the download page of Android Studio. And on that page, it should automatically present you the macOS download. So you can simply hit download Android Studio here, accept these license agreements, and well, then download. Store this in any folder of your choice. And this again is a little bit of a bigger file, so let's wait for this to finish before we continue. Now the download did finish. You can then simply execute that file and it will launch an installer for you. Let me also close the iOS simulator here. Now that Android Studio installer is pretty straightforward on Mac. Just drag that into that applications folder. And this will copy or install that tool in that folder, which again will take a couple of seconds since it also unpacks that folder. And once you are done with that, let's go back to the Flutter installation page. Once you're done with that, you need to start Android Studio and go through the setup wizard to configure everything and install everything you need. Now, you could also be getting a security warning that the opening of Android Studio was blocked because it was from from the internet, not from an identified developer. You can then open it anyways through the Mac security and privacy settings. And ultimately, this should bring up this setup wizard. Now, click Next on the first screen, click Custom on the next screen, Next again. Now, here you can choose your editor theme. If you want to have the light or the dark one, you don't need to use Android Studio as an editor for this course. And actually, I won't, but you can. So I'll go with Darkula here, but that is totally up to you. Now, on the next screen, make sure to also check Android Virtual Device here under the installation options. The default installation path then should be all right. Click Next and Finish. And now this will download a bunch of things and install all the SDKs and tools you need to develop Android apps. And these will be used behind the scenes by Flutter, which is why we need them. So let me fast forward until this is also done. Now, by the way, this can take a couple of minutes, so don't worry if it takes a bit longer. It downloads and installs quite a lot of things. Now the setup finished for me here, so let's click Finish. And thereafter, you can click on Open an existing Android Studio project. Now there, simply navigate to the folder where you just created your new Flutter app. In my case, that's that first _app folder. Select the whole folder and click Open. And this will bring up Android Studio with that project opened. Now, when you open it for the first time, it will actually scan that folder. So let's wait for this to finish. And it should actually suggest you two things. Down there, it finds something about a plugin. And there you can simply expand this and click on Configure Plugins. It actually also shows you something about the Dart files. We ignore this for now. So now choose that Flutter plugin and click OK. And thereafter, click Yes to also install that Dart plugin for which it's asking up there. Thereafter, simply restart. Now, once you restart it, you may get a message at the bottom here regarding IDE and plugin updates. If you don't, that's fine too. In my case, I do get one. So I'll simply update now to install the latest versions of all the SDKs and build tools I might need. And that again will get downloaded, which again will take a couple of seconds. And now with all of that done, let me click Finish here. And now this is our Flutter project. Now I will open this in a different IDE where it's also a bit easier to read in a second. For now, we won't work on that code here. Instead, let's run this on an emulator. For that, we can simply go to Tools and then AVD Manager. That stands for Android Virtual Device. Let's open that tool. And here I actually got some pre-configured devices. You should at least have one that Nexus or some other device which is created with the installation. You can always create a new virtual device by clicking that button here at the bottom. And then you can choose which device you want to use. Let's say the Pixel 2. Continue, choose your API version. Now, typically the highest one is a good choice, or the one selected by default, I should say, not necessarily the cutting edge one, but this one. Click Next again. Now here on emulated performance, you should choose the hardware emulation for a faster emulator. The other settings should be fine. Simply hit Finish. And this should create that new emulator. And you can then start it by clicking on that play button on the very right here. Now this will bring up your Android emulator. Now we can of course use that emulator to run our Flutter app there too. And to run it, what we need to do is we need to go back to that command line where we previously already ran it on the iPhone and repeat that Flutter run command. If you still got the old one running, which you probably don't have if you shut down the old simulator, you can always quit the running process with Ctrl-C. So let's hit Flutter run to run it on our Android emulator once that emulator did boot up. And it will build the project with the help of the Android SDK that was installed together with the Android Studio. And that first build process can again take a couple of seconds. Subsequent ones will be faster. And now it should be up and running. Let's view it. And there it is. This is our device. And this is our Flutter app. And we can click the plus button to increment this counter. Awesome. So this is how we install Flutter and run it on both the iOS and Android emulators. Now, if you want to run it on real devices, you can follow the steps outlined in the documentation. But of course, we'll also run it together on a real device later in this course. For now, let's focus on the editor with which we're going to work on this code. I will not use the Android Studio editor, though you can absolutely do that. There's nothing wrong with it. It's a fully fledged IDE with the Flutter plugin. You can work in it, and if you want to use that, you can follow along through the entire course with that IDE without problems. I'll quit it though, because I have another IDE which I like more, and that's Visual Studio Code. You install it from codevisualstudio.com, and it's a free IDE, just like Android Studio. It should automatically present you the right download option for Mac, and you can simply, well, download it then, and once you did download it, you will have a file which you can execute and which will walk you through the installer. The installation should be pretty straightforward. There's nothing special on it or nothing tricky on it. Once you did install Visual Studio, you can open it, run it, and then in the starting screen, simply choose Open Folder or choose File, Open to open your Flutter project. So that is what I'll do. Open that first app folder, and this will now open Flutter in, well, that IDE. Now, I will actually use this IDE and also this look of the IDE, which is the dark theme. You can change the look under Code, Preferences, Color Themes. But I will install some extra extensions to make working with Flutter a bit more pleasant. And that extension can be added by going to View, Extensions, or using that shortcut, or using that sidebar you will probably see here on the left. Extensions are simply add-ons to Visual Studio Code, which let us enhance the coding experience. And there you should simply search for Flutter to find the official Flutter plugin or extension. Click Install there, and this will also install the Dart extension as a dependency. Once you did install it, you can hit Reload to reload Visual Studio Code with that extension added. And there's one extra extension I will use throughout the course, which is totally optional, and that's the Material Icon theme. Now that's not related to Flutter, it just makes the icons look nicer. I already got it installed. You can install it from this page. And once you did install that, but more important, the Flutter one, you can switch back to the Explorer here with that shortcut or by clicking in the menu. And you're back in your project structure. And now you're well prepared to work with Flutter. And for example, here in our main Dart file, we can manipulate our first app by, for example, going down to the increment counter method here and changing that counter plus plus thing to counter equals counter plus 2. This should now increase the counter by 2 on every click. Now, the very cool thing is you can hit save here and then go back to your command prompt where you ran Flutter run and simply hit R with that Flutter run process running. So don't quit it. Hit R whilst it is running, and it will hot reload your Flutter app, which means it will reload it on the fly on the emulator without the need to rebuild it. If that gets stuck somehow, you can press Shift R for a full rebuild and reload, still with that process running. So let's go back to our app, and it looks like nothing changed. We even have the old counter, but if we click the plus now, it increases by 2. And that's already showing how cool it is to work with Flutter and how easy it is to develop with it with that hot reloading. And this also is the setup I will use throughout the course. And I will teach you all about Flutter, Dart, and some tricks with the IDE throughout this course. Now let's see how that works for Windows, or if that doesn't matter to you because you're using Mac only, let's continue with the course and dive deeper into Flutter. In the last video, we installed Flutter for Mac. Now, if you're using Windows, let's now install it for Windows too. If you're using Mac only, you can therefore skip this video. So, to install Flutter on Windows, first of all, let's visit flutter.io, click on Get Started there, and then choose Install on Windows. There you will see all the installation steps in detail, and I strongly recommend also going through these step by step along with the video. Because for one, they can change in one or the other detail in the future. And then this is great to see or easy to see in that written form. And additionally, it's easy to miss a step. And therefore, this is a great companion for this video. So first of all, let's have a look at the system requirements. We install Flutter on our machine. We need Windows 7 or higher, the disk space, which is mentioned here, and important, one of these two tools, PowerShell or Git for Windows. Now, Git is a versioning system, and even if you don't use it actively, Flutter does use it. So here, I'll install Git for Windows by clicking on that link. Then we have the chance to download that Git tool from that Git page here. It should automatically give you the right download for your machine. Download it, and then walk through the installer. Now, in the installer, you can choose the place where you want to install Git, then simply hit next and, well, install that tool. Now, very important, you click next a couple of times and most of the default settings are fine. One important thing to note is that on this screen here, you should use Git from the Windows command prompt. Don't use one of the other two options, use the middle one here. This is also mentioned in the official docs. Now with that, hit next a couple of times and leave all the other defaults. And with all that, simply hit next one last time and it will install Git on your machine. And with that, you're fine. You can now close this and continue in these setup instructions. The next step is to actually install the Flutter SDK, which you can get from this download link here. Now important, the version of Flutter of course will change in the future. Right now it's 0.3.2.beta. It's production ready already, and the code you learn in this course will still be all correct in the future, even if you are downloading a different version, but make sure to download the version you're seeing here. So whatever version that is for you. So this will now also be downloaded. Will take a couple of seconds since it's quite a big file. And once it is downloaded, you can extract this folder into the place where you want to install that Flutter tool. Now important, the Flutter tool is not your project for your mobile app. It's a SDK a software development kit which you install globally on your machine and which you will use from different places on your machine to create new Flutter projects and to work with the ones you created. So to build them, to run them on an emulator, things like that. So unzip Flutter into that directory. And once you unzipped it, you can go into that directory. And in my case here, I'll also move all the files up one folder so that they're all directly in the Flutter folder. And then you can execute that flutter console.bat file here. Now this will open up a command prompt which already uses Flutter. And you could stop here and continue with the Flutter commands and with bringing up your Android emulator and so on, and always open that tool here to run the Flutter commands which you need to run or build your app. However, I want to be able to use the normal command prompt. So let's close the Flutter console here. And let's move on and make sure that we can use the Flutter commands from the normal Windows command prompt. For that, we'll need to update our path. Now, the path, that simply is a global variable which Windows uses to find the tools we can use from the command line. And since we picked a custom folder where we installed Flutter, or where we unpacked it to, we need to make Windows aware of where that is. You do that by opening your control panel and then going to User Accounts, and there simply click on Change My Environment Variables. Now in the window which opens, you should find a path entry which you can select and where you then can click Edit. Now here you can add new locations of tools you want to be able to execute to that path by clicking on New here. And then here you need to enter the path to your Flutter folder, so the folder you unpacked. Simply go into your Windows Explorer and there navigate into the bin subfolder, to be precise, that is what you need. Copy the path to that bin subfolder and add it to your path variable by clicking New, adding it to that empty blank space which opens up, and thereafter hitting OK. Now you're prepared to run Flutter commands from the normal command prompt. Click OK and make sure to close any command prompts you might have opened already. Restart Windows if you're facing issues thereafter. And once you did all that, you can bring up the normal command prompt and simply enter Flutter there. Now, this might show you a warning regarding the installation being a bit older. You can ignore that because we actually did just install the latest version, so that will be all right. But the fact that you're seeing this and not something like Flutter not recognized means that we did successfully add it to our path and that we can use that Flutter command line tool from our command prompt. Now, Flutter is now available. The next step we have to do is we have to set up Android Studio. This is the official SDK provided by Google for building Android apps. And whilst we will not write native code with it, it includes all the SDKs and build tools Flutter will need too. So simply go to developer.android.com/studio or use the link you find in the Flutter installation documentation and download the Android Studio version there. It should automatically give you the right version for your operating system. You need to accept the agreement before you can continue. And with that, the download will start, and it will also take a while since it's also quite a big download. So let me fast forward to the point where this is done. Now, once the download did finish, simply execute the, executable you got, and the installer will start. Now there you can continue. Make sure to choose Android Virtual Device as a component you want to install though. That's important that you tick that. Thereafter, you can choose the location where you want to install Android Studio, and you can use the default here or pick your own location on your machine. And then you can simply hit Next. Now this will again take a couple of seconds. And once it's done, you can start the Android Studio. And for the first time you start it, a wizard will come up, which allows you to configure it. Now in that wizard, hit Next, and then choose Custom here. And the next step is that you can choose your UI theme. Now that's mostly important if you want to use Android Studio to build your Flutter apps, which you can. However, I will use a different IDE in this course. And I will go with the dark theme here, but of course you can choose your favorite look. In the next step, it's important that you check Android Virtual Device, that this option is ticked, because we will need to be able to bring up such virtual devices. With that ticked, choose your Android SDK location, use the default or create your own path, and thereafter simply hit Next. Now, this will install a couple of things, and you can start the installation by hitting Finish here. This will actually take quite long because it downloads and installs a lot of packages, so don't worry if this takes a couple of minutes, maybe even 20 minutes or something like this, and I will be back once it's done for me. Once the installation did finish, you can, well, close the installer and then bring up Android Studio again. Now here, you can open an existing Android Studio project, which would be your Flutter app you're working on, but we don't have such an app yet. So our next step actually is to create such an app. However, we will need an emulator to view it. So let's make sure we fulfill all requirements for that. You can see them here in the official docs. And by the way, if you want to install your app on a real device, that is something we'll also do later in the course. And you can, of course, already go through the steps you see here if that's important to you right now already. But again, we'll do this together later in the course. For the majority of the course, we will work on the emulator though. So there on the emulator, you see that it's important that we have hardware acceleration enabled on our machine. Click that link to learn more about it and see how to turn it on. And thereafter, we can go back to Android Studio, and now we need that Flutter project to continue. So back to the command prompt. There, you should now navigate into the folder where you want to create your new Flutter project. You can navigate around in Windows with the cd command to change the directory you're in the command prompt. Now make sure to create a folder and navigate into that folder where you want to store your Flutter app. And once you're in that folder, you can create a new Flutter application and project by running flutter create and then the name of your project. Now important, that name must not contain a dash or something like that, also not a white space. Words should be separated with underscores, or you simply use one word only. So flutter create first underscore app is my command here to create this project. And now this will add a new folder in the location you're in the command prompt and configure your first Flutter project in there. As you can see, it creates a couple of files. And once it's done with all that, you can open the project in Android Studio by clicking on Open an existing Android Studio project. And there you should navigate to that folder you just created and open it there in the Flutter folder in my case. So basically open that project you just created, first underscore app in my case. This will open it in Android Studio. And before we do anything there, let's bring up that virtual device. You can do that by, in Android Studio, going to Tools, and then AVD Manager, which stands for Android Virtual Device Manager. And in the window, which then opens up, you can start a new virtual device by clicking on to Create Virtual Device. You should also have one by default, which you can use, but let me show you how to create a new one. There you choose your blueprint, basically regarding the general hardware and layout profile. I'll go with the Pixel 2 here. On the next screen, you choose the image, the Android version you want to use. And I recommend not going with the cutting edge version, but using the latest stable version. In my case, Oreo API level 27. Typically, that's the one which is selected by default. Hit next again. Now on the next screen, make sure to choose hardware acceleration from the graphics drop down there. And you can have a look at the advanced settings, but you typically don't need to change these. And with that all done, you can finish that and create that new virtual device. Now with it created, you can start it by clicking on that play button on the right. And this will open the virtual device on your screen. It will bring up an Android phone on your machine, so to say. Now, with that running, we can't run our Flutter app yet because we still need to do some things. For one, we need to install the missing dependencies, the missing plugins. For that, click on Install Plugins here at the top where it tells you about the missing Dart plugin. You could, by the way, also skip this if you already installed a Flutter plugin, but here I do it in 2 separate steps. So install that Dart plugin. Once the installer is done, you need to restart Android Studio. And once you restart it, you should actually get a message here at the bottom where it suggests you a new plugin. Expand that message and click on Configure Plugins. And there, it will suggest the Flutter plugin. Simply accept this by clicking OK, and now it will install the Flutter plugin too. And that would have installed the Dart plugin with it, so you can actually do that in 1 step only. And once this is done, you need to restart the IDE one more time. So let's do that. Let's restart the IDE again. And now we have Android Studio configured to support Flutter. Now, we still don't see our emulator here at the top, and therefore we still can't start our application. Let's quit the emulator for now. And to make it work, first of all, go back to the setup instructions and make sure to install that Google USB driver. Now, that should only be important for running it on a real device, but it still doesn't hurt to set it up already so that it will work later. So click on that link you see there and install the USB driver. You can do that from within Android Studio by going back into it and there going to Tools, SDK Manager. And in the SDK Manager, go to SDK Tools and choose Google USB driver there. Hit OK thereafter or apply and install it. You also need to accept the license agreements there. Now, with it installed, you will need to also do one more thing if you installed your Android SDK in a different place on your operating system than the one suggested during the wizard, which I did. You need to add one other environment variable. You can also see that if you go back to the command prompt and run Flutter Doctor, a tool which tells you what's missing. Here it tells me that it's unable to locate the Android SDK. And therefore, I will go back to my control panel and there to user accounts, and then change my environment variables. And first of all, we need to add a brand new variable. So click New here. And then name that variable, and the name is important, Android_home, all uppercase. Make sure to not add a typo here. Now, with that name defined, you need to define a value, and that simply is a path pointing to the Android SDK. You can click Browse Directory here to choose the Android SDK location, and there simply choose the location you selected during the wizard or in the wizard which opened or which ran when you opened Android Studio. In my case, it's the Android folder. It should be this folder which has a platforms, emulator, and so on subfolder. Simply hit OK with the root folder selected, and now you also need to add something to your path variable. So select that again and click on Edit, and there you need to add 2 new entries. The first one should be %, and then Android home, so that variable name you just created, written exactly in the same way, and then another %, \tools, and then you need to add one other entry, which is also %, Android home, \platform tools. Make sure it's written exactly as you see it here in the video. Now, with that added, hit OK and restart the command prompt. And now also restart your virtual device by quitting it, potentially wiping the user data if you're facing issues restarting it, and then hitting the green play button again. This will bring up the emulator again. And now you should see it here in the drop-down selected. And now you can press that Run button to run your Flutter app on that virtual device. Now this build process, which will start it on the device, can take a couple of minutes when you run it the first time. Don't worry about that. And once it's done, you should see your Flutter app running on that emulator. And you can hit the plus button here to increment the counter. Pretty awesome. Our Flutter app finally running on an emulator. And of course, we'll change this app soon. Now, as I mentioned, I won't use Android Studio as an editor here. And therefore, I also want to show you a way of running this without Android Studio. You can do that by going to the command prompt, navigating into the folder where you have your first app or into this project folder you created. And in there, you can run Flutter run. And this will now do the exact same as you did with the command inside or with the click of the button inside Android Studio, but without you doing it through Android Studio. It will build the app and ship it to your emulator and run it there. And this is actually how I will run my apps for the rest of this course, since I won't use Android Studio. You can use either approach, however, using Flutter Run will have advantages like the hot reloading I'll introduce in a second. Now, which editor will I use then? I will use Visual Studio Code. You can get it from code.visualstudio.com. It's a free IDE, which also has an extension that provides awesome Flutter support. You can download it from that page, and it will automatically give you the right version for your operating system. And you can simply walk through the installer. It's pretty straightforward, nothing special about it. Simply install the IDE on your machine. Now, once you did install it in your favorite location, you can start it. And in the IDE, you can then click Open Folder or choose the Open option from the File menu in the top left corner and simply choose that first _app folder you created. Now, this is your Flutter app. And in order to be able to work with that really well, we should add a so-called extension. So a plugin we can add to that IDE to add extra functionalities. You can install extensions by clicking on this icon on the left or selecting View Extensions in the menu at the top. And there simply search for Flutter. Install that extension you find here. It's the official Flutter extension. And it will also install the Dart extension together with it, because that will be a dependency. And once it is installed, you just need to restart the IDE to have that installed. Now, I will use one extra extension throughout the course, and that's the material icon theme that is not related to Flutter development. I just like the icon look I get with it. It's totally optional. I just want to show it here so that you don't wonder why my icons look different than the default icons. Once you install that, if you want it, you again can reload the IDE. And with that, we can finally make a change to our Flutter code after I activated that new theme. You can see your Flutter code in the lib folder of the project you opened. And there in the main.dart file, you see the code which is responsible for the app which is currently running on the emulator. There, search the increment counter, the _increment counter method, and in set state, change _counter ++ to _counter equals _counter +2. This should ensure that we actually increase the counter by 2 every time we hit the plus, not by 1 anymore. With that change made, go back to the command prompt and make sure that the Flutter run process is still running. Don't quit it. You could quit it with Ctrl+C, but as long as you are developing, you should keep it running, because then you can hit R with that process running to hot reload your app, which means the changes you added are pushed into the app without the need for it to rebuild. Now, sometimes this fails. Then you can press Shift-R to do a full reload and a full rebuild. And you can quit that process with Ctrl+C if you're done with development for the day. So I pressed R, and if I go back to my emulator here, you can see that I can now increment by 2 instead of 1. And this is our first little change. We will do much more, of course, but this is our Windows setup finished. Was quite a lot of work, but now we are prepared to continue and dive much deeper into Flutter, of course. In the first app, you already saw it, and throughout this course you will see it. Flutter by default embraces the material design system, the material design language. Material design looks like this, as an example, and it's a design system created and heavily used by Google. Now, it's not Google style for everyone though. It's highly customizable and works on iOS devices too, so you can also use it in your iOS apps. And whilst material design is built into Flutter, you also find Apple-styled widgets in the Flutter framework which you can use. And in this course, I will show you both. I will show you how to build apps that look like the typical material design application. I will show you how to set up your own look, so neither material design, not iOS style. And I will also show you how you can get that iOS look with the so-called Cupertino widgets, which Flutter also offers. So here again, Flutter gives you full flexibility regarding how your app should look like, and in this course I'll cover all the different options and show you how you build different kinds of apps. For the majority, I'll use the built-in material design widgets, but you will learn how you could deviate from this as well. We're nearing the end of this module, and you can skip this video here if React Native and Ionic doesn't tell you anything. These are simply alternatives to using Flutter, at least in a certain way. Flutter is not the only tool, the only approach that allows you to build iOS and Android apps with one programming language and with one project code base. There are other solutions too, also besides React Native and Ionic. There, for example, also is NativeScript and so on. But React Native and Ionic are probably the biggest competitors to Flutter. And I just want to show some examples on where Flutter differs from them. So why would you use Flutter and not React Native or Ionic? Now let's see how each of these approaches works. Flutter uses Dart and the Flutter framework, and Dart is a programming language developed by Google. React Native, on the other hand, uses JavaScript and the React library, and Ionic uses just JavaScript and any or no framework at all that you want. And by the way, I also do have courses on React Native and Ionic in case you want to have a look at that. Now the result of Flutter is that you get compiled native apps. So you get real native apps compiled for the target platforms. For React Native, that's pretty much the same, but I wrote partly compiled here because the apps are compiled to native apps, but there also are parts in your code, in your JavaScript code, which is actually not compiled, but which is basically enclosed in the native app and runs as JavaScript in the native app instead of as compiled code. And that's different for Flutter. There, all the code is compiled and runs as native machine code, therefore. And for Ionic, nothing is compiled. There, you actually have a web app, which is wrapped inside of a native app. So you still get a native app, which you can publish to the app stores, but it's just a wrapper around your web app. Now, the advantage of this Ionic approach is that you can use normal web technologies, and if you're a web developer, it's particularly easy to create such apps, and you can use all your normal web development skills to build cross-platform apps there. Downside of this wrapped approach, of course, could be performance. Now, for Flutter, it's also important to understand that we don't compile to iOS or Android UI components, but that Flutter gives you an app that controls the entire screen and every pixel on it. For React Native, that's different. There you do compile to iOS and Android UI components. So the parts of the React Native app that are compiled is in the end the user interface, and there, for example, if you render a button, it is compiled to the native iOS button for iOS and to the native Android button for Android, which means you have less customization possibilities because, for example, if you can't add a drop shadow to the native iOS button, you can't add it to the React Native button because that's compiled to the iOS button. For Flutter, since it controls every pixel on its own, you can style it in whichever way you want, or Flutter lets you at least, because the native button restrictions don't matter to Flutter. Now for Ionic, there is no compilation to native equivalents. Instead, you have a web app, so you can style a button as you could style it in any web app. It's not compiled to a native button. Now with Flutter, you can build cross-platform apps, mobile apps, and actually even web apps and desktop apps, though as long as that's in very early stages, it'll not be part of the course. I do cover it once it is more stable though. For React Native, it's pretty much only about mobile apps, though there is a project, an unofficial project if you will, which allows you to use your React Native app also to get a web app as a result. For Ionic, you by default, since you build a web app that's wrapped by a native app, you by default have a web app as well, right? So you also have full cross-platform support. You can get a mobile app with this wrapped approach. You have a web app anyways, and you can also build a desktop app by wrapping it around this web app, so to say, with a tool named Electron. Now, who's working on these projects? Flutter is developed by Google, React Native is developed by Facebook, and Ionic is developed by a company which is called Ionic, and therefore they all have big companies backing them, especially React Native and Flutter, of course, but also the Ionic company is earning its money with the Ionic framework. And therefore, regarding the future, all three should be very stable and under active development for a long time. So that shouldn't influence your choice. What should influence your choice then? Well, for Flutter, there you have the great advantage that you have real native apps, so you get great performance. No web view wrapped app, which automatically has a bit worse performance because of that wrapping. Instead, you have meshing code, which is running, and that gives you a great performance. And because Flutter controls every pixel on the screen, you also have a high flexibility. You have a lot of control over your app. Now, some people also might not like this approach of not having the platform primitives, but instead have Flutter control everything, because you could argue that it's therefore harder to get the default Android and iOS look and that it requires a bit more work from your side to get the look. But that's up to you to decide. I think the higher customization possibilities actually aren't too bad and are a nice advantage. But in the end, that's of course up to your personal preference. React Native and Ionic are certainly nice alternatives, and that's why I do have courses on all of them. And attached to this lecture, you actually find a link to an article and a video which I created where I compare these alternatives and dig a bit deeper into the details of these approaches and give you a more detailed comparison. As a first summary here, Flutter is a great choice, of course, because you have real compiled apps, and with every pixel controlled by Flutter, you have a lot of flexibility and high performance. So now it's really time to get started with Flutter and learn all about its details. We're pretty much done getting started. In the next course module, we'll dive into all the important basics of Flutter, and you will learn all about how Flutter works, the core widgets there, how you build user interfaces with the widgets, and so on. So that will be a crucial module, of course. Thereafter, we'll dive into debugging, because of course things can go wrong during development, and finding and fixing errors is an important part of being a developer. So we'll have a look at how that works in the debugging section. Before we then have a section where we dive deeper into the basics, if you will, dive deeper into available widgets, into how to style and customize your widgets, how to add more logic to your application, and in general, build more realistic applications. Now, it is worth mentioning that all of these concepts are not just taught in boring theory, but that we build full apps, and not just one app throughout the entire course, but we do have an app for the basics section, we do have a different app for the more widget section, and throughout the course we'll have a couple of applications, some apps only for one section, some apps which are used by multiple sections to show different concepts. This also gives you the advantage that if you come back to the course after a while, or you want to skip certain sections, you don't miss a large chunk of a project we're working on. Instead, many sections have their own projects, and therefore it's easier to get into them. Now, after having a closer look at styling and building more realistic widgets, you will also learn how to build responsive and adaptive user interfaces. Responsive simply means that you have user interfaces that look good on different device sizes. Adaptive means that your user interface adapts to the underlying platform, so to Android or iOS, and for example renders different widgets or a different layout if you want to. After that, you'll have a solid understanding of the core foundations of Flutter, of the fundamentals if you want to call it like that. And therefore we'll then dig deeper into the internals. We'll have a look at how Flutter and its widgets work internally, how the app is re-rendered when something changes, and how you can optimize your code to improve the performance and improve how your app works. With that out of the way, it's time for a new app and a brand new topic: navigation and multiple screens. Up to this point in the course, we'll always have worked on one screen only, but most apps have more than one screen. You might have a product screen and a card screen and a user profile screen, and here you will learn how to set up different screens and how to navigate between them so that you can switch pages in your app. It's around that time that we will also see that for bigger apps, it can get pretty cumbersome to manage the data correctly. The data our app or the different parts of our app needs. And therefore, we'll then have a look at state management. This is a super important course module where we will dive into the different options you have when it comes to managing data and state, which is in the end just a different term for data that changes, you could say. How you can manage that in bigger applications, how you can pass it around effectively, how you can make sure that when something changes in a certain place in your app, all places that depend on it are updated efficiently. And we'll have a thorough look at this in this module, and for this we'll also start a brand new project, just as we did in the navigation and multiple screens section. We'll then build up on that and dive into how you can manage user input and forms, so how you can fetch email addresses or URLs or numbers and have the user enter such data, before we then learn how to connect our Flutter app to the web. Because up to this point, we always just worked on the device, but some data needs to be stored in a database in the web. And therefore here you will learn how to reach out to the web, how to reach out to such a database and store your data there or get it from there. Now, most applications also need some form of authentication, and therefore it's then time to dive into user authentication and learn how you can log users in, sign them up, log them out, and manage their session across the lifetime of your app. Really, really important for many applications, of course. After that, we'll have a look at animations. Animations are a crucial part of applications because they allow you to give the user a better feedback regarding what changed on the screen. And you will learn all about the built-in animation techniques Flutter offers and how you can use them to create great user experiences and user interfaces. Now, most native apps also need access to certain device features like the camera, maps, on-device storage, things like that. And therefore, this is also something we'll have a thorough look at in this module then. We'll again build a brand new application for this module here, and you will learn how to use the device camera, take an image, store that image, how to store it on the device, and also how to use Google Maps or get the user's location. Now, sometimes you need some native device feature which isn't built into Flutter, where you have no easy way of accessing it through Flutter. Now, for camera and maps, that is built in, but maybe you have some use case where it's not built in. Well, then you will also learn how you can run native device code, so Java code for Android, for example, or Swift code for iOS, how you can run such code and connect it to your Flutter app so that you still have one project, but in case it's missing, it's not built into Flutter, you can actually run native device code triggered from inside your Flutter app. That's a really cool feature, and we'll cover this in this course as well. Now, once all of that is done, it's of course time to publish the app. And I will show you how you can build and optimize your app and then publish it to the Apple App Store or the Google Play Store. Well, and with that, we're done. I'll then round up the course, show you some next steps on how you can continue, and actually also give you a blueprint, you could say, for how you can develop great apps, which different phases are involved, and what my recommendations regarding that are. So definitely check that out as well. So as you can tell, there's a bunch of content in this course. I hope you'll like it. We have a bunch of apps we're building, and by the end of the course, you should therefore feel really confident to build amazing Flutter apps and build any app you want with the help of Flutter. So now that you know what's inside of the course, let's dive into how you can get the most out of it. So of course, you should watch the videos. It's a video on demand course after all. Watch them at your speed. Pause and rewind if I'm going too fast. I try to find the right balance for everyone, but if you feel like I'm too fast, slow me down or pause and go back to the start of the video again, because you should also code along and do the exercises. And sometimes that means that you have to pause the video so that you can code along. That's okay. Some students don't code along, which is why I don't have super long pauses in my video, since I want to create a good course for these students as well. But my recommendation really would be that you do code along, because that is how you learn the most. And also do the quizzes you find in the course, some exercises I have in there. Do all of that. Build your apps, build your own versions of my apps, because that is how you ultimately learn the most. Use all the course resources you find attached. That's my source code, which you can compare to yours if you're facing any errors. And also, of course, check out the different slides and cheat sheets I attach to various lectures in the course, since that can be really helpful, or it can be really helpful resources if you're coming back to this course after a while, or if you're working on your own projects. Now, if you're getting stuck and you did compare my code to yours, which you should always do first, you can of course also ask in the Q&A section. I'm trying my best to help you there, but I really can only help on questions that are directly related to the course and to the course code, and I urge you to compare your code to mine first before you ask, because most errors can simply be fixed by comparing code, and you learn much more if you can find and fix an error on your own than when I tell you and you maybe don't really understand what was wrong. And besides, asking in the Q&A section also help others, because you learn the most if you dig into problems, be that your own problems or the problems of others, and you solve them, and you have to write down an answer, and you have to think about the problem, and if your answer is correct. Of course, you might answer in a wrong way, but that's not a problem. You'll get corrected and you'll learn again. But if you try solving problems, be that your own ones or the problems of other students, you will learn so much more, because you really have to think about a problem and find a solution. And that is what makes you a great developer in the end. So definitely take this opportunity to get the most out of this course. So let's dive into Flutter. And for that, we'll dive into the basics. There are a lot of basics to cover, and hence this will be a long module. I strongly recommend that you watch it in pieces, that you code along, and also have a look at all the attached resources, the cheat sheets and documentation I provide, the text lectures I have in between, which allow you to dive deeper into certain concepts I might have walked over too fast, because I try to find the right speed that suits both newcomers and a bit more experienced programmers. So take advantage of all these resources, and of course don't be intimidated by the length of this. By the end of this module, we will have covered a lot of the core basics you need to build amazing Flutter apps. So what exactly can be found in this section then? We'll have a look at how a Flutter app actually starts and works, and what's really happening there, how a Flutter app brings something on the screen. We'll work with widgets, and we'll build custom widgets, because that is also a core part of building Flutter applications. You will learn how to react to user events, namely to button presses when a user taps a button. We'll learn that there are two major different kinds of widgets, stateless and stateful widgets, and you will learn what the differences are and when to use which widget. In addition, we'll cover a lot of Dart fundamentals, and I will teach Dart along the way, because I believe it's way more interesting to learn it whilst building stuff than to learn it up front and only start building stuff after an hour or two. We'll learn all of that here on a concrete Flutter app, arguably not the most beautiful one. We'll build way more beautiful applications later throughout the course, but that simply is the case because here I want to focus on a lot of functionality and features and behind the scenes stuff, and not so much on the layouting and styling stuff, which we'll also have a look throughout this course though, no worries. So we will build way more beautiful applications throughout the course. We'll write a lot of code across multiple files. We'll build our own widgets, and you will learn a lot about passing data around, managing data, styling to a certain extent, and core Dart and Flutter features. So let's dive in. So let's dive into Flutter then. And for this, let's create a brand new project. For that, open up your terminal or command prompt on your machine, so the default Mac OS terminal or your Windows command prompt. And in there, make sure that with the help of the cd command, which allows you to change directories, you navigate into the path where you want to create that new project. So here I navigated into a playground folder, for example. It doesn't matter how you name that folder, but it should be the path where all your project files are stored thereafter, or where this new project folder is created in, to be precise. Once you're in that path, we can use the Flutter command, which is available since we installed the Flutter SDK in the first course module. And we can run the create command there to create a new Flutter project in that place where we navigated to. So now with that, you can give this project any name you want, like Flutter course, or I'll name it Flutter complete guide. The name is up to you, and this just wrapped over 2 lines, so it's one name here. Make sure that in that name, however, you only have one word, so Flutter complete guide, it's one word, where the individual words are separated with underscores. Don't use dashes or blanks there, that will not be allowed and you'll get an error. Instead, use underscores for that project name. And this will then go ahead, once you hit enter, and scaffold out this new Flutter project for you. So now this creates this new folder, that Flutter Complete Guide folder, in the path where you navigated to. And inside of that folder, it gives you all the base setup for a new Flutter project. And by the end, you should see an output that looks something like this. You can ignore warnings you might be getting here. If Flutter Doctor basically showed you the same, it should work here. And now you can run these 2 commands to navigate into that newly created Flutter project folder and to then also run your Flutter project. However, I'll not do that here. Instead, I opened up the project here in Visual Studio Code, which is the IDE I'll be using throughout the course. Now, as you learned in the first course section, you can use either Visual Studio Code with the Flutter extension installed, as we did it in the first course section, or you use Android Studio, which is also absolutely fine. However, I prefer Visual Studio Code, and therefore that's the IDE I will use throughout this course. Now, this is Visual Studio Code just configured as I showed it in the first course section, nothing else. And this is this Flutter project, which we just created here in the command line. So this is the project and all the default files and folders we get in there. Now, in the next lecture, I will walk you through all these folders and files and explain what they do and with which files we will work mostly. But first of all, let's make sure that we can also see our app, not just in code, but on a device. And for that, you could use a real device connected to your machine. And of course, I also will show you how that works in detail later. But for now, let's simply use an emulator, a virtual device. And I will pick a virtual Android device since that works on both Windows and Mac OS and Linux, whereas iOS devices, iOS simulators, iPhone simulators only work on Mac OS. Nonetheless, later down the course, I will also show you how to run this app on an iOS simulator, so you will also learn that. Now, to launch the app onto an Android emulator, we first of all need to create an emulator. And for that, you should start Android Studio, which you had to install anyways. And you should see that welcome screen there. Now in there, if you click on Configure, you should have the option to choose the AVD Manager. If you don't have that option here, you can open an existing Android Studio project and there simply navigate to the Flutter project you just created. So that's the Flutter project I created with Flutter Create. And in there, choose your Android folder as an Android project, because that is a real Android project that's part of your Flutter project, your Flutter app. Now, once this opens, you could write code here, Android code, which we certainly don't want to do. We want to write Flutter and Dart code and get an Android app automatically. I only opened this because here, under Tools, once this initialization here finished, which will take a couple of seconds, you'll also find that AVD Manager. So in case you didn't see that on the welcome screen, well then, you can go here to Tools and find the AVD Manager here. So you should find it in either of the 2 places. If you find it in neither of these places, you should try to reinstall the Android SDK and possibly the entire Android Studio. But once you found it and you open it, you should see a screen that looks something like this. Here I already got a couple of virtual devices. You might not have them yet. And you can simply create a new one with the button here in the lower left corner if you click on Create Virtual Device. Now in here, you can create different virtual devices, and we'll use a phone in this course for testing. And you have different blueprints here. For example, you can create a Pixel 2 or Pixel 3 device. You got other blueprints here. Also depends on the point of time you're watching this. You got really old or small devices as well, which we'll also use for testing later to see if our app works well on these devices as well. But for the moment, I'll go with the Pixel 2, and I would recommend that you also pick an image where you have this image here next to Play Store, this play button style here. Because if you have that icon here, that means that this image actually comes with certain extra services installed, which make development with things like Google Maps and so on easier, or which makes testing these features easier, and that will help us later down the course. However, you could also launch a new simulator with that feature once we need it and go with a different one for now. Nonetheless, I will go with the Pixel 2 here and click Next thereafter. Now, you can install, and you should install, a system image, which is basically the Android version that runs on the device. Now, I would recommend that you use the latest stable version here. Now, I could use Android Q here, and when you're viewing this, this might already be the latest version. But right now, when I'm recording this video here, this is the latest Android version that is available, the latest stable Android version. And I don't want to develop for an unstable or under development version where certain features might not work, and therefore I'll use this. Now, if you don't have that already, you might need to simply download this image first by clicking that download button. So choose that latest stable version here and click Next again. And now you can give this emulator a name if you want to. I'll stick to the default. And all the default settings here should be fine. You could configure some advanced things, but only do that if you really know what you're doing. I will instead go with all the defaults and then click Finish. And now this creates this new virtual device, adds it to the list here, and now you can always launch it here by clicking that play button. So that's exactly what I'll do here. I'll click that play button here, and this will bring up that new virtual device, which is now booting up here. This is the virtual device on which we will now run our app as soon as it is done booting up. Here we go. This just finished booting. And now if we go back here into our project, we can run this Flutter app on this device. Now for running this, we got a couple of options. You can open up the terminal in here by going to your menu here and clicking on New Terminal. And this is now your normal system terminal or command prompt just running inside of Visual Studio Code. And it automatically navigated into this project folder, so you don't have to do this manually with the cd command. Now here you can run Flutter run, and it will run your app, and it should automatically find this application here. You could absolutely do that, but with the help of this IDE and the Flutter extension which we installed in the first course section, we got an even more convenient way of running our app. You can go to Debug here, and now you have two options of starting your app. You can start it in debugging mode, or either by clicking here or by using this shortcut here. And this is something I'll show you later in a separate module where I will show you how you can debug your Flutter application and find and fix errors. You can also run it without debugging, which is a bit faster, because with debugging, a lot of extra features get added to your app, so to say, for debugging only. And if you run it in non-debug mode, you simply have a bit of a faster app, which is a bit nicer for normal development. That can be run by clicking here or using this shortcut. And if you click this, it should also automatically spot your device. However, first of all, you have to choose, at least if you have multiple different extensions installed, with which environment you want to run your code, and that would be Dart and Flutter here, so choose that if you are prompted. And now it will auto-detect the emulator and launch this application that we have in this folder here on that device. So, as you can see here in the bottom right, it's now building the project with the help of Android Studio and the Android SDK. And here, the top right, you have that control bar, which allows you to control the execution of this app. You can always stop it by clicking that red stop button. You can reload the app, restart the app on the device with that green refresh icon. You can hot reload with that flash, and hot reload means that changes that you made are added to the already running application, which is a really cool feature Flutter supports for development, makes development much faster because you don't have to restart your app all the time. You can also pause if you want, and you can then, these buttons are helpful for debugging later. So that's the control panel we got here. And the build process here takes a couple of seconds up to minutes. The first time you run this, subsequent reloads, when you change something in code and you want to see that in the device or on the device, that will be much faster. So it's just that first load, which takes a while. So let's wait for this first launch to finish here. In the meantime, let me also mention that it probably automatically switched here to the debug console. So not the terminal anymore, but the debug console. And that is the console where you will see all the output whilst the app is running. So any errors will be shown here, but also some system messages which you might want to print will also be shown here. And we'll work with this quite a bit to fix errors we might be getting or to see a certain output to validate that everything is working correctly in our application. So here it's now starting up. These are all default log messages which we're seeing here. And you should then see your app run on that emulator as I do it here. And you then can press this button here in the bottom right corner to, well, interact with your application. Now, the first time it's loaded, the first few clicks might be a bit slow here, but thereafter you should be back to normal interaction speed. So this is the Flutter app which we just created running on that emulator. And this is the code or the project in which we'll work on the code. Speaking of that, let's now walk through all the folders and files we have here and understand what they're doing. So we got quite a lot of folders and files here. Now, a lot of the files you see here are only there for configuration, and a lot of the folders here also don't need to be touched by you. But let me explain what each folder and file does. Let's go from top to bottom. The idea folder here holds some configuration for Android Studio. It doesn't really matter for us here because we're not working with Android Studio, and you don't need to change anything in here. VS Code is a folder you might not have. I have it here because I added some extra configuration for this project. I set the zoom level so that you can see my code. And anything you do configure for your VS Code, your Visual Studio Code project here would end up in such a config file. And you don't need that if you don't have any special development options here. The Android folder is super important. It holds a complete Android project, as you could also create it without Flutter. This is in the end the project which the Flutter SDK will use to kind of merge with your Flutter code, you could say. So when your Flutter code gets compiled to native code, it will basically get injected into this Android project, you could say. And that is the Android project which later will be built into a real Android app, or later actually is the wrong word, which already got built into this Android app we're seeing here. So this is in the end a normal Android project with your compiled Flutter code. And you don't need to change anything in here, or very rarely, and I will mention when you do need to change anything here. For the most part, for the most time, this is a passive folder which will be used by Flutter, and therefore it's super important, but not a folder you work on. The build folder is also very important. In the end, this holds the output of your Flutter application. In this case here, also some Android or Java files. And this folder is generated and managed by the Flutter SDK. You shouldn't change anything in there. That will all be done automatically by the Flutter SDK when you are developing or when you are building your app for deployment, which we will do at the end of the course. And therefore, this is also a passive folder. So thus far, no folder in which we would work. It's the same for the iOS folder. We had the Android folder with a full Android project, which is important for building an Android project, both for development and for production. And the iOS folder is simply the same for, well, iOS projects. Now, on Windows, you won't have that folder, because on Windows, unfortunately, you can't build iOS applications. That's not allowed by Apple. On macOS, you will have it, and this holds a normal Xcode project. Xcode is the development environment of macOS for iOS apps, and just as with the Android folder, this is a folder where you really won't work in too much. There are some occasions where we will do some work in here, but I will mention when this is the case. For the most part, this is a passive folder which gets kind of merged with your Flutter code in the end, and which will all be managed by the Flutter SDK to get iOS applications both for development and testing, as well as for the real application in the end, which you deploy. The lib folder is now the important folder for us. Lib stands for library, and that is the folder where we will do 99% of our work. It is the folder where we will add all our Dart files. Dart is the programming language Flutter uses to write the code for our Flutter application. So this is the folder where we will add files and where we will write code in. This is a super important folder for us. The test folder is a folder which won't be too important for us here. It allows us to write tests for our application, automated tests. So basically code that runs our code and tests it for certain things. Certainly important once you're a bit of a more advanced Dart and Flutter developer, but not important for us right now, and therefore we can safely ignore this. Git ignore is a folder that helps you when you're using Git, which is a source code management tool. It allows you to create snapshots of your code, save them, and you can go back to them at a later point of time if you messed up something or if you wanna change something. It is not a tool you have to use, but often during development, Git can be really useful. And after this lecture, you find a short text lecture on Git. Using it is totally optional, but if you want to use it, if that sounds interesting to you, that lecture will help you get started with it, and then you can use it if you want to use it. The metadata file is not really a file we will work in. It will be managed automatically by Flutter. And in the end, the Flutter tool simply saves some information in here, which it needs to well, build our application correctly and so on. The same is true for the .packages file. It's not a file we'll do any work in. This is generated automatically by the Flutter SDK. And in the end, this also just manages some internal dependencies, some packages this project needs, and it is fully managed automatically. You should not delete it, but you also shouldn't work in it. This file here, this .iml file, which has your project name as a name, is also a file where we will not work in. It's also managed automatically by the Flutter SDK to, again, manage some internal dependencies and some settings for this project, you could say. And it's not a file which we will change. Now, the pubspec.log file is also not a file we'll work in, and it becomes clearer once we understand the pubspec.yaml file, which is a file in which we will work. This is a file that allows you to mostly manage the dependencies of your project. Now, what does this mean? This means that here you can configure which other third-party packages your project might be using. You can also configure some other things in here, like for example, fonts you want to use or images you want to use in your application, and we'll use all these features. We'll work with third-party packages and we'll use fonts and images, and therefore I will show you how to work with this file and how to change it to include new fonts or new images. I will show you all of that step by step. Basically what you have here is code written in YAML, which is a certain format for structuring text files, where you use indentation to express how code works together. And here, for example, we're right now specifying with which Dart version this works, which version our application should have, also which other third-party packages we might be using, like here the Cupertino icons, which allows us to use certain iOS styled icons in the application, and we'll add other third-party packages throughout this course here. So this is basically a config file that allows us to configure how our application works or which external dependencies it has. For the moment, we don't need to change anything here. The pubspec.log file, in the end, is a file that is generated automatically based on your .yaml file here, and this simply holds more details than about all the dependencies you have, and it is required by Flutter, but it's not a file you will work in. In the end, as I said, it will be generated automatically. We will only work in the YAML file. Well, and the README file is an automatically generated README file, which, well, we can ignore. It holds some information about our project, and you could change this here if you were sharing your project with other developers and you want to give them some information. So that was a thorough walkthrough through all the folders and files. The core takeaway is that we will work in the lib folder and sometimes with that pubspec.yaml file, and we can basically ignore all other files and folders. With that, it's time to really dive into the code, and for that, let's look into the only Dart file we have at the moment in our lib folder. It's the main.dart file, and since this is the only Dart file we have right now, and since I mentioned that this is the folder in which we will write our entire application in the end, this has to be the file that is responsible for giving us the output we're seeing here, so for giving us this application. And indeed, that is the case. This single file holds all the code that renders this application onto the screen. And how does it do that? Because overall, this is a pretty lean file. It doesn't have that much code. All these green lines here with the double slashes at the beginning are just comments. So this is not even code that does something. It's just there for you to explain what happens thereafter. So in the end, this is a really lean file. What is this file doing here? We will rewrite this file to create an application from scratch, but before we do that, I want to briefly walk you through it so that you get an understanding, a basic understanding of how such a Flutter application works and what Flutter does for you. Flutter, as you already learned or as I already mentioned, is both a tool set and a framework, a programming framework for the Dart language. And in the end, a Flutter app is an application where you, the developer, build a UI by adding widgets. Widgets are components, the building blocks of your user interface. Like this button here in the bottom right corner, that would be a widget. The text here, that would be a widget. The app bar here at the top and the title in there, that would be widgets. And that's what you can see in the code here. Even if we don't understand all of that code, if we scroll down a little bit here to this build method in that my homepage state thing, which is totally unclear for now, but if we scroll down there, we can identify things like app bar or things like text and another text or things like a floating action button. And even if you don't really understand Dart and Flutter, it probably makes sense that this floating action button is kind of related to that floating button we have here in the bottom right corner. And the two text pieces we have here, text and text, where we see you have pushed the button this many times, that seems to be responsible for giving us this text here in the middle. And indeed, that is how this works. These are widgets which we didn't create ourselves, but which are built into Flutter, which ship with the Flutter framework, which we can use to put some text onto the screen or to add a button to the screen. And of course, we got way more widgets than these two different kinds of widgets. We got widgets for different kinds of buttons, for drop-downs, for images, for lists which we can scroll, for so many things. And that is how Flutter works. You work with these built-in widgets and you build your user interface based on them. And you can configure all these widgets to change their colors, or for example here, to change the text size. And you can also build your own widgets, which take these built-in widgets and group them together to build a brand new custom widget, which you can then put somewhere. For example, you could be combining this smaller and this bigger text, and then have your My Custom Output widget, which always prints or draws this smaller and bigger text on the screen if you would need this combination in other places of your app too. And we'll dive into all of that throughout the course, and I will explain Dart and how Flutter works and how you create such widgets whilst we are diving into that, no worries. Here in this starting code, we can already see that here we seem to be doing something with a widget, so maybe this is code that does create a custom widget, and indeed we're doing that here. But again, I think it makes more sense and it's easier to understand this if we do that step by step. And for that, let's actually select the entire code in the main.dart file and delete it. Now, why am I doing that? Because I want to create a complete app with you from scratch. I could just give you the instructions on, okay, now add this, now let's do that. And you would have a working application, but you would learn nothing about how it works. And it's super important to understand how it works and why you write which code, not only to learn Dart, but also to learn how Flutter works. And that is what you need to build your own Flutter apps. Because otherwise you can only build exactly the same app I show you, but I want you to be able to build any app. And for that, you need to learn it from scratch. So let's remove all that code in main Dart. Let's save the file. It now automatically rebuilds the app and syncs it back, and therefore this now crashes because we're not starting anything here, and we get an error here at the bottom. And that is all right. We will now write our own code here. Now, with our main.dart file now being totally empty, I will first of all walk through some programming and Dart fundamentals before we continue rebuilding our app from scratch. Now, if you already are a more experienced developer, if you worked with JavaScript or Java or C#, then you will already know a lot of the things I'm going to explain. Still, there will be some Dart specifics, and therefore I would recommend that you don't skip this lecture, but instead maybe just ramp up that playback speed if it's boring to you. If you're brand new to programming or you're never programmed before, well, then you should definitely follow along. Now, for these basics, we'll not stay here in our project at the moment because we couldn't really execute that code here since we have no working app at the moment. But instead, you can Google for Dartpad, and that is a web-based playground that allows you to write some Dart code and run it in the browser. And that's exactly what I have here. This is a little demo starting project which we start with, but we'll write our own code here in a second. So this is Dart code, not a Flutter app, just normal Dart code. You could also use Dart for web development. This is just some dummy Dart code where we see the output here on the right in the console, and it's perfect for learning the basics about Dart. Now, what do we have here? The overall thing we have here, this main thing, that is a so-called function. Functions are a crucial concept in pretty much any programming language you're going to learn. Functions are code snippets which you can execute multiple times and at any time you want. This function here is named main because the thing in front of the parentheses here is the so-called function name. The parentheses themselves are always required for every function you define, and they allow you to receive so-called arguments that would be input to your function. And this function simply doesn't take any arguments. Nonetheless, it needs these parentheses to turn it into a function. Then we have curly braces, the green ones here right now. Curly braces surround the so-called function body. That is the code which executes when this function gets called. And I will show you how to call a function in a second. Void here, that is a so-called type. Dart is a typed language, which simply means that everything in Dart has a type. Here, that is the type of data which this function returns. This function returns nothing, and therefore the return type is void. It's empty, so to say. Here we see another type in this strange for thing, to which I'll come back later. This would be the type of I. I holds a number, a so-called integer. But more on that in a second. Let's not learn too much at the same time. So this is a function called main. It has no arguments and it returns nothing and therefore has a return type of void. This is the function body. Main is a special function name. Generally, you can give your functions any name you want, but main is a special name because main is the entry point of a Dart application. Dart automatically calls the main function for you when the app starts. Therefore, in a Flutter app, when you add main in the main Dart file, which is also a special file for which Flutter will look for, when you add a function called main here, by adding parentheses and by adding void in front of it, this is the first function which Dart and Flutter will execute automatically when your app launches. So into this function, you need to put the code that basically kicks off that UI rendering work that brings something onto the screen. More on that in a second. So that's a function, and main is a special kind of function. Now, because it's a special kind of function, you probably also can create other functions, right? And you can. Let me first of all remove that code inside of the function. And let's add a new function above the main function. And I will name this add. or add numbers. That name is now totally up to you, but you should follow a naming convention, which is called camel case, where you have only one word, so no blank in between. That would actually be a syntax error. But you have one word, and if your word actually consists of multiple words, like this one, add and numbers, then all words should always start with a capital character, even right inside of the word. But the first word always starts with a lowercase character. So you have add numbers. If this would just be called add, then you would also start with a lowercase character. But any other word in there has an uppercase character. That's just a naming convention which we use in Dart and also in many other programming languages, which you should memorize and use so that when other developers see your code, they have an easier time understanding it. Now, as I mentioned, a function can take arguments, so input. Now, the main function didn't take any arguments, but let's say add numbers is a function which should hold some code to add two numbers. And therefore, this will now take two numbers as an input. So between the parentheses here, we can add num1 and num2. And just as the function name, these names are also up to you. You can name that whatever you want. And as you see here, you simply add commas as a separator between your different arguments in the list of arguments here. Now you also need a function body, and you add that by using curly braces. That simply tells Dart that in between the curly braces, you have the code that should execute when this function gets called. So when you instruct it to execute the code inside of add numbers. Now you do instruct Dart to execute this function by using its name, now in the main function, which is the code that first runs when the app starts. So in here, in main, you simply call add numbers by its name. And now here you also need to add parentheses. You always need to do this, even if the function takes no arguments. This function, however, does take arguments. So now between these parentheses, you add the concrete values, which will be passed to add numbers. So that num1 and num2 do have actual data with which they can do their work. So here we could add 1 and 2. Now, of course, this function doesn't do anything at the moment, though. I call it with 1 and 2 here, but we have no logic in there to really add these numbers. So what we can do in here is we can call num1 plus num2, and now we would add that. Now, we also need to add a semicolon. That's another thing in Dart. For every expression you have in your code, for every code line, you have to add a semicolon in the end. Exceptions from the rule are the definition of functions, where you don't add a semicolon after this curly brace here, but you do add it here for all the code inside of your functions, so to say. And in general, for all these block statements, as they are called, so these statements where you have code between curly braces, you don't add a semicolon after the curly braces, you only add semicolons after the expressions between curly braces. So here we have num1 plus num2. I added this semicolon here, but the problem we now have is we add two numbers here, and that would generally work, but we're not doing anything with the result of this operation. Now you could think that it should automatically be output here on the right. Well, let's see. Let's click run. What happens is that we have an empty output here on the right. So that's not really helpful. Now in programming, you always have to be very clear about what should happen, because the programming language, Dart in this case, does not make any assumptions. Why would it print it here? You don't tell it to do that, and therefore it doesn't do it. Now you can print the result by using the print function. Print is not a function we defined, it's a function that was that's built into Dart. And you can wrap num1 plus num2 with print, and if you now hit run, you will see 3 here on the right. So now this works. Now we're outputting the result of num1 plus num2. So this is our first little piece of Dart code, and yet we can improve that. For example, we don't use types here, but Dart is a strongly and a strictly typed programming language. That means that you have to be clear about which type of data your arguments are or this function returns. That is something which helps the Dart compiler to yell at you when you write code that violates that. If you don't assign your own types, which we'll do in a second, then Dart will assume that this is of the dynamic type, a type built into Dart, which, as the name suggests, doesn't tell too much about the type. It basically accepts any value, and therefore it won't really help you that much with checking that you're writing proper code. So if possible, you should avoid that dynamic type and assign explicit types when working with Dart. Now, there are a couple of built-in types in Dart. Everything in general is a so-called object, which is a data structure that has, some complex logic inside of it, possibly at least. And we'll create such objects later too. But there are certain special types of objects, you could say. There is text, for example, and you create text by using quotation marks. So here, if I type hello and I print this, please note the quotes. You can use single or double quotes, that doesn't matter, but you shouldn't mix them. So if you open it with a double quote, you also have to close it with a double quote. I will use single quotes in this course though. And this creates a so-called string data type. So this is a value which is of type string. Text simply is a string. If we now hit run here, we'll see hello being printed because, well, I'm printing this here, and therefore we see the output here. So text, strings, are one data type. Besides the text, for our numbers, we have so-called integers and we have floats or doubles. Integers are numbers without any decimal places, like 29 or 43 or -10. Floats or doubles are numbers with decimal places, like 29.99, -10.56, something like that. So here, these two numbers would actually be integers. Now, in this function here, we should be clear about the fact that this only works with integers. We do that by adding int in front of each argument. This tells Dart that num1 and num2 both have to be integers. So if I now run this, it will still work. But if I would pass 2.5 or 2.6 here, then we actually automatically get an error here in the bottom right corner that our argument of type double can't be assigned to a parameter. Parameter is basically a different word for argument of type int. And that is why Dart does use these types, because it allows us to write cleaner and better code. If we know that this function should only work with integers, then we should define it as such. And if we then later, somewhere else in our code, accidentally call that with a double, we get an error. And we get that error before we ship our code into the Flutter app, so into the app stores, for example. And that is, of course, good. We want to catch and fix errors whilst we are developing. So here, we would get an error. Now we have two possible fixes. Either we fix our code such that we only call that with an integer value, or if we see, no, this should actually also work with doubles. Well, in such a case, we could of course change that and accept doubles as inputs. And now if we run this code would work again, and it would output a double here with a decimal place, because now we allow doubles here. Now, of course, you could think, why don't we always use a double then? It's more flexible than an int. Well, sometimes you have situations where you really only want to have numbers without decimal places. Let's say you have some counter, which only increments by 1 at a time. Well, then you should be clear about that being an int so that you can't accidentally run the code with an invalid value with a decimal value. Now, side note, we could have also used num here, which is the overarching number type, and that would allow both ints and doubles. But as you see, if we use double here, this also allows us to call this with a 1, because this implicitly is converted to a double. So we can really use double here if you want to allow both double and int. So this works, and with that we learned about text, so-called strings, and about numbers where we have integers and doubles. And that all can be used as types which we, for example, pass to a function. Now this function, however, might also return something, or it might not. And you should therefore also always add a type information about what type of data this function returns. Now this function prints the result, and therefore it does not return anything to the place where we call it. Hence the correct type here would be void. Void is a special type in Dart which basically means nothing. This function returns nothing. Now why is that important? Because if we now, for example, wanted to print the result of add numbers here, like this, then we get an error that the expression here has a type of void and therefore can't be printed. We can't print the result of us calling add numbers because add numbers doesn't return anything. Sure, it prints something, but that is done from inside the function. Here, we would want to print what this function gives back, and this function doesn't give us anything back. However, we could actually make sure that it does. Instead of printing in here, let me comment this out, which you can do by adding 2 forward slashes. Now this code won't be considered. And this is a common pattern, by the way, that you comment out code which you don't want to run, but maybe you want to use it later, so you don't want to delete it, but you simply comment it out so that it's still there but not executed. And now we could return something here by using a special keyword in Dart, which is return. Now this is a keyword which tells Dart that this will now return something to the place where you called the function. So here I return num1 plus num2. And now what this does is, now here, this is valid code, because now here we print the result of add numbers, and the result is what add numbers returns, and here we return 2 numbers. If I now run this, we get an error though, that we can't return a value because this expression has a return type of void. And again, this is a good thing. We defined that add numbers doesn't return anything, that it returns nothing, and yet we do return something here. Now the solution is to change the return type here. And here we can change this to double, because since we add 2 doubles, we will always return a double. So now I'm returning a double here. And now if I call this function and I run this, now we don't get an error and we see 3.6 here instead. And this is how you should write Dart code. You should use these types. You have the core types of string and numbers, where we have integers and doubles. We have a couple of other types too, which we'll learn about throughout this course. And this is a core concept of Dart, just as functions are a core concept of Dart. Because now we can call add numbers here as often as we want. So I can also call add numbers here with 2 ones, for example. And this is a really useful pattern and feature which you have in basically any programming language, because it allows you to write code once, this logic for adding code, and you can call it with different inputs as often as you want. And therefore functions are a really important concept in programming and also in Dart. We had a first look at some programming basics, functions and types, or some of the important types for the moment. But there is more in programming, and there are 2 other features which we need to understand before we can go back to our main Dart file. The first feature is the feature or the idea of variables. Thus far, what I always did in here is I always immediately printed the result of add numbers. Of course, this is just some simple dummy code, and therefore this makes sense here. We basically just want to see what this yields us here. In reality, however, you often write programs where you also need to store the result of some calculation or some user input. You want to store it somewhere so that you can use it later. Now with store, I don't mean in a database, but in memory, because you need it later, a couple of code lines later in the same code. So we don't want to write it into a file or store it in a database. We just want to store it in memory so that when this code executes, we can take it and use it a couple of lines further down, for example. And we can store data with the help of so-called variables. Now let's say that first result here shouldn't be printed immediately, but instead I do want to store it in a variable. You create a variable by giving it any name you want, like first result. And the naming convention here is just the same as for functions. You use camel case, lowercase starting character, then only one word, and every word inside the word starts with a capital character. Now that's first result, and you assign a value to that so-called variable now with an equal sign. Now it's called variable because the data in there is variable. You can change it. Here I'm storing the result of add numbers in first result. I could reuse that and now also store that result in first result. So after the first line, the result of add numbers for 1 and 2.6 would be stored in here. After the second line here, the result of add number with 1 and 1 would be stored here. And the first result, so this result of this line here, would be dropped. We would store that result in the first result variable now. However, we have a syntax error here. And that means that Dart doesn't understand this. This is almost the right syntax, but to tell Dart that this is a variable, you need to add the var keyword here when you create that variable for the first time. So not in this line, where I then use it again, the same variable with the same name, but when you introduce it, then you need to add the var keyword to tell Dart that this is a variable. And now we can, for example, use that result, that first result, whoops, the name is first result, we can use that here in a separate line. Sometimes you even just use a variable to make your code easier to read so that you can split it across multiple lines. Sometimes you have some other code in between that you need to execute first, and then you want to use first result later. Maybe you even want to combine it with some other calculation that you add +1 to it. That would be possible too. First result simply holds the value returned by add numbers, and that number in our case is a double. So you can do anything with it, which you could do with any other double. So now if I run this, we print 3 here, because first result has the result of add numbers with 1 and 1 stored, which is 2. And then we add 1 to it. So we have 2 + 1, and we print that result, and therefore see 3 here. Variables are a core feature in Dart, and we'll see it a lot throughout this course. Now, besides that syntax, where I use var for creating it, you can also create it by adding the type of data which this variable will hold eventually. So in this case, we could also write double first result. However, Dart also has a feature called type inference. This means it's able to infer the type of data you'll store here by the value you have on the right side. Here, since I call add numbers, which returns a double, and which always returns a double, Dart is able to infer that first result will hold a double. And therefore, you don't have to tell Dart that this is the case. And actually, it's considered a better practice to then just use var. It would be a different thing if you created the variable like this, without assigning an initial value. That is possible too. The variable now exists, but it is uninitialized. And sometimes this is also something you need to do because you want to create a variable and at a later point of time you want to assign different values to it. In such a case, it is a good practice to tell Dart which kind of data will eventually end up in this variable. So then you should use the type here instead of var. In this case, that's a double. If we now run this, we see the same output as before, but now we created this a bit different and we are using double instead of var here. Now that's one of the important features which I wanted to mention. Another important feature is that Dart is a so-called object-oriented programming language. I did mention that everything in Dart is an object. So this number, this 1 here, is an object. Now, you would say it's a number, and that's true, but a number is just an object. Now, what is an object? Everything in Dart is basically a data structure with a lot of different information in it. Now, here the information is, of course, that it's 1, but there is some other metadata which Dart uses internally, you could say. Now, why do we actually start expressing our data structure as objects? Well, that is simply related to the real world. If we think about the real world, we work with objects there too, right? You have a car and you can drive that car, or your car has a certain amount of seats or a certain amount of horsepower. So we describe our real world with objects. And the idea simply is to bring that way of thinking into development, into programming, so that it's closer to the real world. So we work with objects in our program because, of course, typically with programs, like here where we're building apps, we also have things which we could describe as objects. For example, in a mobile app, we have a button. A button, of course, would be a valid object if you think about it like this. So that's why we call it object and where this idea of using objects comes from, why we group things into data structures that we call objects. That simply comes from the real world, and it should help you think about and reason about your program. And the core idea really just is that you can kind of bring the way you think about reality into how you think about your programs. That's the rough general idea. And how you work with objects will, of course, become very clear throughout this course because we work with objects all the time in there. Now, you can also create your own objects because sometimes you're not just working with a text or a number, but you have a more complex data structure which you want to express in your code. Let's say you have a person with a name and an age. Of course, we could create a variable here, string name. String, this is how you tell Dart that this will be of type string. Please note that unlike double, it starts with a capital character. That's just how it is. So you could have a string name and let's say a int age. That would be possible, and you could store values in there. And to you as a developer, it would of course be obvious that these two are related. However, for other developers it might not be, and even if it is clear, it's a bit annoying that you always have to work with these two separate variables. It would be nice if you could merge it into one variable. And that can be done with so-called objects. To create an object, you first of all need a blueprint for it that tells Dart how this object should look like. You do this with another core Dart feature, which you also see in other programming languages, which is a class. A class allows you to define a blueprint for, objects. A class needs to have a name, and that could be person. And here the naming convention is not to start with a lowercase character, but with an uppercase character. Then you add your class body with curly braces, just as you did it for the function. And still, this is no function, this is a class, it's a different thing. And in between that class, you can now define how that class, and therefore objects based on that class, should look like. Now, what does this mean? Well, for example, you can add variables in here. You can add a variable name and age if you wanted to. So what I basically had down there is now added in that class. And you can also give this default values just as we did it before. Now, if you have a variable in a class, this is also sometimes called a property. It's still a variable, it's just inside of a class, and therefore we give it that special name so that when I say we change this property, you know that we changed a variable inside of a class. A variable inside of a function, on the other hand, is called a variable. And we have these different terms so that when I say property, it's clear I'm referring to a variable in the class and not to a variable in the function. So here we have these two pieces of data now in our class. And it is worth mentioning that just like with normal variables in a function, if you are assigning a value, which I'm doing here with max and 30, then you should actually use var here as well instead of string and int. Now, I use string and int here because I'll change this later to not initialize it, but if you would leave it like this, if you plan on initializing a property with, an initial value, then you should also use var there instead of repeating the type. Repeating the type won't be an error, but it is considered a better practice to use var and let type inference of Dart do its job. And now down there in the main function, if we need such a person, we can create a variable, p1 or whatever you want to name it, and you create a new instance of this class, because the class is just a blueprint. The instance of the class is the concrete object with which you're working, by calling person like this. Now, if you have some other programming experience, you might be used to using the new keyword in front of that. New is required in some other programming languages to create a new object based on your own class. Now, that can be used in Dart too, but since Dart 2, which we use in this course, it's not required anymore, and therefore we just call person like this. So now we have person executed like a function actually, with parentheses here. And this will instantiate this class and store it in P1. And therefore, now if I print P1 here and I run this code, you actually see instance of person being printed here. Now, on this class, you can now conveniently access the data that's stored in here with the dot notation. So I can type P1 dot, and now I could choose name or age or a couple of other things which every class has in Dart, automatically added by Dart. But here I could print P1H, and if I now run this, we see 30 here. And that's what I meant. Now we grouped that data together, and we can create new persons by simply calling person again. We can also change that data on a person by accessing P2 name and changing that to menu, for example. And now if I would print P2 name down there, and I print P1 name up here, so for the two different persons I print the names, then you see that here on the right we print menu and max, because for the first person I didn't change it, and therefore we have that default. For the second person I did change it, and therefore here where I changed it, we changed it to menu. Down there when I print it, I print menu. This is how that works, and classes are a crucial feature in many programming languages, and they also are in Dart. Now there's more about classes and about Dart, which we'll learn throughout this course. I don't want to bore you now with a 1 hour long introduction to Dart. I find it more interesting to learn Dart whilst we are learning Flutter. But these are some basics which I needed to get out of the way so that we now can continue working on our main Dart file and understand what's going on in there. So back in our main Dart file, we have that main function. As you know, this is a function. It returns nothing, takes no arguments, and right now we also have nothing in the function body. Now, as you learned, main is a function which automatically is executed when the app starts by Flutter and Dart, because it's in the main.dart file, which you therefore also shouldn't rename. Now, in here, we need to add some code that actually brings something onto the screen. For that, it's important to understand that on the screen, we basically see a bunch of widgets. Flutter is about widgets. It's so important to understand this. Every Flutter app you're building is just a bunch of widgets, and widgets are the UI building blocks you see on the screen. Things like the app bar, maybe some image, maybe a list with list items. And as you can see here, for example, widgets also often contain other widgets, like that list which has list items. So you compose your Flutter app as that tree of widgets, which I already mentioned before, which has a root widget, which is your entire app, and in there you have your other widgets, which yet might hold other widgets thereafter. Even your entire page, so the entire thing that holds all the widgets on your page, on your screen, is a widget in Flutter. So since everything in Flutter is a widget, and since the entire app is a widget, we probably need to create such an app widget, which then has other widgets to see something on the screen. And that's 100% correct. Now, to create such a widget, we need to create a class, because a widget is a special type of object, so to say. And you learned that you need classes to create objects. So let's add a class here, and you can give it any name you want, and I will name it my app, following that naming convention, which is called Pascal case, where you have a capital starting character, and then every word inside the word also starts with a capital starting character. No blanks in between, no underscores, no dashes. Your classes should be named like this. The concrete name, if this is my app, my cool app, or something else, is totally up to you. Now this would be a class, but as you probably can imagine, a widget that really can be seen on the screen is not that trivial to create, because in the end, the pixels on the screen need to be controlled. Now, thankfully, we don't have to write that logic on our own. Flutter does all of that behind the scenes. And therefore, our class here now uses a feature called inheritance. That means that it builds up on a base class, gets all the features of that base class, and only adds new features to it. We do inherit by adding the extends keyword here after the class name before the curly braces. That informs Dart that this class will be based on some other class, and you can only extend one class at a time. Now, the class I do want to extend here is not a class we will write, but a class provided by Flutter. Now, of course, in our whole project here, we only have one Dart file in the lib folder, and that's our own Dart file. But please remember that we have that pubspec file where we define which dependencies our application has, or our Dart project has. And here we have one dependency, and that's Flutter, the Flutter framework. Now, the files of that framework are not stored here in that project. Instead, they're stored somewhere else on your machine, typically in your user folder somewhere. But you can import from these files because the connection is established with the help of this entry in the pubspec.yaml file. So now in the main Dart file, we can inform Dart that we want to reach out to some other file, in this case from the Flutter framework, that gives us the class which we would want to extend here. We do that by adding the import keyword. This tells Dart, hey, I want some functionality which is not in this file, but which is in some other file. Now you can point at your own files there too, and we'll do that later, but you can also point at third-party packages which are part of your project. You do this by adding package : and then the name of the package, which in this case is Flutter. And then a lot of packages have a lot of files that make up this package. So you can add a slash here and then point at a concrete file. In this case, this would be material.dart. That's one of the files the Flutter framework exposes to you. It has a lot of built-in widgets following the material theming. And later you will also learn how to make your apps look good on iOS, but material themes also work on iOS. And besides these pre-styled material looking widgets, the material Dart file also has a base class which allows you to create your own widgets. And that's the stateless widget class. So we extend stateless widget here, and this now turns our class into a class which can be used as a widget by Flutter. However, now we got a new error here, that it's missing a correct implementation of statelessWidget.build. Now what does this mean? Now .build signals that this seems to be some property, so a variable, which is part of that class. Or maybe it's a function that's part of the class. We haven't had a look at this before, but besides variables, you can also have functions inside classes. Now, variables inside of classes would be called properties. Functions inside of classes are called methods. So we have to add a special method here. Now, how do I know that it's a method and not a property? It's just something you have to memorize, one of the very few things you have to memorize. So here, this is a method which is missing. So let's add build here. Since it's a method and therefore effectively a function, we can add parentheses here. We have to add them and curly braces to mark the body of that function. Now functions can take arguments, and if we hover over this to read the error here, we actually see that it isn't a valid override, whatever that means, of the build method, and indeed it should take a build context as an argument. So let's add an argument here. You can name it CTX or context, whatever you want. It's a special type of object, a special object, which will be passed into the build method automatically, because you will never call that method. Flutter will call it whenever it needs to draw something onto the screen. And context is an object into which I'll dive deeper later. In the end, it holds some meta information about our app and about this widget we're building. But for now, let's just add it. And let's also add a type annotation. The type is build context, which is in the end a class that is also defined in material Dart, which is why we can use it here. So build context is a special object type provided by Flutter in the material Dart file, and this context object is of that type, and we get it automatically by Flutter. Now build is also a function or a method which returns something. It needs to return a widget because you work with the widgets in Flutter. Your entire app is a widget. We're trying to build an app here. The build function is what Dart and Flutter will call in the end when they try to draw something onto the screen, and therefore the build method here needs to return a widget. Now, just like build context, widget is in the end a class, and every class automatically then also is a type, which is provided by material Dart. Now we need to return such a widget here inside of my app. And there is a special widget which we should return, and that's the material app widget. Also provided by material Dart. That's a widget provided by the Flutter team, which does some base setup to turn your combination of widgets into a real app that can be rendered. It does a lot of heavy lifting behind the scenes, you could say. Material app also takes a couple of arguments. As you can see, it's a pretty long list, and all these arguments are so-called named arguments. Now, thus far, we only saw something which are positional arguments, which means the build method takes an argument, context, and because it takes one argument, we accept it like this by giving it a name in the end, and the first and only argument which will be passed into build when Flutter calls the build method will be passed into context or will be available as context. In our example here, we had two positional arguments in add numbers, num1 and num2, and what we passed in as a first argument here when we called the function would end up in num1. What we passed in as the second argument here would end up in num2. Now, Material App uses so-called named arguments, which means we don't pass in data in order here, but because that has a lot of possible arguments we can set, which are all optional in the end, we target the argument by its name. And there, for the moment, we only need the home argument. Home is basically the core widget which Flutter will bring onto the screen when this entire app is mounted to the screen. And here we could use a text widget, which is yet another widget built into Flutter. And you will work a lot with these built-in widgets because thankfully you will rarely have to reinvent the wheel and all the core UI building blocks you need in modern apps already exist. Text takes a string, you learned about that data type, which you can create with single or double quotes, as an input, and here we could print hello. So now we have that Material App widget, which is provided by Material Dart, with that named argument, which, in case it's not entirely clear, is something we'll also use throughout this course, and we'll also create our own functions that take named arguments so that this becomes clearer. And then here we also have hello, which we pass to text. Now, as a side note, if you're wondering whether Material App is a function or a class, it is a class, and yet we can pass data to it with a feature called a constructor, but that's also something I'll come back to later. For now, let's just accept that this is some code which will create something which can be treated as an app, because Material App does a lot of heavy lifting behind the scenes, and which should also output some code. Now we just need to wire up that main function with this class here. To wire these two things up and see something on the screen, in main we need to execute some code which takes our widget here and draws it to the screen. And for that, there is another function provided by Material Dart, and that is called run app. Now, run app is a normal function, but not written by us, but written by the Flutter team and exposed in that material.dart file. So as you can probably tell, importing that Material.dart file unlocks a lot of core features which we need to build an app. Now, run app does what the name suggests. It basically runs our Flutter app once the Android app booted up, or the iOS app, whatever it is. And that simply means it now tries to take our widget tree and draw something onto the screen that's based on that tree. So here it would draw that text here onto the screen. For that, however, we need to tell runapp what our core widget is. And that's our myApp widget, of course. So here we pass myApp, and we execute this like a function by adding parentheses. That is important. Don't forget these parentheses. Otherwise, you would use it as a type, but this does not need a type, but a concrete object, and you instantiate the object based on a class by adding parentheses. That's also what we did here when we created our persons, right? Now, runapp does just that. It runs the app, takes our widgets, and runs that. To be precise, what it does with our widget is, of course, it creates that. We're calling the constructor after all, so such a widget object is getting created. And then runapp does take this object, which we pass to it in the end here, which we pass as an argument to runapp. We pass the finished object, the finished widget object here after all, by calling the constructor. Runapp takes that and calls the build method for us. That's in the end what it does. And that's how build gets triggered here for the first time, and how this, construction of our app then continues, and how something gets rendered onto the screen. And therefore, if we now save that file and we go to debug and again start this without debugging, we should now be able to bring this back onto the emulator and see a very basic and ugly application there, which somewhere outputs hello. And as you can also tell, therefore, is that we basically only care about the user interface and what we see there. And that's the cool thing. We don't have to care about rendering individual pixels or managing the life cycle of the app, starting it up and listening to events on the home screen of our Android device. We do none of that. What we do here is we control what ends up on the screen. So now this is getting built into an APK file here for my Android emulator. Once it's done, it launches up and we see this. Now, this is the expected result. We haven't defined any styling. We haven't defined anything that will lead to something more beautiful being rendered, but we see hello here. And that therefore proves that this basic code works, that we created our own widget class, which is a normal class with some extra features provided by a stateless widget, and that this was accepted by the main function to run our app with the help of, well, run app. With this first output on the screen, before we dig deeper into this app and build something more beautiful, let me take a step back and go back to Dart, because it's so important that you also understand Dart whilst we are working on this. For one, let me go back to Material App and Text. I mentioned that these are not functions, but classes. And yet, I pass some data to them, right? I pass the hello string to text, and I even have this more strange looking home : thing here for Material App. Let's go back to our little Dart example here on Dartpad, which we started working on earlier. There we also have person, and person has some default values here. Now we can override these defaults, but what if our class should be a bit more generic? For example, for a person, it doesn't really make sense that the default would be max and 30. If we're, for example, building an application where users can sign up, then why would we assume that the average user is named Max? That does not make any sense. So you might want a setup where you have no initial values, but instead, when this class gets created, we can pass the initial values here between the parentheses, so that I have Max and 30 here, and I have menu and 31 here. And then I don't need to overwrite my name down there. That would be nice, but right now it's not supported. We can support it by adding a so-called constructor to this class. A constructor is a function inside of a class, and therefore we could also call it a method, because functions inside of classes are methods. It's just a different name. It's a function inside of a class which is different to other functions inside of the class in that it always executes only once when we create a new object based on the class, which happens when we call a class like this. You add a constructor by repeating the name of the class. So in this case, person, like that. In other programming languages, you would write constructor, for example, but in Dart, it's really just the name repeated. You add parentheses, like for a normal function, and then you add curly braces, which holds the code that should run when this class gets created. Now here, you can accept arguments, like name and like age, or input name and input age, to avoid confusion with the names we chose up there. Though you could use the same names, because Dart also has a feature called scoping, which means that if you had the same names as up here in the arguments, it would not overwrite this or anything like that. Instead, it would simply just create new variables inside of person. It always creates new variables for every argument you get, and these variables could have the same name and they would not clash, because Dart would, behind the scenes, manage that separation between your class level variables and your function or constructor level variables. But here, to not confuse you, I chose different names. And now inside of the constructor body, we could refer to our name up here by just typing name and assigning input name as a value, and the same for the age. Now, by the way, if you had the same name, so let's say I had age here, then of course Dart would not be able to figure out if we mean the age up here or the age here when we're using age in the body of the constructor, and therefore it gives us a special this keyword, which refers to the class itself, and with this.age we can tell Dart that here I want to refer to the class level age variable, whereas without this I want to refer to the function or constructor level variable. So this is the code we can use. We could do the same for name, just want to show the two different options. And now with that, we have a constructor which allows us to create our object, if I run this, with different default values down there, which is of course pretty convenient and a feature you'll use quite a lot. That's also the feature text uses here, which accepts a string which we can pass to the constructor, which we will use to output something, because having a default text in the text class would not make that much sense. Now, besides using this syntax here, you can also use named arguments. And that means that you simply wrap that here in curly braces. Now what this does is, it means that now these arguments are all optional, and therefore of course you should write code that can live with no values being provided, and that you do target them by name when you're creating your data. So here you would then target a argument by name by repeating its name here when you create an instance based on that object, like this: input name colon, and also age colon. That concept of named arguments is also not only available for constructors, but also for normal functions. Now if we repeat this, it still works. Now why would I use named arguments? It's especially great for constructors or functions that take a lot of arguments, because if you have normal, positional, so non-named arguments, you have to remember which argument goes into which position, that the name is the first and the age is the second argument. Now obviously for a constructor with 2 arguments that is doable, but if you had 10 arguments it would be more difficult. By using named arguments, you can simply use the name to assign it, and you can also mix and match the order here if you wanted to. So here I could first assign the age and then the name, because I'm targeting it with the name, right? So with the name of the argument, and therefore the order doesn't matter here. For positional arguments, as the name suggests, it does matter. Now, since I mentioned that all named arguments automatically are also optional, you also should either define default values here with an equal sign right in here in the argument list. That's something you can do. Now, in case you don't provide an age, the default value would be used, and that can of course be useful to avoid that your code breaks. Or you add a special annotation, the @required annotation, which will ensure that the compiler yells at you if you don't provide a value for that named argument. So with that, you turn that optional named argument back into a required one. Now, side note, required is not a feature built into Dart, and therefore here I get an error that Dart doesn't understand what @required means, but it will be built into Flutter, so here we will be able to use that. And with that, it's hopefully a bit clearer what named arguments are and what constructors are. Now, one last side note, if I remove @required here, one last side note because it is important, let me add the default value again. Sometimes this setup here, where you get certain data and you want to assign it to variables of your class, is so common that you don't have to write all that code. Instead, you can get rid of your constructor body, add a semicolon after it, and now just make sure that you use your variable or your property names up here, so that you use name and age. And now, here, you can simply target this age, and here also this name, now without a type assignment because we got the types here already. And this is a shortcut understood by Dart, which tells Dart, okay, what we receive as a name argument will be stored in a name property. What I receive as an age argument will be stored in the age property. And now, since I renamed this to name again, because now the names here have to match, since I renamed this to name, I also have to rename it down there, of course. And now this works again, and it's of course shorter than writing that extra function body for the constructor. So we got our first lines of code that lead to this application, which, well, obviously is not the kind of application we would ship to an app store. Yet, before we dive deeper into building a bit more beautiful of an application, let me briefly sum up what we learned thus far. And yes, it's a repetition, but it's so important and crucial that you understand how this works and what we did. So we have this main Dart file with the main function, and this main function is automatically executed when our app launches. That is important. In there we call runApp, which is a function provided by the Flutter team in the material Dart package, which we are importing up here. We can import the Flutter package and there the material file because we have the connection in the pubspec.yaml file. Later in the course, we will also add other third-party packages to add even more features which we don't have to build ourselves. So with that, we call runApp, and runApp is a function which does all the heavy lifting behind the scenes to take a widget we created and draw it onto the screen. To be precise, what it in the end does is it calls the build method in our widget. Because, and that's an important rule now, every widget in Flutter needs to extend stateless widget or stateful widget, into which I'll dive later. So it needs to extend one of these two base widget classes, and each of these classes will force you to add a build method, because in the end Flutter will always call that build method for you, so you don't call it, Flutter calls it when it is prompted to draw something onto the screen. RunApp prompts Flutter or tells Flutter to draw something onto the screen, and therefore Flutter will do a lot of stuff, but also call the build method of the widget you passed to runApp. The build method is always responsible for returning a new widget, which should be drawn onto the screen. And therefore, at some point of time, you have to end up with returning one of the base widgets Flutter ships with, because these then will have the nitty-gritty details for really controlling the pixels, so to say. Of course, they do a bit more than that, but in a nutshell, that is how you can think about it. So widgets need to return widgets, and therefore at some point of time, you will end up returning these base widgets, and in the end, you will build your entire user interface with these base widgets, because there are base widgets for everything you could possibly want to build, and you will learn how to work with them and how to find the right widget for which job. You will learn all of that throughout the course. Now, the build method turns this context argument. Now, since Flutter calls build for you, it's Flutter's job to provide the value for context. So you don't have to worry about that. You only have to accept it here, since you are writing that build method in this place here. Context, as I mentioned, will be an object of type build context, so using the build context blueprint, which is also provided by Flutter, which holds some metadata about this widget, its position in the widget tree, and your overall application, so to say. This is what's happening here. Now, in the myApp widget build method here, we have the material app, which I'm returning, which in turn is a widget, but now it's a widget provided by the Flutter team. This uses a named argument, home, and as a value for this named argument, I pass yet another widget, the text widget, which is also provided by the Flutter package, and this uses a so-called positional argument. So both text and hello are arguments. Text is an argument to material app for the home argument, and hello is an argument to the text widget. Now, both these widgets, material app and text, are in the end Dart classes. Every widget is just a Dart class, which in the end has a build method. That's something you can remember. This is what's happening here. It's also worth pointing out that by adding parentheses after your class name, like we're doing it here, we're instantiating that class, so we're creating a concrete object of that class. Here of the myApp widget, we're creating an object of that, and we're passing that to runApp, which then passes it on to Flutter, so to say. And that is what in the end brings this here onto the screen. Now, with all of that, we only touched on some of the core fundamentals of the Dart language, of course. There is more than named arguments, variables, methods, and so on, but we will learn all of that step by step and not upfront in front of the course. Instead, let's rather dive a bit deeper now and make sure that we see something more beautiful on the screen. However, before we do that, there's one important annotation which I want to add to this build method, and that is @override. Now, technically, that's not required. Our app worked without that. This is a so-called decorator, and it's a decorator which, you probably guessed it, is also provided by Dart and Flutter. So override is actually provided by Dart, not by Flutter. But there are other decorators like that @required thing, which I showed you earlier, which would be provided by Flutter. Now, what does this decorator thing do, though? It worked without it. Yes, it works without it. It's just there to make our code a bit clearer and a bit cleaner. This makes it really clear that we are deliberately overriding the build method, which is provided by stateless widget. It exists there, but we override it with our own implementation. And actually, stateless widget forces us to override it. We don't have the option of not overriding it. Nonetheless, this is basically a common practice and a good practice. If you provide a method which also existed in the class you're extending, then you should add override to make it clear that you are not accidentally overwriting this already existing method, but deliberately. Because when you add your build method here, and stateless widget also had one, then the one of stateless widget will not be considered for my app, but your own one will. And that is absolutely something you have to do here. It's not an error. You want to do that. You just want to be clear that this was done deliberately. So it's a tiny stylistic thing, still something which you'll see throughout the course and which I therefore want to mention here. And there's one other thing you will see. For example, when you create a new Flutter app. Instead of the main function looking like this, you also can see something that looks like this. You have void main, then you have your parentheses. So that's the same as we have it up here. But then instead of curly braces, you have an equal sign and a greater sign. So an arrow, kind of. And then you have run app, my app. So what we had between the curly braces now comes after this arrow without curly braces. And that is valid Dart syntax too. It's a shorthand for functions which only have one and exactly one expression, so only one line of code in the function. Then you can omit the curly braces and instead add such an arrow here, which tells Dart, this is a function with only one expression, and this here is the expression. Please execute, there is nothing else. And the result of this expression here will then also automatically be returned. Now here, run app doesn't return anything, and therefore our overall function does not return anything. But if run app would return a value, then this would automatically be returned by our function here as well. You can use that for any function with one expression where you then want to execute that expression. So this is just an alternative syntax to that, and it's just something I want to get out of the way here so that it's clear what this does if you see that. But with that, let's now make sure we have a bit of a more beautiful app on the screen. To get a more beautiful app, it would be a good start to have a white background and maybe not this reddish text with the double yellow underline. And we only get this here because I'm outputting the text widget in the material app, and that is enough to bring something onto the screen, but it has no default stylings for our mobile app. It does not have any background or any app bar, because for Flutter, you have to configure that all manually. Keep in mind that Flutter controls the entire UI. All the pixels on the screen are controlled by your Flutter app in the end, by the Flutter framework. It does not take an existing mobile app and just mix in some widgets or some components. It controls the entire app instead. And therefore, you also have to give clear instructions about every detail. What should be the background color? Should there be an app bar? And to do that, there is a little helper widget which you can use. And I'll replace my text widget here with it, and that's Scaffold. Now, Scaffold is yet another widget which is baked into Material Dart. It's made available there, and Scaffold has the job of creating a base page design for, well, your app. So it will give you a basic design and structure and color scheme or coloring for, well, giving you a UI that looks more like a regular mobile app page. Scaffold also has a couple of named arguments, and you can always hit Control Space to get some auto-completion in the IDE and get a list of the named arguments that are supported. And here you can also cycle through with the arrow keys to get some help and some explanation of what each of these named arguments does. Now, there are tons of arguments, and typically you only use a few of them for each widget you're creating. And here, for example, we could add an app bar and then a body. Body is basically the main content of the page, and app bar, as the name suggests, is the bar at the top. So here we can add app bar, and now again app bar, if we hover over that, takes a preferred size widget. Now, what's a preferred size widget? Well, it's a special kind of widget, you could say. You could build it on your own, but since the app bar is such a typical and specific thing in any application, you can simply pass in a pre-built widget, which is also named app bar. App bar, again, is a widget provided by Material Dart. And as always, all widgets are classes. So here we are instantiating a class, but this is a class which extends stateless or stateful widget in the end. An app bar, then again, takes some configuration. So here, if I hit Control Space whilst being within the parentheses with my cursor, I get some explanation on what I can pass here. And you can pass a bunch here. You can pass actions, which would be buttons in your app bar. You can pass some bottom tabs if you want to add some tabs in there. You can change the background color, but for now I only want to set my title. Title is a named argument that allows me to set a title for this page. And here we could add my first app as a title. However, title does not take some text, but if we have a look at it, title actually takes a widget. And you can always hover over that to see what goes in there. So it takes a widget, not some text, but it takes the text widget. You know, this could be confusing, but the text widget is not some plain text, but it is actually a widget which takes some plain text, which takes a string, therefore, as a positional first argument, and then it outputs some text on the screen, the text we're passing in here. But text is a widget, not the plain text. This here with the quotes, that is plain text. So now I'm passing my text widget, which in turn takes that plain text, as a widget for the title argument in my app bar widget. And we already see a bunch of widgets here, and whilst this can be confusing initially, this is how Flutter works. You compose your user interface by mixing multiple widgets together. So here we have our overall app widget, which then uses a scaffold widget to get some basic page styling, which then has an app bar widget for its app bar, which then takes a text widget. Now, of course, we might not just want an app bar here, but also a body. So we can add body here. Now that's on the scaffold widget, so make sure you are adding this on the right level, outside of the app bar and outside of the text widget arguments, but on the scaffold arguments. Here we can add body, and the body here, again, could be our text, like, this is my default text. Now, one recommendation I have here, always add a comma after closing parentheses, because this will allow you to auto-format this in a very readable way. That's just a feature the Flutter extension for Visual Studio Code and also for Android Studio offers. You can format your document with a certain key binding, and you can find that if you go to Keyboard Shortcuts, and there you search for Format Document in Visual Studio Code. Then you should find a key binding, which you can also change if you're not happy with the default. With that key binding, if you press that, you auto-format your code to be a bit more readable, and with these trailing commas at the end of every line, Flutter is able to format this nicer. If I would remove this comma after my body argument here, you see now it formats this a bit more unstructured, and for short snippets like this is fine, but the longer your widget trees get, the easier and nicer it is to read this with these trailing commas, which improve the auto-formatting. But that's just a tiny hint for writing clean code. So with that, we finished our scaffold widget, which we didn't create ourselves, but which is provided by Flutter, and we passed an app bar and a body. And now if we save this, it should automatically rebuild and hot reload your application. Hot reload means that it didn't need to restart the app, which means it keeps the current state. If we changed any data in there, it wouldn't restart and overwrite that. Instead, it keeps the app as it was and just injects our new code into it, which is some magic managed by Flutter during development. And therefore, if we go back, now this looks way better. Instead of that ugly hello, which was red with a black default, with a black background, we now have our nicer page look here with an app bar, with a little drop shadow, with a blue background, with our title that automatically has a color that contrasts against the background. And then here we have the this is my default text, which we output in the body, so in the main area of this page. And this is how we build Flutter apps, how we work with these widget trees, and how we can also structure our app here in code. And that is what I meant when I mentioned in the first section that with Flutter and Dart, we build mobile apps by building the user interface in code. We're not using a drag and drop editor here. Instead, we're writing some code which defines what should end up on the screen. And now that we have these basics set, let's take the next step towards our first, a little bit more realistic course application. In this first, a little bit more realistic application, I want to build a very simple personality quiz application where you answer a couple of questions, and based on the choices you made, we judge your personality. For that, we'll use that current application we have here, this very lean application where we right now only output the default text, and we'll build up on that to present a question and some buttons that allow the user to choose an answer. Now, for that, we certainly need a text widget to output the question, and below that, I want to have a couple of buttons that allow the user to choose different answers. And now here's a problem. We have body, and body is the place where we add the widget that should be shown in, well, all that white area. And body only takes one widget. I can't add a second widget here. I can't add another text. Second text, you already see I get an error here because now this would actually not be passed as an additional value to body, but Dart would try to parse this as a positional argument passed to scaffold, which doesn't take any positional arguments here. So that does not work, and we also can't concatenate this by adding a plus here. All of that doesn't work. We can really only pass one widget here to body, so what can we do? I want to pass more than one widget. I want to have a text and a couple of buttons. For this, it's important to understand that we have different types of widgets in Flutter. We have the visible widgets, which are related to user input and to outputting data. Things like a button or a text or a card. And we have only seen the text from all these examples here thus far, but there are more widgets like, well, the raised button, which renders a button, and other widgets. And we'll see all of those throughout the course. Now, these are the widgets which we see. We see a button, we see the text, right? That is what we see, and that is, of course, crucial for any application. But equally crucial are invisible widgets that help us with layout and with controlling how our widget tree behaves and how it looks like. And there we got things like row, column, list view, and so on. These are also widgets that ship with Flutter, which we don't have to build ourselves, which we don't see themselves, but which help us with structuring our content. So these widgets give our app structure and control how visible widgets are drawn onto the screen, and therefore, of course, they're super important. There also is a very important widget, which also ships with Flutter, the container widget, which kind of belongs into both categories, as you will learn once we use it, because it by default is invisible, but you can also give it some styling so that you can see it. But before we focus on that, let's actually take row, column, and so on to work on our quiz app and add both a question and a couple of answer buttons. To have a text and below the text a couple of buttons, we now need a layout widget. And there we can use the column widget. Column, as the name suggests, is there to render widgets in a column, because the difference to text and so on is that this has a children named argument, which actually takes a list of widgets. Now, there are a couple of new things. This thing here between the angle brackets, that's new, and the square brackets here are also new. What does this all mean? Let's start with the square brackets. Dart, like many other programming languages, has the concept of lists. Thus far, we learned about strings, about integers, doubles, and objects, and everything is an object in the end. Now, lists are another type of data. A list is basically a group of data. So you can have a list of strings. For example, here we could add a variable questions, and that could now be a list of text questions. Like, what is your favorite color? By the way, if you would want to write what's here, and you use single quotes to enclose the string, then this single quote would quit the string, which is an error, and you can escape this by adding a backward slash in front of this. Now what happens is that this single quote here is not treated as a quote that ends the string, but instead as the quote character that should be part of the string. So that backward slash in front of it achieves that. So now we would have a question, what's your favorite color? And also, what's your favorite animal, for example? Let's also add a trailing comma here. And now questions actually would be a list of string data. Now the idea behind lists is simply that we can group related data together, because in so many scenarios of programming, but also in real life actually, you work with lists of data. You have on your phone, on your real phone, if we take a real life example, you have a list of contacts, your friends, that's a list of persons, a list of people. And therefore, lists are also something that exists in programming and basically in any programming language you can find, and of course also in Dart therefore. Lists are created with square brackets. That's also what I did up here. I created it with square brackets, and therefore lists are also created down there where we have a list of widgets. And that's the angle bracket widget thing. This is a so-called generic type, and it's a little annotation, which we could also drop here because of type inference. This tells Dart that this list here will hold a list of widgets, because a list can of course hold anything. This, for example, is a list of strings. If I hover over questions, we see that Dart was able to automatically infer this list, and then again this angle bracket thing, but here with string. A generic type is basically an annotation which you can have on some types that allow Dart to understand that this is not just a list, but a list of a specific data type here, for example. It's the same thing down there. This is a list of widgets. Now, because of type inference, we can remove that as soon as we start adding widgets here. And there I would want to have my text widget with the question, and I'll add some real text soon, and below that a couple of buttons. Now there are different kinds of buttons in Flutter. One of them is the raised button, which is a button with a background color and a little hover effect. Now the raised button here is again a widget which we create by instantiating our class here, and it typically has a child, which is basically the content inside of the button. That could be an image, that could be an icon, but often it's all just some text. So the text which is displayed on the button. Again, this is a widget, not just some string. The child here is a widget instead. And therefore here we could have answer 1. And then I can copy that line and add it again so that we also have answer 2 and maybe also answer 3. Now each button, besides having a child, also needs an onPressed argument. And onPressed will be a function that should be executed when this button is, well, pressed. For the moment, since we haven't really learned how to wire that up, let's add null here. Null is a special value in Dart. It basically means nothing. The difference to void is that void is a type. So here we say the type of data main returns is empty, it's nothing. And null is not a type, but a concrete value. Just like 1 is a value, the number 1, or like this here is a value, null is a value, which says nothing. But we need to add that to avoid errors. So here I add onPressed to all my buttons, and for all buttons I then add null. And with that, again, I hit my code formatting shortcut so that this gets formatted in a bit of a nicer way. And again, if we add trailing commas like here, after null in my first button, then this gets formatted in a bit of a more readable way. So now I added my column widget, which has a couple of child widgets, where we have the text widget and then the raised buttons. And if we save that, now we see our text up here, and then we see the 3 buttons, and they are currently all disabled because onPressed is null. And that means if we press this button right now, nothing happens, and Flutter automatically detects this and then disables the button, which sometimes can be nice if you have a user input form where you gather the email address and the password of the user. Then you would want to disable the button as long as nothing valid has been entered. Here, however, of course, I want to enable them. And for that, we have to understand how we wire up the button here to some function that does something, or how we make sure that something happens when the button is tapped. Of course, we can also improve the styling and how this is laid out here on the screen, but we'll do this in a second step. For now, it was important to understand how we can have more than one widget next to each other with the help of column for ordering widgets from top to bottom. If you would want to have them sit next to each other left to right, you would have used row instead. But we'll see column and row and all these other invisible and visible widgets throughout the course. So whilst we can certainly improve the styling, I first of all want to improve the behavior of the buttons. Right now they're not doing anything when we press them. That happens because we haven't wired them up to anything. Now, onPressed here takes a function. That's important. The value of onPressed is a function that returns void. This is what this here means. Now previously, for example on title here, we saw that title wanted a widget. If we hover over onPressed, we see this strange thing, and that simply means a function that takes no arguments and doesn't return anything but a function. This here is basically the type definition for a function. Arguments and return value. So onPressed takes a function. Now we got a couple of different options here. We can add a new function outside of the class. That's a bad idea. Your objects, so your classes, should always work standalone. So everything that belongs to a widget should go into the same class. All the data which it uses and so on should belong into the same class so that the widget is a standalone unit. So we can add a function here into our class. You can do that because you can add functions to classes. They are then called methods, but it's a normal function. So here we want a function that takes no arguments and does not return anything. So here in my app, we can add void and then any name you want, like answer question. Answer question. Typically, your function names are descriptions of what happened or what happens. So here we got our answer question function. It does not take any arguments. It returns nothing. And in there, let's simply print answer chosen. Now that's the function defined here. How do we now wire this up to onPressed? Well, it's simple, right? We call answer question here like this. Add parentheses and we're good. Well, we already see that we get an error here. The expression here has a type of void and therefore cannot be used. Does that make sense? Shouldn't it return void? Isn't that what I just said? The problem here is, and that is now something which I know that it can be confusing, but it's super important to understand. So I'll explain this in very clear and slow steps. The problem is that here I'm executing answer question. Sounds all right, right? I want to execute it when onPressed is clicked. However, you have to remember that Dart parses your file from top to bottom, left and right, when it, in the end, starts your application. Now there, it then runs the app, builds the MyApp widget, and that means the build method gets called. And in the build method, Dart now goes through the entire method to find out what to build. And it sees, okay, I build a material app, and there I have a scaffold, app bar, text, column, and so on. Dart goes through all of that. With the help of Flutter, it's able to bring that onto the screen. But then it encounters the raised button. The raised button is configured to have a child, which is this text. And then for onPressed, what you're saying to Dart with this syntax is onPressed, the value for onPressed should be what answer question returns. Let's have a look at Dartpad again. There, earlier, what I did is I add numbers, and then down here, I store the result of add numbers in first result, right? What add numbers returns. And I do this by executing add numbers. This then executes this code and returns that value, and therefore I can store that returned value here in first result. And here it's the same. By adding parentheses, this gets executed as soon as Dart encounters this. Not when the user presses the button, but when Dart goes over that code to set up the raised button. So it executes answer question, and now it expects to get back the value which should be passed to the raised button as a value for onPressed. But onPressed wants a function. Answer question, on the other hand, doesn't return anything. because this is a function that doesn't return anything, and since we now pass the returned value to onPressed, we return nothing to onPressed, but onPressed wants a function. So we're not passing this function here to onPressed, but the return value of this function, because by adding parentheses, this gets executed when Dart tries to build that button. Of course, this is not what we want. We want to execute answer question when the user presses the button. That's why we want to pass a pointer at answer question to onPressed. Now, consider this real-life example. If you have a TV and you can turn the TV on with your remote by pressing a button on your remote, then you could say turning the TV on, that's what happens in a function. That function could be named turn on, and you execute that function by pressing the button on your remote. Now, if I give you the remote for the TV, you can press that button whenever you want, and that turns on the TV. It would be bad if I pass you the remote and simultaneously I press the button for you, because then I would take the option of turning the TV on away from you. That's what we're doing here. We're essentially executing the function at the point of time we want to give it to Flutter. So the solution for all of that is that we remove the parentheses here. By doing that, we're passing a pointer at that function to Flutter, to onPressed. We're telling onPressed, hey, this is the name of the function which you should execute when the user presses the button. So we're passing the name of the function to onPressed and to the raised button, and not the result of the function. Name instead of result. Super important. So here we have to use answer passed question without parentheses, and you always need to use it without parentheses when you just want to give the name of the function to some argument or whatever it is in your code. We'll see this occur over and over throughout the course. So here we can do the same for answer question down there on the second raised button, and of course also on the third raised button, always without parentheses, to just point at the function instead of executing it. With that, if we go back, now the button is enabled, it's not dark grayish anymore, and we can press it, and I pressed each button now, and therefore here in our debug console we now see answer chosen, answer chosen, answer chosen, and that's coming from that print statement here, which simply is a system output which we don't see in the app, but we can use it during development to see some log here in our debug console. Of course, this is not a feature you would use in a real app because the user doesn't see it, but for developing an app, it's super useful. So our buttons work and we execute this function when we press them. Now this way of hooking up a button to a function is one of two possible ways. We have our function here, our named function inside of stateless widget, and then we connect it here to onPressed. Now another way of solving this would be to use an anonymous function. This here is a named function because it has a name. Now if you have a function which you really only need here in this one place and you're never calling it from anywhere else in the application, which is already not the case here because we have 3 buttons that use the function, but let's say you only had 1 button, then instead of using a named function, which you can always do, but instead of doing that, you can add a function right here. Now without a name, but you simply add parentheses to get any possible arguments. In this case, you don't get any though, so it's an empty pair of parentheses. And then either that one line expression syntax with an arrow function, and then the code you want to execute. So here answer 2 chosen, for example. Or if I do the same on answer 3, you can also add curly braces for a possibly longer function body. So here you could now do some stuff and then in the end print answer 3 chosen, like this. And here I had 1 parenthesis too much. Now if I save that, you will see that if I click answer 1, 2, 3 here, we see answer chosen. That's from the answer 1 button, which executed our name answer question function. Then we had answer 2 chosen, which is coming from my anonymous function here, and answer 3 chosen, which is coming from the function here. And it's called anonymous because it has no name here. It just has the argument list and then the function body. Now, an anonymous function always is a good idea if you never need to call it from anywhere else in the code, because you can't call it from anywhere else. It has no name, but you don't need to, well, define it up here if you only need it in one place. So these are two function syntaxes which you will also see throughout the course. Please note that this also is not executed immediately. This is just a function definition. I didn't add parentheses after that, which would execute it immediately. Instead, I just define my function here with the arguments in the function body, and I pass that definition of the function to onPressed, which therefore ensures that the raised button can execute the function when the user really pressed the button. So that's a lot of fun with buttons and functions, and it's a crucial building block of Flutter applications, because in your typical application, of course, you do interact with the user, and you want to give the user some chance of interacting with the application. And that requires, well, exactly what we learned here. Nonetheless, right now, we're really just doing some behind-the-scenes stuff, right? We're really just printing something here. And that's nice for debugging, so that we see that the buttons really are pressed, but it would be nicer to change something on the screen before we then also later work on the general layout and the look of this. And that is exactly what we'll do next. Let's make sure that something changes on the screen when we press one of these buttons. Now, for a start, to change something on the screen, let's make sure that we output a real question here. We got two questions here in this list of questions, and I want to start with my first question here at the beginning of the app. But once we press the button, and for the moment, it doesn't matter which button we pressed, I want to switch to that second element here. Now for that, let's first of all start by outputting the first element. So I don't want to hard code my question down there into this text widget, but instead I want to use the first element of my questions list. To do that, we first of all have to refer to questions. Questions is the name of the variable. By adding it here. But now questions is a list of strings, and I only want to take the first string and output it. To do that, Dart gives us a syntax for accessing the different items in a list with their different indexes. Each item here has an index. The index starts at 0 for the first item. That's important. Not at 1, but at 0. And we can access the different elements by their index. There are two ways of doing that. You can add a dot here after your variable names. And now, since questions in the end holds a list, which is an object, this has quite a lot of methods which Dart gives us automatically, because list is a default object built into Dart, and it's a more complex object, as you can clearly tell, with a lot of built-in methods. Now we'll use some of these methods throughout the course. Here, one method we could use is element add. And now here we could pass in an index, which, if you hover over that, needs to be an integer. And if that is 0, for example, you get access to the element at the index 0, which is the first element. So if I do that, and I save this, you see what's your favorite color here, because what's your favorite color is the first element here, and therefore it has the index 0. If I pass 1 in here, we would print what's your favorite animal should be the text here, of course. If I pass 2 in here, which is index 2, then we actually get an error here, right? I get an error that, if we scroll up, that we have a range error here, invalid value, not in range, 0 to 1, so that's the range we have, and we try to use 2, and that's in the end the error I get here, because I try to access the element at an index which we don't have in here, because the index at the element 2 would be the third element in this array, and we only have 2. So that's one way of doing this, but there is a shorter way. Instead of using element add, you can add square brackets after the variable name and then enter your index number there. That's doing the exact same thing, but it's a bit shorter, and therefore it's the syntax you typically use. This now accesses the first element in the questions list, and therefore this, what's your favorite color question, and hence this is what we now see here. So that's nice. However, it would be nice if we could change that index which we're accessing dynamically when we press a button. To make that happen, we can add a new variable. Now, however, not inside of the build method here, because then it would essentially be reset and change every time build runs, and actually Flutter executes build a couple of times. It always executes build when it needs to rebuild the interface on the screen. Instead, I want to add it as a class-wide variable. So here inside my class, I can add a new variable at the top, and that could be question index, which is 0 initially. Now we could also replace var with int, but since I initialize it with 0, Dart is able to infer this, and hence using var is a better practice. Now by adding this property here, so a class-wide variable is called a property as you learned, we can use it here in answer question. And I could take my question index and set it equal to 1, or simply to question index plus 1 to use the old value that's stored in question index and then add 1 to it. And then after this calculation is done, that's stored back into question index. So the old value of question index will be overwritten with the old value plus 1. And I can remove answer chosen now. So we could update question index here. And now here, when we output a question, instead of using 0, we could refer to question index here. So the index which we use to access an element in our questions list is set dynamically. It is 0 initially, and we increment it to 1 after a question was answered. And right now, answer question is only connected to the first button. So when we press the first button, we should change question index, and therefore we should also see our question change here to the second question, which is the one for our favorite animal. Let's also print question index here to see whether that works. If we save this, it should rebuild. You can always manually press that flash button here to do a hot reload, or if somehow your app got stuck, you do a hot restart to fully restart your app, which takes a tiny bit longer, but make sure that you really rebuild your app with the latest piece of code. And now if I press answer 1, seems to work. If I go back, I see 1 and 2 because I pressed it twice. But if I only press it once, let me rebuild this again to really prove that this only executes once. So if I now press answer 1, I see 1 here. So this works, but what you also see is that the text didn't change. It's still what's your favorite color. It did not change to what's your favorite animal. So what's wrong here? Do we have an error in our code? No, the problem is, and that's also kind of signaled here by the green squiggly lines, but that's a bit too cryptic, but the problem is in the end that we're trying to change some internal state of this widget. And for that, of course, we need to understand what state is, and then we'll understand what the remedy is. What's this state thing I mentioned? In general, state is data or information your app or your widgets in your app use. State can be things like a username, or in our case, the index of the question we want to show. So app-wide state would be things like, is the user authenticated? Or if we're building an app that users can use to find new jobs, we could have the overall jobs we loaded from a server. Widget state could be things like the current user input, or are we currently loading data and do we want to show a spinner, or as in our application, the widget state of the app widget we have could be which question is currently selected. And that state can and typically will change in an application. However, as the name suggests, since we're extending a stateless widget here, this widget can't have state. Now that might sound very restrictive and strange, since we typically have interactive applications where things should change. Why would we have widgets that can't change? Well, typically in your Flutter application, you will have more than one widget, and we'll soon have more than one widget here as well. And some widgets are only there to output something, like that text widget, which is built into Flutter. This is a widget which has no state in it. It gets the text from outside passed in. That is passed in when the widget is created, so it never changes whilst the widget is there. And it just outputs the text. It does nothing else. It doesn't react to clicks on the text or anything like that. Therefore, text would be a perfect stateless widget, and indeed it is. And a lot of the widgets are only concerned with outputting data with certain styles, certain colors, or in a certain structure. Some widgets, however, need to change data, like our app here. We want to change that question index. And for this, we can convert that stateless widget into a so-called stateful widget. The difference between stateless and stateful widgets is that in a stateless widget, we have our widget and the build method, which is used to render the UI. Now we can pass in data from outside into the stateless widget through the constructor of that class, so of the widget class. We'll do this later too. And this data can change, and actually Flutter would rebuild that widget when that external data changes. But inside of the widget class, the data will never change. We can only receive new data from outside, and that will basically rebuild the widget. Now, a stateful widget also has a build method that builds a widget and that renders a UI, therefore. But here, we can also get our input data, so data passed in through the constructor of the widget class. But we also can have some internal state, and that's the core thing here. And this widget will get re-rendered, so the user interface will get updated by Flutter whenever either that external, that input data changed, or when our internal state changed. That's the core difference. And here we really just have a My App widget, which doesn't take any input data, so it doesn't even take that. But it certainly can't have internal data, internal state, because it's a stateless widget. Now, how can we turn this into a stateful widget now? For turning this into a stateful widget, you could think that you simply rename this into stateful widget, but now we have an error, because it's not that simple. You also can refactor this in Visual Studio Code and Android Studio if you have the Flutter extension installed, which you should have. Then you can check your key bindings and search for refactor. And you should find a key binding which you can use to get refactoring suggestions. And if you place your cursor on stateless widgets, if you click on that and you then use that key binding, here I get the suggestion of converting this to a stateful widget. We could do that, and in the future we will take advantage of this because it's super fast. But here I won't do that because I want to show you what makes up a stateful widget step by step. Now, the first step is indeed that you rename this to stateful widget. Stateful widget is a class provided by the material package here. So this exists, so you can use that. Now, however, a stateful widget is a bit more complex than a stateless widget. It's actually not just one class, it's instead a combination of two classes. So let's close the curly brace of our first class here. Let's add a second class with all of that content down there, with the build method and so on being part of that second class. This is now typically named My App State. Not My App State, but your widget name plus state after it. So in this case, My App State, because my widget here is also named My App. My App State now extends state. And now you can open your curly brace again. State, again, is a class imported from Material Dart, and state is a generic class. Now comes the more complex part. Why do we have two classes, first of all? Because the way Flutter works internally, into which I'll dive a bit deeper later, is that the widget itself can be recreated. This class can be recreated. When the external data changes, this will be recreated, basically. The state, however, is persistent. It's attached to that widget, so it's attached to that element in the user interface which you see. But unlike that class here, it's technically not recreated. And that's important for storing your state, so that when the question index changes and the external data passed into the widget itself changes, only that is rewritten, is rebuilt, and our data here is not reset. And if that's not entirely clear yet, it will become clearer once we start passing data into the widget itself. So we have that separation so that this data here, the state, can be persistent, whilst this widget itself can be rebuilt. Now we need to tell Flutter that this state class belongs to this widget class, however. To us humans, to us developers, it's clear, because of the naming, my app state and my app, but the naming is just a convention, it's not a rule. And therefore, Flutter does not take the name as an indicator that this class here belongs to this widget. Instead, to set up a connection, we need two things. First of all, state is a generic type, so we should add angle brackets there, and in between, we add a pointer at our class here. So here I add my app. This tells Dart and Flutter that this state belongs to the my app class. So this is one part of the connection. The second part has to be done here inside of the my app class, so inside of the widget. There, we have to add a new method, the create state method. Now here I get a suggestion by my IDE, and if I hit enter, it automatically adds it for me. Now, create state, as you can see, is a method that takes no arguments, but that in the end has to return a state object, which is connected to a stateful widget. Now that's exactly what we have down there. It's an object that's of type state in the end, because it inherits from state, and that is connected to my app, which is a stateful widget. So here we want to return a new my app state object. Here we create a new object based on that class, which also knows about this class, and therefore we now connected the two pieces, the two classes from both ends. Here we also have override again, because create state is a method provided by stateful widget. It needs to be overwritten, and again, to be clear that we are doing this deliberately, we add override here. Now we have that connection set up from both sides. And now with this change, the build method is now inside the state, not inside the widget, because the state holds the data that is used by the build method. With this now changed, and nothing else changed, if we now save this, and we restart our application, because if you do such a transformation, hot reload typically doesn't work, so you need to do a full restart with that green arrow here, or the shortcut which it shows there. Now with that, if you go back and you click answer 1, please watch the what's your favorite color text. Still nothing changes. We see the output go up there with the print statement, which is still part of answer question, but still nothing changes in the UI. Well, the reason for that is that still, even with this transformation to stateful widget and state, Flutter doesn't automatically update and re-render the user interface just because we tap the button. And that's good, because for performance it would not be that great if Flutter would re-render the user interface on every tap of the user. If we tap somewhere and Flutter takes this as an indicator to re-render everything, then our app would certainly have a horrible performance. Instead, we have to tell Flutter that we're about to change the state, and that when this state is changed, it should re-render this widget. We do that by wrapping the code where we do change data inside of our state that is reflected in the user interface. And the question index is of course reflected because it controls which question is shown. So when we change that, we wrap this in a set state function. Set state is a function, or a method to be precise, that is provided by that state class which we inherit. And set state takes a function, typically an anonymous function, so a function here with no arguments and then the function body. And inside of this function, which we passed to the set state function, so a function that takes a function as an argument, that's just how it is, inside of this function, we move that code where we change our property in this case, the property which also is used in build. Now with that, if we now save this, and we do a full restart, if you now watch what's your favorite color and I click answer 1, you see now it changes to what's your favorite animal. And this now happens because of set state and us using a stateful widget. Now throughout this course, we'll work with both stateless and stateful widgets. As you will learn, the majority of widgets will actually be stateless, because more often than not, you're just concerned with outputting something in a nice way. But occasionally, you need to change data. You need to react to user input and change something, and then we'll use stateful widgets, which are the other core type of widget Flutter supports and knows. By the way, please note that if you press this more than once, you of course get an error, because then you change question index to 2, and you would try to access the third question, which we of course don't have. Now, with our stateful widget added, it's important to have a brief first look. I'll later have a more detailed look, but a brief first look at what Flutter actually does when setState is executed here. setState is a function that forces Flutter to re-render the user interface. However, not the entire user interface of the entire app. Instead, what setState does in the end is it calls build again of this widget where you called setState. Now, in our case, that is almost the entire app, right? My app, this widget here, with this build method, that is basically our entire app. But later in this course, we'll have bigger applications with more widgets where we split that into more custom widgets. And therefore, it will really make a difference if you update the entire app or just that widget with setState. So setState updates this widget by calling its build method again. Now, the build method goes ahead and rebuilds this widget tree. It basically goes through all these instructions again. Now, that might sound very inefficient because the majority of this user interface didn't change, right? All the buttons are still the same, the app bar is the same, only this text changed. And therefore, Flutter, no worries, is pretty efficient about that. Internally, it has a lot of mechanism to go through that build method again, but to not re-render the entire UI again. So it does not redraw every pixel again. In the end, it just has its tools and its mechanisms to find out what changed on the screen and what needs to be redrawn. And therefore, it will find out that text here changed, that this widget changed because the text we passed to it changed, and it will only update this text here in the end. Now, again, I'll dive deeper into how that works and how we can find out what Flutter changed and so on. I'll dive into that throughout the course once we are a bit more proficient with Flutter. It's just a brief first look which I wanted to give you at this point, that build is getting called when you call setState, and that is why you see the change then. And that is also why you didn't see anything without setState, because then you changed the data, which is nice, but Flutter never executed build again, and therefore this widget tree never got rebuilt, and therefore this text with the updated text never made it onto what the user sees. So we learned about stateful widgets, the other type of widget you can create in Flutter, which differs from the stateless widget in that it can manage internal data. Well, you could do that in a stateless widget too. You can do that in any Dart class after all. But in a stateful widget, if you manage that internal data, actually in the state object then, which is connected to the stateful widget, you can update this in a way that it's picked up by Flutter and that the UI also updates. Now that's nice. Now let's dive a little bit deeper into Dart at this point. Let me show you one alternative syntax here, which I would recommend using because it is a common pattern and a common practice, and you'll see it in other official examples, and we'll also use it throughout the rest of the course. In Dart, you can have variables on classes like question index, and you call these variables properties then. And you can have functions in classes, and they are called methods then. Now that's not new. Now in Dart, you also can put your code into more than just one file. We only use one file thus far, but actually I'm already importing something from that material Dart file, which is exposed by the Flutter package. Now, as a default in Dart, every file is its own enclosed ecosystem, you could say, its own so-called library, which can be a confusing name because we have that lib folder that makes up a bigger library. But in the end, every file in that folder is its own mini library. These files can still work together with the help of import statements, but you can control what can be imported and what can be accessed in another file. And for example, you might want to restrict that this state object can be used and changed from inside another file. Now we only have that file here, right? But we'll soon add more files, and then we want to make sure that we can maybe use our widget in other files, because we are, for example, also using the material app or the scaffold widgets, which we get from material Dart. But in these widgets, we might not want to grant access to all the properties that are in there. Or to this class, we might not want to grant access at all from inside our files. Because the only thing that should use this class is the myApp class here, which needs the myAppState class to create that state. Now, of course, we as a developer, we are writing our own code and we can simply not use that class anywhere else, and we're fine. But if you're working in a bigger team or if you're sharing your application with other developers, then you might want to put some protection into place so that the myAppState can't be used or manipulated from outside this file. Because if it could be manipulated from outside, then maybe you could change question index from inside another file and that wouldn't be picked up by that widget correctly, and your app might therefore get out of sync, or you might introduce weird bugs. Now, to inform Dart that this myAppState class should only be usable from inside the main Dart file, so from inside the file where it's defined, you add a leading underscore in front of the name. And of course, you also have to add that in all the places where you use that name. Now, this might look like a cosmetic thing, but actually that leading underscore is a special syntax in Dart, and it turns this class, which normally is a public class, which means it can be used in any file which imports the main Dart file, this turns it from a public into a private class. And now myAppState is a class that can only be used inside the main Dart file. So in our case, only in that myApp class here. And that's what I want, because since this state works together with this class, it should really only be usable inside the same file where the myApp class lives. So that is a common syntax you see. And on the same page, this variable and this method should also only be accessible from inside that file. Hence, we can add an underscore in front of question index, and then also again in all the places where we reference question index to signal that this should be a private property of this class here, which means we can't access it from anywhere else in our project. And let's do the same for this answer question function, or method as it is then called. Let's add an underscore in front of it and then also add an underscore here. Again, this is basically a convention I'm following here. However, it's not just a cosmetic change, it really has an impact. It is a syntax understood by Dart. It doesn't change the way our app works right now, but now we really ensure that myAppState and all the properties and methods in there can't be used from anywhere else than inside this file. And that is really important. A few lectures ago, I mentioned this strange input data. Now, what do I mean by input data? Let me explain this, and at the same time, let's also improve our look of this app, at least a little bit. And for that, we'll actually create a new widget. A widget which should wrap this question text here. Now, to create such a new widget, we can simply add a new class. Now, we can do this in the same file we previously worked in, but a good convention and rule is to only have one widget per file. There are rare exceptions to that rule. For example, if you have two widgets that really only work together and you don't really plan on reusing a widget in other files, but generally you want to have one widget per file. And therefore here I'll add a new file next to the main Dart file and I'll name it question.dart. And this should hold my question widget. Now, you should actually, thanks to the Flutter extension which you installed, have a little helper here. If you type st, you should normally get some suggestions to automatically create some widgets. So a little shortcut, a little code snippet, which was added by the Flutter extension in Visual Studio Code and in Android Studio. If you get that, you can select the Flutter stateless widget option here and hit enter, and you automatically get a new stateless widget created for you. All you have to do here is add a name for that widget, which in my case would be question here. Now, this is in the end a class extending stateless widget, and you already get that build method with the override annotation, and it's the exact same widget setup we manually created at the beginning of this module. Now, here we're using stateless widget, and that is provided by the material file from the Flutter package, just like widget and build context and this container thing, which we haven't used before. And therefore we have to add an import at the top of the file, which points at a package, and there at the Flutter package with /material Dart, so at that material Dart file. Now this is a valid widget. And there, let's get rid of container and let's add text here. And here I want to output the question text. The problem just is I'm managing my questions here in main Dart. Now, of course, we could move that questions list, or array as you could also call it. Array and list, these are interchangeable terms. You could move that list into the question widget. However, then you would have your list of strings in there, but the logic for changing the index resides in the main Dart file. Now you could move that into the question widget as well, but we'll later also need it for our answer buttons, and actually already the answer buttons are in the main Dart file. We could move them into the question Dart file as well, but then we effectively would have moved basically everything from the main Dart file into the question Dart file, and that's not the idea behind splitting our app into widgets. So instead what I want to do is I want to come back to that idea of getting some input data in a widget. And if you recall earlier lectures of this module, then you know that when you create a class, you can have a constructor which can take some data to initialize data inside of that class. And here the idea could be that we simply have our question text, or whatever you want to name it. And since I don't initialize it with a default value here, I'll set this to type string to be clear about which type of data it will hold. And that question text should be passed into that widget kind of from outside, so from inside the place where we later use that question widget. For that, we can add a question constructor using the same syntax I showed you earlier, where you repeat the name of the class and then add parentheses. And then you can either use the long form with the curly braces, where you accept your arguments and then you store your arguments in properties of this class, or you use the short form, where you add a semicolon after the constructor, and then you use this question text, and now the first argument, which is passed to the question constructor, will be stored in the question text property. Please note that I'm saying the first argument, because since I didn't wrap this here in curly braces in my argument list, this is not a named argument, but a positional argument. Only if I would wrap this in curly braces, it would be turned into a named argument. However, here, since I only need one argument, I'll go with a positional argument, because identifying it shouldn't be too hard. It's the only one, right? So this is my positional argument which is required, which will be stored in the question text variable or property here. And now down there in the text widget, which expects a text, I can simply refer to question text. So to this property, I can refer to it down there. Now, how do we use this widget then? Let's go back to the main Dart file where we at the moment have our text widget here. And now I want to forward my selected question, which I select in the same way I did before, not to the text widget, but to my question widget instead. To do that, we first of all need to import our question widget from the question file. So we add a new import statement at the top. And the convention here is to first of all have a block of all the imports that point at packages, and then a block of imports that point at your own files. Here you add quotes, single quotes or double quotes, doesn't matter, just be consistent once you made your choice. And there you now add a relative import path, which means you add /, which means look in the same folder as the main Dart file is, and then the name of the file from which you want to import, which in this case is question Dart. So now we're importing from question Dart, and that means everything that's in this file is now available in the main Dart file as well, unless you name it with an underscore in front of the name. However, question doesn't have an underscore, and it shouldn't, because we want to be able to use the question widget in the main Dart file. So here we now can use question instead of text. And since question, its constructor, expects to get a value for the question text, we still need to pass a value to this question constructor. So this is already correct here in the main Dart file. Now, of course, you might wonder, what's the benefit of this? Previously, we used text. Now we use our own widget, but in there, we also just use text. Of course, for this simple restructuring, it's not useful, nonetheless, it is a good idea to split your widgets or your app into smaller custom widgets. That can help with performance because it can make your rebuilds more efficient, and it also makes it easier for you to manage your code. Of course, not that much if all we had here was a single text widget, but the more complex of a widget structure you had here, the leaner your main Dart file gets as soon as you move that into a separate widget. Again, not that useful for the single text widget, but we'll see the benefits more and more as we progress throughout the course. Now, that here is a stateless widget, that's important, and this now receives some input data because it gets some data in its constructor. Now, if we save that and we have a look at our app, it looks the same way as before, and conveniently, if we press answer 1, it also behaves the same way as before, and the text changes once we press that button. Now, this has one important implication. It means that what I mentioned on this slide is true. On the left side, on the stateless widget, it gets re-rendered when the input data changes. Now, that's exactly what's happening here. Here in main Dart, when we change the question index with setState, the build method gets called here, and therefore Flutter and Dart go through our widget tree. And in the end, they find out that for a question here, we are changing the text, right? Because question index changed because the index changed. So we select the second question in our list of questions now. So the input data to question changes, and therefore Flutter automatically calls build in the question widget here. Now, technically, it calls build for every widget here, but then the widget basically checks, did I change? And most widgets didn't change, but for the question widget, it now did change because it received a new text. And since it received a new text and was rebuilt with that new text, it also updates on the screen. So that is what Flutter does for us. We rebuild the stateless widget, not because it changed internally, it can't, it's stateless, but because the data from outside changed when the build method in main ran again. So that's what's happening here. Now, one syntax improvement which we should do here, because I'm already getting a warning here, this here is a property of the question widget, which, like this, could be changed internally. Now, of course, that wouldn't be reflected on the user interface as you learned because it's stateless, but technically inside of the class, you could change this because there's a difference between the Dart features, and there in any class you can change data, and how Flutter uses that class. And that's what that warning tells us. This class is marked as immutable. That happens inside of the stateless widget in the end. And yet we have an instance field, which is in the end just a property, which is not final, which means it could be changed. You could change that string from inside that class. And therefore, it's a good convention and recommended that you add final in front of this property definition here. This tells Dart that this value will never change after its initialization here in the constructor. So this change doesn't count. That is okay. So when data is received here in the constructor, that will be stored in question text, because in the end, that all happens when this object gets created based on the class. The constructor, remember, gets called when the object is created. At this point of time, the data we receive in the constructor is stored in that property, so that is okay. But thereafter, once this object, and therefore this widget, is live, so to say, we can't reassign this. We can't assign a new value to question text. We didn't do that, but now we would get an error if we tried to. And that only makes sense because since it's a stateless widget, changing this wouldn't have any effect, and now we're really writing code that makes this super clear. So adding final here is a common thing you will see throughout this course and something you should add here. Now with that, we have the same behavior as before, but in our own widget. And our custom widgets will become more and more important the more complex our widget logic gets. We can already make this a bit more complex by adding our first little styling to this text. Thus far, we haven't really styled anything. Well, now we can do at least a little bit of styling here for our question text. So let's style our question text. And for this, Here on text, we can actually pass more than just the text that should be output. That is the positional argument of the text widget, which is built into Flutter and the material Dart file. However, this also has a couple of named arguments. For example, the style argument. The style argument, if you hover over it, takes a text style object. And now this is not a widget, but a normal object based on the text style class, which in turn is provided by material Dart. You simply create a new instance by instantiating text style like this, like you always instantiate classes, right? You always do that by using the class names and adding parentheses. Let's add a comma here. And now text style in turn takes a couple of named arguments that allow you to configure the text style. For example, you can set a font size. Now, as always, you can hit Control Space to get a list of things you can set. You can, for example, change the color and so on. But here I'll set the font size. And I just want to set this to, let's say, 28. If we do that and we save this, you see now that's way bigger. And that's already better, I'd say. It would also be nice if that were centered. We can easily do that, not with the help of style, but with the help of another named argument on the text widget. And that would be text align. Here we can set text align, and this requires a text align value. Now here you could instantiate text align, but actually this now works a bit differently. There you can just use text align without parentheses and then dot, and here you have a couple of default values, for example, center. So what's that text align center thing here? It's a so-called enum, which is a list of predefined values, you could say. The idea here simply is that there are different kind of values you can assign for alignment, like center, left, right, and so on. And these are encoded as numbers, and instead of using 0, 1, and 2, which are very meaningful to a computer, of course, they're not that meaningful to you as a developer, as a human, and therefore we have this enum thing, which is a different data type in Dart, which simply assigns labels to these different options, to these different numbers. So it's always a good solution if you have like different options and you want to use a human readable label, and behind the scenes you only basically need a number that identifies an option. We'll have a look at the source code behind that in a second. Now, how do I know such things? Well, from the official documentation, and I'll dive into that together with you later in this module, because of course it is important that you are also able to find out such things on your own. I'll come back to that later. For now, let's just use text align center here. If you now save that, you will see that the text is not just bigger, but that it also should be centered. Doesn't really work, right? A reason for that is that by default the text widget only allocates as much space as the text needs. We can change this, however, by wrapping our text here in another widget. And that would be a container widget, for example. Container can be wrapped around our text here. So open and close parentheses after text. And container takes a child named argument, which now is the text. So that is now the widget that's wrapped into container. Container by default is pretty invisible. Doesn't have anything that you would see on the screen. If you save that, doesn't change, right? It's the same as before. So what we can do with container, however, is there we can set a width. And you can set this to double dot infinity. Dot infinity gives you basically a width that ensures that the container takes as much size, as much width as it can get. So by default, the full width of the device. And now we see this is centered. Why? Because the container takes the full width of the screen now, and the text now automatically takes the full width of the container. So now the text does not use its text as a measurement for how big it should be, but the surrounding widget. That's just the default behavior of Flutter, and you'll get into such behaviors and get a feeling for them as you work with Flutter and as you build apps. So no worries if that is a lot of new information right now. That is something which will become familiar the more you work with Flutter. So now the text takes the full width of the container, which in turn takes the full width of the device, and therefore now we see that centering effect. Now let's wrap up this first little styling excursion here by also adding another named argument to container, and that would be margin. Margin is spacing around the container. And for that, you have to understand that the container widget is a special widget which actually has a bunch of settings that allow you to space things and to align things. The core of the container always is the child. In our case, that's the text widget. Around that, however, we can set up some padding. That is internal spacing inside of the container. Now, inside means that the container also may have a border which marks, well, the border of the container. And that border can be drawn such that you can see it, you can give it a color and so on. And outside of the border, you have that margin thing. So that's the spacing around the container, between the container and neighboring elements. So that overall makes up the container. And it's just important that you keep this in mind. Child in the middle, padding around it if you have one, border around that if you have one, and margin around all of that if you have a margin. Now here on this container, I'm not setting a border, not setting a padding, but I'm setting a margin. And the margin is of type edge insets geometry. Actually, you create that by calling edge insets and then dot one of these options. Now these are basically additional constructors. A class can have more than one default constructor, and you can call them as methods on the object. It's not something we have learned about yet. I'll dive a bit deeper into this in the next lecture. For now, let's just take it for granted. These basically allow us to create different variants of one and the same object. For example, with edge insets all, we can assign a certain value as a margin in all directions around the container. With only, we could target one specific direction, for example, only to the top or only to the bottom. So here, I'll actually use all, and now to all, you simply pass a double value. So here we could add 10, and now this will take 10 device pixels of margin around the container, which is why we now see a little bit more spacing around our title. So that were obviously a lot of new things. Container, margin, new types of constructors, static fields like here text align center. But these all show us that now we have that logic, this a little bit more complex widget in our own widget, which hides that complexity when we use it here in the main Dart file. And this is now a great proof of why you want to split your app into your custom widgets, because it ensures that no file gets too big, because in the main Dart file we would have a way longer code if we had all that code in there. And instead we really have different custom widgets which can focus on certain tasks. For example, here the task is to output a question in a nicely styled way. Now with that, let's dive into special constructors in the next lecture. So what's up with text align center and edge insets all? These are certain Dart features, not Flutter specific, and they're not exactly the same. This here is a special constructor. Edge insets has multiple constructors, and you can see them here if you add a dot after the class type, so without parentheses, then you see all these constructors here. Now these features exist to allow you to create an object in different variants. Now it can always be nice to look into the raw source code to understand what's going on. And you can always do that by holding Command on macOS or Control on Windows, and then you hover over the thing you want to learn more about, and it now turns into a link which you can click. And if you do click it, you're taken to the framework code. We see that enum I was talking about, you created with the enum keyword here, as you can see, and we'll do that manually later. We'll create our own enums. For the moment, let's basically ignore that. These are just different options we have for alignment here, which are then picked up by Flutter once we assign the value to align our text per the option we chose here. What's more helpful is diving into edge insets here. So if we dive into this, we now see it's a class that extends edge insets geometry, which is interesting because you might remember that if you hover over margin, this takes an edge insets geometry value. So it's good that edge insets extends this. This means that if we instantiate edge insets, we automatically get an object of type edge insets geometry, because if you have a class that extends another class, that class that does extend always has its own type as well as the type of the class it did extend. That's also a default behavior of Dart. Now in here, we see that there are a couple of special constructors here. We repeat the class name, which always means it's an instructor, But then instead of directly adding parentheses thereafter, we add dot some name. And that is a Dart feature which allows you to define multiple constructors per class. Now, without diving too much into the internals here, in the end, that just means that each constructor creates a new instance of this class, but with different configurations, with different settings. And that all is just done to make it easy for you to create different edge insets, which is basically a settings container setting up spacings, setting up different edge insets containers with different configurations with these utility functions here, with these utility constructors. If I go back to Dartpad, we could have created that for person as well. We could have added our own constructor by adding the name and then dot and then any name of your choice. For example, very old. And in there, we could have accepted the name and then said that this constructor by default sets age equal to 60. So here we can't set the age in the constructor. It's always set to 60 and we can only set the name. And now this would be a helpful constructor if we wanted to create a person, p3, that always is 60 where we only want to set the name. So we could use the very old constructor and set this to, well, max again, so my name again. And now if I print p3.name and I then also print p3.age, if I run this now, you will see that here we actually get max and then 60 being printed, and that is the output for our p3 object. So these special or these extra constructors are really just there to give you the same type of object you would get with the normal constructor, but with some predefined settings, some different behavior they run inside of the constructor. I already showed you that you can hit Command or Control and hover over the things that you're interested in and click on them to have a look at the source code for these things. And that can be helpful for understanding what happens internally if you're interested in that. Now, of course, you also might be wondering, what can I configure on a widget? What's the idea behind a widget? And which widgets do exist? And that can also be answered. For this, the official documentation is a great place. You find it on flutter.dev, and there you can click on docs. Now here you have a bunch of general documentation which can be interested, and you also have the widgets catalog. Now here you see a lot of categories for widgets, and for example, you can have a look at layout widgets to find all the widgets that help you with positioning other widgets. Here you find information about the container. You also will find information about the column and the row if you scroll down. Here you can read more about that if you're interested, and you can always click on a widget there to find a more detailed explanation. Here for container, it's pretty vast and pretty extensive documentation. Some widgets also have shorter docs. And then you can scroll down to maybe find some examples. Not all widgets have examples, but quite a lot of them have it. And if you scroll even further, you see the properties that exist, the different constructors that exist. If there is more than one, you would see it here. And you can always click on all these things to learn more about that. So that also is something that's worth exploring if you're stuck, if you need a certain behavior in your application, or if you want to look up something. So that's also something I would always recommend that you be aware of and that you dive into. And with that, that's enough of Dart and technical background for the moment. Again, and I'm really just emphasizing this because it is a lot of new content to digest. If one or the other thing is unclear, we'll go through all of that throughout this course. No worries. So for the moment, we have our own custom status widget. It receives external data. It changes when that data changes, and therefore the UI rebuilds this widget if that data changes. And we added our first basic styling and positioning here. So our app is slowly taking shape, but more importantly, we already learned a lot of important core functionalities and behaviors of Flutter and Dart. Let's continue that road. We had a look at some of the widgets we can use and at the widget catalog. And of course, throughout the course, we'll use loads of the widgets you saw there. So no need to learn them by heart right now. For the moment, however, I want to move on by now also moving my buttons here, my answer buttons, into a separate widget, into a custom widget. Maybe change the styling a little bit, maybe to give them a blue background and make them take the full available width. But that won't be the focus here. Instead, what I want to make sure is that we have real text on these buttons, so that we have text that fits to the question we have here, so that we continue working on this first basic application. And for this, let's create a new answer.dart file, which should hold the answer widget. And there we need to create a widget now. Now you could think that you need to create a stateful widget now, right? Because here in main Dart, on a button, we of course have that onPressed argument to which we pass a pointer to the answer question function. Now, just because we register a function here for an event does not mean that the raised button has to be in a stateful widget. Of course, we want to change some data when this event fires, when the user presses the button, but as it turns out, we can also trigger a function in another place of the app, even if this button lives in a separate widget. And that is a core concept and a core pattern which you will use a lot in Flutter, and therefore it's exactly the pattern we'll dive in right now. So here in the answer.dart file, I'll create a new stateless widget here actually, and we'll name it answer. And just as in the question widget, we need to import the material file from the Flutter package because that unlocks stateless widget and so on. Now in here, I will leave the container because as a child of that container, I want to have my button, and I keep the container because that will allow me to control the width. So here the child is the raised button here. The text will soon be received from outside, and I'll come back to that. And onPressed, as I said, should change something, but will also make that change in another widget. And how that works is also something I'll show you in a second. First of all, let's adjust the width, and I'll set it to double infinity again, which is a helper property on the double object. Remember, everything in Dart is an object, so are doubles, and that is the core double type, which at the same time is basically the class for the double value, you could say. And on this class, we have an infinity property, which basically gives us a value which tells the container to take as much width as it can get, which is the width of our device. So that's the width of the container. Now for onPressed, I'll temporarily use null again so that we don't get an error, and that we now can use this button as it is. I also want to set the color of the button here, and I will set it to a color by accessing colors. And colors actually is a class which also has some so-called static properties. These are properties which you can directly use on the class itself without instantiating it first. And there you have various pre-configured colors, and I will simply use blue. Now this can look strange because we haven't used that before. A static property, in the end, simply as I said, is a property which you can use without instantiating the class. If we have a look at the source code here, we see that the class here has these static const values. Const is something we haven't seen before. Let's ignore it for now. These static const values here, like black, and then a different shade of black and so on. And then if we scroll down, also different shades of white. So these are simply properties, normal properties on the class. The only difference is that you can access them without creating an instance of the class first. And such properties exist because we really just, we need that value here, right? And therefore this is like a utility feature of Dart, you could say, that we can get easy access to such a value without having to create a new instance. Instances of classes typically make sense if you want to create multiple different objects based on one and the same class. Here, of course, we want to have multiple different colors, but each color is just a value, like a simple text or so on. And therefore, of course, technically it's also an object, but we don't need the complex colors object for that. Colors, in the end, is just like a group of predefined single colors, you could say. So this colors class here exists not to be instantiated because colors itself is an object that doesn't do anything. It just exists as a grouping mechanism around pre-configured values. A little bit like an enum, but an enum simply gives numbers, 0, 1, 2, a label, a human readable label. Here the idea is to have a human readable label for a more complex value, you could say. Because the value here is not just a number, but actually the hex code or the binary representation of a color. So that is what we're doing here. We're getting access to this static property here on the colors class, and this will give us the internal color value which Dart and Flutter can use to color this button. And with all of that, we can use the answer widget here in the main Dart file. For that, let's first of all add an import. You always need to import what you want to use in a file, because since the answer widget lives in a different file, in order to use it in the main Dart file, we have to import it there. And then with it imported, we can replace our raised buttons here with answer. And now here, of course, we create concrete instances of our answer widget class because we want to create widget objects, multiple different widget objects, which we can use here. And that should be answer, not answers here. Now with that, if we save this, we now have our buttons there. Now they are grayed out because at the moment they're all locked, disabled, because I haven't assigned a real function to onPressed. And that will be the next step. And here, the tricky thing will be that this function, which I want to assign here, actually lives in the main Dart file, because that is where I manage my question index. And I have to manage the question index there because I also have my questions in here, and I need to have my questions in here because I want to pass them down to the question widget, which has no direct connection to the answer widget. So we can't manage the question index in the answer widget, because if we would do that, then we would have the value in here, but then again, we couldn't use it to select a question here, which we want to forward to the question widget. So our main Dart file is the common denominator, you could say, the shared widget between the answer and the question widget. Because our main Dart file and the widget in there, the My App widget, that is the parent widget of question and answer. It is the widget that instantiates and uses question and answer. And therefore, we want to manage our state, which both components need, or with both widgets need. We want to manage that state here in the My App component or in the My App widget, and therefore also in the My App state, which is connected to that widget. This concept is called lifting the state up. You manage the state on the common denominator of the different widgets that need this state. And that is the direct parent of these widgets that need this state. So since we manage the state in here, we also have the function to change the state in here in the My App state class. But how do we now get access to the answer question function in our answer widgets here? The answer is pretty simple. Just as we can pass text to a widget, we can also pass the pointer at a function to a widget. So answer question, my function here, can be forwarded to the answer widgets without parentheses, because I don't want to execute my answer question function immediately when Dart reads this. Instead, I want to forward the pointer at this function to my answer widget. And now in the answer widget, we of course need to accept this as an argument to the constructor, because the answer widget here, that in the end is just a class, right? And therefore it can have a constructor. So here we can add a constructor by repeating the class name, and I'll use that shortcut for the constructor. And I will also add a property here, a final property. The type now is function, which is built into Dart, and as the name suggests, this means that the value stored in this property has to be a function, or a pointer at a function to be precise. And therefore here now, you can give this any name you want. I'll name this select handler, whatever you want to name it. And in my answer constructor, I now store whatever I get here in select handler. Now what I do get in here in my answer constructor is a pointer at the answer question, and this pointer is stored in this property in my answer class. And function simply means that what is stored here has to be a pointer at a function. And now since we have that pointer at a function, which is exactly what I need down there, I can use select handler here. Again, without parentheses, because the same thing as explained earlier still applies. We don't want to execute this immediately. And hence, now we should have a setup where we can trigger a function that's actually defined in a different widget from inside our answer widget, because we pass a reference to that function down to the answer widget here in our My App state. So with this setup, we should be able to save this. And now if I press a button here, indeed our text here changes, which means that this communication between parent and child works. Passing our function down to the answer buttons works. As a next step, I want to make sure that we show some meaningful text here instead of always answer one. And as a little stylistic thing, I want to adjust the text color. We can do this by setting the text color argument on the raised button. And there we can set this to colors.white. Again, colors is this utility class which groups a bunch of predefined color codes, so to say, and I assign this color code to text color, which will unsurprisingly color this text white. But now let's make sure we have different texts here which we pass down. And for that, our question here now has to become a bit more complex, because now a question should not just be a string, the question itself, it should also contain information about the available answers. Now, of course, as long as our question is just a string, we can't put any additional info in there other, well, than the question text. So what we need now in here is a more complex object which can group multiple pieces of information together. The text for the question, but also the texts for the answers. And what could we use for that? We could create a new class which has all these features we need and use that class to create objects here. And that would be a perfectly viable way of managing this. Would be perfectly fine. However, since you're also taking this course to learn a little bit about Dart, I'll actually show you a different data structure that's also built into Dart, which can also be useful if you have relatively trivial data structures which yet are more complex than just some text. And that would be a map. You create a map with curly braces, or by using the map class like this, but let's use the curly brace syntax. So it's a little bit like a list which you create with square brackets, but a map now is not a list of values, but instead a collection of key value pairs. You have a key to identify a value. For example here, you could have the question text key, and you put the key between quotes, double or single quotes, doesn't matter, just be consistent. And then the value is assigned by adding a colon after the key, and then you have your, well, value. In this case, it's also a string, but your value could be anything. Could be a number, could be another map, could be a list. Really, any value can be used in here. The key also doesn't have to be a string. You could also have a number as a key, like 1, but often you will have strings because then you have a very human readable way of accessing the different pieces of information in that map. So now one question here in our list of questions is no longer a string, but instead a map. And that map right now has a question text. But now it shouldn't just have a question text, it should also have a list of answers. And therefore I'll add a comma to add another key value pair to this map. And I'll name this key now answers. These key names, of course, are totally up to you. And now answers won't be a string, but instead a list. As I mentioned, your values in the map can be anything. In this list, I now want to have a list of, well, answer texts which we can display. And here we could have, since I'm asking for the favorite color, we could have, let's say, black. We also could have red, green, and white here. You could add more, but I want to have 4 answers, let's say. And with that, if we now reformat this, we have this map with a question text and with an answer in here. Now, of course, I want to have more than one question in the quiz, so I will duplicate this and also add my second question here as a question text in the second map here. Remove that double quote at the end and at the beginning. And here my answer texts could be, since I'm asking for animals, here I could be asking for rabbit, snake, elephant, and let's say a lion. And let's add one more question here by copying and pasting in this map one more time. And here I'll ask for, who is your favorite instructor? And I want to offer a couple of totally objective choices here, because that could be Max, 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 or Max. Okay, of course, enter whatever you want here. So these are my 3 questions. And now we're using a map here, which, just like everything else, every other value, it's of course based on an object. It's based on the map class, which is built into Dart. So map is a class built into Dart. This is just a shorthand way of creating it, just as you have square brackets for lists. And it's perfect if you have more complex data which you want to manage as key value pairs, like we have it here, where you could create your own class and your own object. But if it is just such a simple collection of key value pairs, creating a custom class and object might be overkill, though you absolutely could do it, of course, but it might be overkill, and therefore creating such a little map here on the fly kind of can be very nice and helpful. With the questions now being re-added as maps, in order to pass down our question text here, it's not enough to select a question by index. Instead, now in there, we of course have our question text key, which we're now interested in. So we're interested in the value, of course, but we do access this value through its key. Now, how do you tell Dart that you want to get the value for a specific key? Down here, I'm selecting a specific question in my questions list. And that's important. This list here is still a list. It's a list which now holds maps. And in this map, we have a combination of string keys and then various objects. And Dart is inferring that we have a map with object values here because we have a mixture of values. Here we have a string value, and here we have a list value. And therefore, Dart goes back to the generic parent type, which every object has in Dart, and that would be, well, object, because everything is an object. So we have a list of maps where every map has a string key and different kinds of values. How do we get access to the value now? Here we're accessing a specific question through its index, and therefore now this here yields us a map. For index 0, it yields us the first map. For index 1, it yields us the second map. If we now want to get access to a specific key, we again use squared brackets here, so not curly braces, but square brackets. We use square brackets to access a key in a map, and we simply use the key name in here, inside of the square brackets. So on all the questions, I'm accessing the question with index 0, 1, 2, and so on. And then here, for the chosen question map, I access the value with the key question text. So that means I access this value, or this value, and it's this string which then gets forwarded to the question. Awesome. We can forward our value to the question. That's of course pretty neat. Now, how can we create our answers dynamically based on the selected question? We always have 4 answers, so we could hard code our answers here. But of course, we could also have one question with 4 answers and another question with only 3 answers. So it would be nice if we could create these answer widgets dynamically based on the current question. And that, of course, can be done with Dart. Instead of hard coding the answer widgets here, what you can do is you can access your questions here. So access questions, which is a list. And now, and that's really nice, map that list into something else. That means transform that list into something else. So that instead of a list of maps, we have a list of widgets. And that list of widgets could then be added here and merged into our list of widgets in that column. For that, you have the map method. Again, questions is a list, and the list is a class, an object in Dart, and that class defines a map method. The map method executes a function, which you have to pass as an argument to map, on every element in the list on which you're calling map. So in this case, on every element in the questions list. So we have to pass a function to map, and you could use a named function, which you could create up here, or you use an anonymous function, since we really only need that function here and in no other place of our file. So here I'll define a function, and that function automatically receives an argument itself, which will be passed in by Dart, and that's the current element we're looking at, because this function will be executed for every element in the questions list, and the current element for the current function execution, that is received as an argument inside of this function, which is applied to every element. So here we get the question, single question we're looking at, and now in here we have to return a new value, because map returns us basically a new list where we don't have to keep the old structure. So it doesn't have to be a list of maps. It can be a list of widgets, and that could be something we merge here into the column. Now for that, we want to return a widget here, because we want to, for every element in questions, we want to return a new element which basically replaces it, and that should be a widget now. So here I want to create a new answer widget. And to that answer widget, I want to forward question. However, we're actually calling map on the wrong thing now, because questions is a list of maps, right? Actually, I want to go through all my answers for the question we're currently looking at. So we should fine tune this a little bit. And here we access questions for the currently selected question index. And there we now select a key, and that key now should be answers, and that will then give us a list of answers, and that's actually what I'm interested in here. So map now takes a function which runs on all our answers, and hence in here I get answer, and I forward that answer to my answer widget. Now here I'm getting an error that map isn't defined on the class object, and the problem we're having here is that Dart fails to infer that the answers key always holds a list. It does here, but Dart simply doesn't see that. It's simply something Dart can't detect. Now to fix that, we can tell Dart that answers is a list by wrapping this part all the way up to after this answers key we're accessing here into parentheses and adding the as keyword, which allows us to tell Dart, hey, this will have a specific type. I know it. And we know that this will be of type list full of strings. Whoops, string should have a capital S. So now we tell Dart that answer here, answers which we access, will actually be a list of strings. And the error we're now getting is a different error, which we'll fix later, no worries. This, however, will work now. We can map a list of strings. Answer here, therefore, is a string. And to answer, we forward that string. Now, of course, at the moment, answer doesn't take a string. It only takes this function handler. So we should accept a second argument here in the answer widget, which is the answer text we want to output. And I also want to store this in a property here, answer text. And therefore, actually here in the constructor list, let's use this answer text, which then automatically assigns the incoming value to this property. And the answer text is then what we can use down there in our answer widget. So now we're accepting answer text, but still here when we create the widget, the answer text, which is inside of answer, is not the first value we should pass to the answer widget, but the second one. The first value should be our handler for the chosen answer. And for that, we of course still want to pass a pointer to our underscore answer question function here. So let's forward this for every answer widget we're creating. That was a lot of work, and I know that this can be a confusing setup here, mapping a list into a list of widgets. What's the idea here? Well, the idea really is that now we have a list of widgets here in the end, at least almost, because map doesn't give us a list, but a so-called iterable, which is kind of a parent class for all the different iterables. A map would also be an iterable. And to really tell Dart that we want a list here and not a map or anything else, we can add a dot after this whole operation and call toList. And now this converts the value map gives us to a list. Also, please note that map does not change the original questions list. It does not change this variable or the value in there. It generates a new list instead, based on the old list and then the transformation we do in the body of that function we pass to map. The remaining problem now is that we have a list here, and here column also takes a list of widgets, but with that we would have a nested list. We would add a list in a list. Actually, we want to have a couple of individual items in that list of children. And to get that, we can use another operator that's available in Dart. It's the so-called spread operator. You can add 3 dots in front of this, and now I get a warning because it's a relatively new operator, but it is supported in the recent versions of Dart. And what this spread operator does, what these 3 dots do here, is they take a list, which is exactly what we have here, and they pull all the values in that list out of it and add them to the surrounding list as individual values, so that we don't add a list to a list, but the values of a list to a list, having only one list without a nested list. So this is what we're doing here. And with that, we're having a transformation where we transform every answer into an answer widget. We then make sure that this is a list, and then we take these generated answer widgets and we add it to this list here. That was a lot of work, of course, but with that, if we save this, we indeed see 4 values here for our 4 answers, and if I choose one and we go to the next question, you see that these answers change. And if I click again, since I already was on the second question, now I get an error, because now I try to advance to a question which we don't have. Of course, we could implement checks that avoid that we can go to a question which we don't have, but for the moment, I'm happy with the current state. If we restart our app here, just to get rid of that error which I deliberately produced, we will see that we now have a nice working first app. Of course, it doesn't really make a difference which answer we choose, and after the third answer our app breaks. These are all things we can and we will tackle, but other than that, we covered a lot of the core important features which we need to know. Now I want to take a step away from Flutter again and have a look at a Dart specific feature. A feature which we already saw when we had a look at this colors thing. There, if I clicked on it, you saw that this is a class which essentially groups a couple of static properties, which are properties we can access without instantiating the class, which therefore ensures that the class is basically like a grouping mechanism for these utility values which are provided out of the box. That's not the thing I want to primarily look at though. It's this const keyword here instead, because we saw something similar already. In our answer widget, we also have final. Now, both final and const sounds like we're creating values which can't change, right? A constant value is probably the opposite of a variable. It's a variable that doesn't change, hence it's pretty constant in the value that's stored in it. But a final value also is a value that doesn't change. So what's the difference? Let me go to the main Dart file. Here, this questions list here, in the end, is a constant, if you will. Why? Because the values here never change. Okay, but isn't that the same as final? Indeed, we can use final instead of var here. And actually, that would be better than using var, because now we're really clear about the fact that we never intend to change these values once our program runs. That's the important thing. You use final if a value doesn't change from the point of time when your program runs. It can be initialized with a value though. For example, in our question and answer widgets, the properties here are final because they are changed initially when we assign a value here when this gets created, but they don't change thereafter. Here in main Dart, we're creating a question and we're creating the answers, and when we select a new question, in the end, Flutter reruns this build method here because we call it set state, and therefore it rebuilds this tree and it rebuilds all these widgets. It creates a new object, a new instance of the question class, for example, and it passes a value to that, and therefore the value that gets passed here into this question text property is kind of dynamic. Once this question widget has been created, it never changes, but when it is created, it's a different value than for the last question. Okay, I guess that makes sense. So it's kind of dynamic. At runtime, the final value gets locked in, but at the point of time we're writing the code, so during development, and also when our code gets compiled, the value is unclear because the question widget can work with different question texts. Only when it then runs, a certain text is locked in. And that's exactly what final means. It's a runtime constant value. At the point of time this code executes, we lock in final values. But at the point of time we're writing this code, we don't know what the final value will be. Well, because it's really important, for the question widget, for example, there is not a single final value. It depends on the concrete instance we create. It's different for the questions list here, though. We never change this list. Yes, we select different questions here when we output our questions, but we don't change our question list here. We just get access to it to then show it somewhere else. We get access to the question text to then show it somewhere else. We don't change the questions list here. And therefore, this is not just final, but it's constant. Hence here, we should actually use const to make it really clear that this is compile time constant, not runtime constant like final is, but compile time constant. Now, compile time constant also implicitly means runtime constant. If you know at the time you're writing the code what the final value will be, and you know that this value will never change, then of course it will also never change during runtime. Okay? But the final value, is not locked in when your code executes, but already after you wrote the code, because this questions list will never change. And that is an important concept and hopefully makes it clear why you see both final and const and how they differ. Now, besides adding const here in front of the variable name, you can also, by the way, add it in front of a value. And now what's the difference? The difference is that if you add it in front of the variable name, the variable is constant. If you add it in front of the value is constant. But isn't that the same? For that, you have to understand how Dart manages your objects. All your objects, no matter if it's a list or a widget or any other object based on any other class, all these objects are stored in memory by Dart. And what it actually stores in your variables, where you think you store the objects, what Dart actually stores in the variables are the pointers at the objects in memory. So the addresses of the objects in memory, you could say. And if you consider a real life example, if you have a house and you go to the postal office and you want to send a letter and you need to put your address on the letter as well, of course you put your address on the letter and not your house. Now, this might sound like a dumb example, but in the end, that's exactly what's happening here. Instead of bringing the object itself to every place in your code that needs it, which would take up a lot of memory because you would constantly have to copy it and so on. Instead of doing that, Dart is pretty smart and stores the object only once, somewhere, and then only takes the address in the different places. It's in the end also what we do with answer question with this function. In the end, a function also is just a variable which holds an address to this function code, you could say. And therefore, we can pass this address, this pointer, as I also called it, at this function. We can pass this to our widget where we then bind it to onPressed, because onPressed now has the address of the code it wants to execute when the user clicks the button. And that's not just the case for functions, but for any object. Now, when we turn a variable into a constant, it implicitly also treats the value as constant. But you could do the opposite. You could have a variable questions and still have a constant value. And now what would be the result of that? Now what is allowed is that you assign a new value to questions. You could set questions equal to a new list now. And even if it's an empty list. This is technically a new list. It's a new object in memory. It's not the old list without elements. It's a new list. It's a new object. And I stored this new object in questions, and therefore what I actually stored in questions is the address of the new object. But what this means is that the old value of questions, which was the address pointing at the old object, is overwritten. Now, by the way, for the rest of the course, I will always say we store an object in a variable, we store a list in a variable, even though technically we store the address. But saying it in the other way is simply easier. But that's important to understand. We had the address here, now we're overriding it with a new address. This is allowed if questions is a variable, even if the value here is constant. If I change questions to be a constant, however, I will get an error down there, because now I'm trying to assign a new value to a constant variable, and that is not allowed. So that is why we should use const here if we never want this to change, because then we avoid dumb mistakes like accidentally assigning a new value. So this does not work if questions is a const. But what's about that const value now? For that, let me give you a brief other example. Let's say we have a variable dummy, and that is a list of text where I have hello. Now, what I can do is I can call add on the list. Add is one of the methods that's provided on the list object. And I can add a new value, and therefore if I print dummy here, and that reloads, I see hello max being printed here, because I print the full list and I added an item to the list. Important, unlike map, add does modify the original object. It does modify the original list. So here I modify the original list by adding a new item. If I added const here, this would not work. If I add const here and I save this, now I get an error during compilation, because it's a compile time constant. So during compilation, I get an error that I cannot add to an unmodifiable list. And that's great. So you should always be pretty explicit about your goals in your code. And if you know you have a list where you maybe want to reuse the variable and assign a brand new value to it, that would be allowed because it's a var. But where you never want to change that object, then make the value a constant. If you have a list where you know the values will never change, well, then make the whole variable a constant so that both the variable and the list is protected against changes. And if you have data where you know it will not change once it has its initial value, then make it final. Now, these were a lot of new concepts, and of course it's a bit overwhelming right now, which is why we will, of course, use all these things throughout the course, and therefore it will become more and more natural to work with final and const. I found it important to introduce this right now, though, because I want you to learn and write clean code right from the start, and you will see final and const a lot in Flutter classes, in other examples, and also in this course. Our first little dummy application, which is still missing a lot of features, no worries, but our first little dummy application is slowly taking shape. At the moment, we have a problem though. Once we're done going through our questions, we get an error, and that's not really the kind of user experience you typically would want to deliver. Instead, it would be nicer if we show our column here with questions and answers as long as we do have questions, but as soon as we exhausted our list of questions, it would be nicer to show some other output, some message like you did it or a final score or anything like that. To achieve this, there are two things which I want to do. So what I want to do is I want to output different widgets once we exhausted our questions. So instead of having a column of questions and answers, I want to show, let's say, a centered text which says you did it for a start. We can change this later, but for a nice start, why don't we use that? Hence, we kind of need a if check here for the value we pass to body, right? Because we either pass this column here with our question and our answers, as long as we do have questions, or we show something else. It's a so-called ternary expression, and this is also a feature which exists in other programming languages. It's basically a single line if check. But speaking of that, we haven't really learned about if checks at all, right? So let's first of all start with what if means. The if keyword can be used in our code if we want to run some code conditionally. Let's say here an answer question. Then we can add the if keyword here, and then a condition between parentheses, and then curly braces to surround the code that only should run if this condition is met. And here our condition could be that we compare the question index to our list of questions, or to the length of this list. So we could check if question index, which starts at 0, is smaller than questions length. However, now we have the problem that questions is a constant which is defined here in the build method, and therefore, I already mentioned that Dart has a feature called scoping. It is scoped to this method. It's treated as a variable or a constant that's only available in the build method, but not in the entire class. Well, the solution is relatively easy though. You simply take that entire list and move it out of build and add it as a variable or as a constant to the overall myAppState class, like this. Now here, however, we get an error that only static fields can be declared as const. So basically Dart doesn't allow const here on the class level. There are two solutions. We could add the static keyword in front of that to fix this. Now Dart is happy. Or you change this to final and maybe just add const here to make it really clear that this list will never change. Both is okay. I will go for final and then here my const value. Now questions is a property of this class and we can use it anywhere in the class, including this function. With that, back to this if check. Here I'm having a Boolean comparison. I'm comparing questions index to the questions length. And what this does is if the length here, let's say that is 3, if that is greater than the question index, then this here will return true. Because I'm checking if question index is smaller than question length, and this question has two possible answers, true or false. And this is another important type in Dart, which I haven't mentioned before, a Boolean. A Boolean is true or a Boolean is false. It's a specific type, bool, which is built into Dart, and it really only has these two values, true or false. And therefore it's awesome for if checks. This here automatically yields a Boolean. This expression here, thanks to this comparison operator, yields true if this condition is met and yields false otherwise. And we only make it into this if block here if this here resolves to true. We could also check for if true, then this code here would always execute, but of course that's a bit of a meaningless check. The same would be true for if false, then this code here would never execute. Instead here you want to have a comparison or a sum check that can sometimes return true and sometimes return false. Besides the smaller than operator, you also have greater than, smaller than or equal, greater than or equal, so the two values have to be equal, or not equal. These are other operators you can use here, but here I want to check, is the question index smaller than questions length? This means that since we have 3 items in questions, this here always is 3, because again, questions here is a list with 3 maps. So questions length always is 3. Question index starts at 0. Then this condition would be true because 0 is smaller than 3. So for the first button click, this is true and we make it into the if block. And then we change question index to be 1. So for the second time we click a button, this also is true because 1 is smaller than 3. Then we change it to 2, and therefore for the third time, this is also true. So what I actually want to do here is I want to print we have more questions. However, as I just explained, this even is true if we have no more questions because we check before we change the index. So we should actually move that to the end of that so that we first changed question index before we check if we then have more questions. But with that, if we now restart the app, what should happen is that when we click a button, is that we see we have more questions twice for the first 2 button clicks, but thereafter, for the third button click, we see no output. So if I now scroll up here above the error, we indeed see we have more questions twice, but after the third click, we no longer see that. Now that's a normal if check. How can we now bring that down there into our widget tree? So in the last lecture, I introduced if statements. You create if statements by writing if and then between parentheses your condition. Now, whenever this condition here is met, you make it into this body of the if statement, which is found between these curly braces. And just as after all such body statements with curly braces, you don't have a semicolon there. Now, what goes between these parentheses, though? Now, as I said, a condition. But to be very precise, what goes between there is actually an expression that resolves to true or false. And that's a specific type in Dart. And this type exists in many programming languages. It's called a Boolean. So here, for example, we have a new variable. Let's say we're tracking the logged in status of our user. And that could be set to true or to false. And that would be a Boolean. A Boolean is a value which is either true or false. There is no other possible value. So true or false. And of course, this is a very handy type of value, a very handy data type, because often in programming, you have these two options. And you especially need Booleans in conjunction with if statements. Because here you in the end want to find out if some condition is true, then do this, or if some condition is false, then don't do that, but maybe, and that's also something you have on an if condition, maybe you then do something else. So that would be your else block here, which you can also specify on an if condition to have an alternative if this is not met. You don't need to have an else block, though. It's totally fine if you just have the if block. Then you might execute this code or do nothing if this condition is not met. Or, well, if you have an else block, then you have an alternative code to run. So both is possible, and Booleans are the key to that. Now, the condition here typically is one of two things. Either you're referring to a Boolean here, so to a variable that holds a Boolean, and then somewhere in your code, you probably have a way of setting this dynamically, because of course, this code snippet here right now doesn't make a lot of sense, because is logged in is hard-coded to be false, hence you can never make it into this block, you would always go into the else block. But if is logged in is controlled somewhere else in your code, if it is set dynamically based on some user input or some other action that is occurring, then this here is a typical check. Now what I'm doing here, by the way, is a shortcut to equals true. I'm comparing if is logged in, so the value stored in this variable is true. That's the default check that is performed if you omit the double equal signs. So this here, if is logged in, which can be read as if true, is equal to this check. So it's redundant to check for equality to true because that's the default if you just refer to a variable or to some expression. Now, as I mentioned, this is one of two common scenarios that you have some variable or maybe also some function call where you call some other function which returns true or false. So that you check something that yields true or false here, and that something is a variable or a function call. The other common scenario is that you write a condition here where you directly compare two or more values. Let's say we have the username, that's Max, and I have my age, 30. And I want to make sure that we execute some code here, logged in, when the username is equal to Max. Let's also add a password to make this a bit more realistic. Tester. So here, when my username and my password are correct, I want to print this. Otherwise, I want to take my user or the code execution into the else block and print failed. Now, in such a case, we want to check the values of username and password. And we therefore have no single variable that is true or false, but we want to check if username has a certain value and password has a certain value. In such a scenario, you can check if username is equal to Max, and that's something new which you haven't seen before, the double ampersand sign here means that you also need some other condition to be true. And here you check if password is equal to tester, for example. So in this scenario, what I'm doing is I'm checking two conditions and both have to be true to make it into this if block. If at least one of them is false, even if the other one is true, you make it into the else block here. So now if we run this code, we therefore see logged in because username is Max, I'm setting it here, and password is tester, I'm setting it here. Please be aware that double equal sign has a totally different meaning than a single equal sign. You use a single equal sign here to store a value in the variable. You use a double equal sign here to compare a variable's value with another value. And that is something totally different. Such a comparison, where you use such a Boolean comparison operator, as it's called, always yields a Boolean. So this here, yields true or false. And that's where we're back to this Boolean value up there. And of course, you could also use some helper variable like has correct credentials or whatever you want to use here, where you put this check in like this. This is a valid code. And then down there, you only use that variable in the if condition to have a leaner if condition. This is totally valid. Now I'm basically using this Boolean operation here with my comparison and my concatenation of conditions to derive a Boolean value, which is true if both conditions are met, or false if at least one fails. And therefore I store true or false in has correct credentials. And then I'm using has correct credentials down there, which is true or false. So that's all possible, but I'd say the more common case is that you don't use such helper variables, but that you put your condition right into your if statement here. Now, sometimes you also have alternative conditions. Here, both have to be met, but let's say, for whatever reason, we also want to lock the user in if he's older than 20. So we can also add an OR statement with the two pipe symbols here. So here we can add OR and check OR age greater 20. And that's another Boolean comparison operator here. Besides the double equal sign, you also have greater than or equal, smaller than or equal, and also not equal with the exclamation mark in front of the equal sign. Please note that this is only one equal sign in here. So these are alternative operators, and here I'm using the greater than operator so that this part here returns true if age is greater than 20, which it here of course is. Now, how can we read this overall expression though? Well, let's see what happens if I now change my password so that it's wrong, so that this first part here shouldn't be met. If I now run this, we're still logged in. So how can this be read? Well, this reads as, please log me in if this is true and this is true, or if this is true. And well, this here is not true, and therefore this combination here is not true. But this here, this is true. And since it's a or, this overrules the prior false which this returns, because we have an alternative condition that could be met. And only if this condition and this condition would be false, we would not make it in here, because then neither of our two or conditions would be true. And of course, it's always a great idea that you simply play around with Dartpad here and with if statements to find out how you can configure that and what you can do there and how the different operators behave. Sometimes you also want to combine conditions differently than they're parsed by default. So instead of maybe saying this and this should be true, you might also want to say, well, this should always be true, and then this here should also yield true. So you want to combine this check. So you want to say, yeah, you're logged in if the username is Max, and then if either the password is tester or the age is greater than 20. Right now this reads as, you're logged in if this is true and this is true, or if this is true. So if you would want to combine password check and age check together, you could also use parentheses in there, just like in mathematical equations. And now you're saying, well, these two conditions here at the end belong together. So now the username always has to be Max. And then you're either having the right password or the right age. So at the moment, that means we're logged in because the username is Max. But now if I change Max up here to Maximilian, we would actually see that when I run this again, we're failing, because this always needs to be true. I'm then combining it with the check of the ladder condition here. Now, if I would, for example, remove these parentheses which I just added, you see that now I would actually be logged in, and that's making a difference. I would be logged in now because I'm checking, is this true and this true, or is this true? And neither of these first two checks is true, but this here is, and therefore that's why we're now logged in. So using these parentheses correctly is very important. And of course, it's also important that you use these comparison operators correctly. Also be aware of the not equal operator, which is also super important. And therefore you have a lot of power to control when your code executes. Now, sometimes you also have a more complex if check, where you don't just have an if and an else statement, but you know, well, if this here fails, I might have some alternative code to execute, but that code also depends on some condition. And then you can add an else if statement. You can then also still have a normal else statement if you want to. Now you would say, well, if this here is not met, if this first condition is not met, then we make it to the next block in line, and that is an else if statement. And there I can check yet another condition. And only if this condition is then also not met, we make it into this else block. if this condition here is met, we don't make it into this else block. And here we could check if is logged in is true. And now if I also add this extra parenthesis pair up there again, so that the first check will fail, now we should make it into the else if block, and then we could print overruled here to see that this executed. But when I hit run here, you indeed see failed, because of course is logged in is false. As soon as we set this to true, however, or we derive this dynamically and it yields true, then we see overruled, because now we're running the else if block, because the first condition was not met. Therefore we got into here, we check this, and this is true, and therefore now we're running this. We're then not making it into the else block too. These are if statements, and they're an important construct in basically any programming language you can learn, and therefore also in Dart. We'll use them a lot throughout the course, and I hope that this lecture here was helpful in understanding how they work and how you may play around with them. There is an important value built into Dart which we hadn't had a look at yet. We had a look at string values between the quotes, at integers, doubles, and so on, but what we hadn't had a look at yet is the null value. Null simply is a value built into Dart which you can use if you might generally expect another type of value. Let's say you have a username and that is max, but then something in your application happens and you want to reset that to an uninitialized state, so to say. And in such cases, you can set this to null. This does not violate the rule or the inference of username being a string. So just to prove this, if I would assign a number here, then actually here I would get an error, because a number is of course not a string, an integer is not a string. Null is assignable here, even though it's of course not wrapped between quotes. Null can basically be assigned to any type, so no matter if you normally expect a string, integer, double, whatever it is, null can always be assigned, and you often assign it to reset a variable, to reset the value in a variable, to indicate that you have no value yet, anything like that. You can also use it in Boolean comparisons. So if you have an if check and you want to find out if username is set, you could check if username is not equal to null, for example. That would be something where you would also use null, because right now, if I don't assign a value, this would, for example, be null. The default uninitialized state is that this is null. So then such a check here could be useful. So using null to reset values, or in checks to make sure that you have a value and you're not in uninitialized state, can be very important in Dart. We'll use it throughout this course, and therefore null is a value you should be aware of. Now let's start with the ternary expression, and therefore here you first of all have your condition. The condition here could be without the if keyword. That's how you write a ternary expression. So the condition here can be the same condition as up there. Is the question index smaller than the question length? If this is the case, then you add a question mark. This will then mark the border to the code which should run if this is true. So the thing after the question mark is used if this condition is true. And then you need to add a colon after the code block that should be used if this is true. And this part after the question mark must only be one expression. Here, since it's a lot of lines, it looks like it's more than one expression, but in the end it's only the column here, right? It's only the column. All the other stuff is in the column. So only the column here is created if that is true. And therefore, after the column down there, we add a colon, and now we have the so-called else block. We didn't have an else block up there, but we could add it here as well. You can add else here, and then you can define code that should run if the condition is not met. So if this here, if this returns false, then you will go into the else block. By the way, in if statements like this here, you can also have else if statements where you could add other conditions which are checked if the first condition is not met. But let's ignore that for now. For the ternary expression here down in our body, we don't have else if, but we do have our main code if the condition is met, and then after the colon we have our else block. And now that could be a center widget, which is another widget baked into Flutter that centers all the content horizontally and vertically on the page. It takes a child, and that is then the widget which should be centered, and this could simply be some text like "you did it." And let's add a trailing comma here, reformat everything, and now we have a ternary expression. If we now reload this application, and we go back, now I can select my answers, but after the third button click, we don't get the error, but we get "you did it." And that's, of course, way nicer and already a better user experience. Now that we added this ternary expression, we cover a lot of the core fundamentals of both Dart and Flutter. Now, obviously, there's way more to learn, otherwise there wouldn't be more course content left, but it's an important first step. This ternary expression down there, however, could be kind of difficult to read. If you'll have a look at this, it might not be obvious on first sight what's going on here, especially because we have this quite complex column in between. And to be honest, it isn't even that complex. You can and you will throughout this course have way more complex widget structures than this column here. And what could we do about that to make that more readable? If you want to make your widget tree more readable and more manageable, one thing that should always come to your mind is splitting that. You can, of course, split your widgets into sub-widgets. The question always is, should you split it? Well, let's assume you have a bigger widget with a lot of different nested widgets which you pass into each other and so on. Then, of course, you can always split this into separate sub-widgets which take the individual tasks. And the question is, should you do that? Now, in general, and that's really something you can memorize, in Flutter, it's always encouraged to create more than less widgets. Of course, you should not wrap every single built-in widget into your own custom widget. And you will get a feeling for when the right point to split your widgets is there. But overall, it's better to have smaller widgets than large widgets. It's better to have readable code than unreadable, really entangled code. It's better because it makes your code easier to manage for you and your fellow developers, but it's also better for performance. That is something I'll dive in later though. So in our application which we have here, it might be worth considering putting the column here, but also the center widget into a separate widget. Now, of course, the center widget is not really complex at all, and it would be fine to leave it here, but I do plan on adding more content to it. So therefore, I will add two new widgets here, quiz.dart and result.dart. Now in my quiz.dart file, I'll create a stateless widget, quiz, where I import the Flutter material Dart file as always. And then we can take this column, which we have in the main Dart file, grab it, and add it here instead of that container as a return value for the build method. Now, of course, in here, we're referring to the question and to the answer widgets. So what we should do here is we should import both. We should import question Dart and we should import /answer Dart to unlock these widgets here in this file. And I'm referring to the questions list and also to the answer question function. Now, of course, you could now think that you want to turn quiz into a stateful widget now, because now we have both the question and the answers in here, so we could manage everything for that in this widget. But please keep in mind that in order to show the result, which we want to do in the main Dart file and not in the quiz Dart file, otherwise we would basically transfer the ternary expression also into the quiz Dart file. Because we need to manage that condition in the main Dart file, we want to keep our state in here. So instead, what I want to do is here in the main Dart file, instead of importing the question, I import the quiz.dart file, and that allows me to use the quiz widget here if this condition is met. So after the question mark here in the body, and to the quiz widget, we should pass both our questions list and our answer question function. And that, of course, means that we forward this answer question function through two levels of widget. We pass it from the myapp widget in the main Dart file to the quiz widget, and in the quiz widget, we forward it to the answer widget. But it is what it is. It still is a linear setup where we manage the state on the highest level that makes sense, where we then also can still control whether to show the quiz or our result, which we will soon show here. So that means I want to forward a pointer at answer question to quiz, and I also want to forward questions. And as a side note, because I forgot this earlier, since questions is now a property of the entire class, it should of course be underscore questions to be in line with, for example, the question index here, because it is a private property that's only available in my app state. So change questions to underscore questions, change it in all the places where you use it, like here in the condition, and here where you pass it down. And now in the quiz widget here, we want to accept both that function, that answer question function, and our questions list here. For that, let's add two final properties here as you learned it. Runtime constant values, which are initialized when our app starts, but thereafter they don't change. And here we have our list of maps, where each map also has different values. It holds string keys and object values. So we have these nested generic assignments here. So we have our list of questions. And we also have a function, which I'll name answer question. Without an underscore here, because this widget is not private, it should be used from inside other files. So here I then also add a constructor. And to mix it up, not because it's required, but to mix it up, I'll use named arguments here. So I'll have my questions list and I have my answer question function here. Now, the problem is I also need to know which question we're looking at. So let's also accept our question index here, which should be an integer, and also add this as a named argument here to the quiz widget. And then here I use question index without the underscore, and here answer question without the underscore, and therefore this should all work. And now in main Dart, where we use this quiz widget, we now have to pass these values as named arguments. I also want to add, before I pass it, I want to add required, at required in front of all these arguments. At required is a decorator provided by Material Dart, and it basically tells Flutter that, well, all these values are required, that we must not omit a single one of them. So if we tried to create this quiz widget with only one or two or none of these arguments here, we would get an error. So now, of course, we have to create that quiz widget. We do that in the myAppState class in the main Dart file. Here's the quiz widget. And now let's assign values to our named arguments. If we place the cursor between the parentheses and we hit Control Space, we get some IDE support. And for answer question, which is my function pointer here, I want to point at underscore answer question. So my function I have here in the myAppState class. At question index, there I want to pass underscore question index, which is the property managed here in my myAppState class. And at questions, I will pass underscore questions. So now we're creating that quiz widget with that data forwarded to it. Might look a bit redundant, but still, I'd say that is now cleaner here than having the column in here. Let's now also outsource, of course, our result. So that center widget. Here in result Dart, I again create a stateless widget, which I'll name result. And in there, I import package Flutter Material Dart like before. And instead of returning a container, I return center. Now we just need to use that result widget here. So after the colon, we can use result like that. For that to be available, of course, we need to import it though. You always need to import what you use. So let's import result.dart. With all of that out of the way, let's restart the app by pressing the green refresh button here, and let's see whether that works as it should. We see the questions and the answers, and I can tap them, and if I tap my buttons 3 times, I see you did it. Of course, it was a lot of work for the same result as before, but Flutter is also all about writing clean code and clean widget trees. And I would argue that this is now easier to read than having that column here in our main Dart file. Especially, of course, if you had more and more logic in here. And splitting your app into widgets is a good practice. As I mentioned, don't wrap every single text into your own custom widget, but as soon as it gets a bit more complex, a couple of lines, more logic, then you should strongly consider creating a new widget for that. This was a pretty long module. I now want to wrap it up or bring it to an end by making this quiz a bit more realistic and showing different results based on which answers we chose. Now, of course, you could now make this extremely complex. I will make it relatively simple, though. What I want to do is I want to turn each answer here also into a map by wrapping it with curly braces. And then we'll, of course, have our text or answer text or whatever you want to name it. And now that's the important new thing. I want to assign a score to this answer because we have kind of a personality quiz here. So we can calculate an overall score of the personality of the person who takes our quiz. Now, let's say, and that's of course just my logic here, the higher the score, the more strange or negative a person is. And therefore, if you, for example, select black as your favorite color, I'll give you a score of 10. On the other hand here, for red, where then red is our text, we might go with a score of, let's say, 6. Or 5, because red is more positive than black, in my world at least. Now green is even more positive, because green is the color of hope. And of course, feel free to assign your own scores to fit your own personal judgment of these colors. But I'll give green a color of 3. And well, white is of course the color of innocence. So here for white, I'll actually give that a score of, let's say, 1. So with that, these are my answers. They're now all maps, not just text. They got a text key, but then they also got scores. Now, of course, we can do the same here for our animals. And I will now fast forward here. Of course, feel free to assign your own scores or take the ones you find attached. Attached, you basically find that questions list now with all my finished scores assigned. And we can then proceed with that. So with the finished list here, now of course, when I pass down my questions here into the quiz, inside of the quiz widget where I built these answer widgets, the answer I'm forwarding here is no longer just a string. That is incorrect. Instead, each answer I'm looking at is of course itself now a map, so we should change this. A map where we have a string key and then objects, various values, because we have in our answers, we have both text and we have numbers. So therefore, here when I map, answer now is also a map with various values. And therefore here, I'm of course interested in my text, in the answer text, which I know will be a string. But I will also need the score to calculate a total score, of course. And for that here, to answer question, so to that function which we have in the main Dart file, this underscore answer question function here, we actually need to get the score of the answer which was chosen. So I expect a score here as an argument, and this should be an integer, to calculate a total score. Hence, we should also add a total score, underscore total score, here, a total score property in our overall class. And then here, in answer question, I want to increase or add to the total score the score that we chose. So total score should be equal to total score plus score. By the way, if you have a setup like this, there also is a shortcut in Dart. Instead of using equal old value plus some new value, you can also have plus equal. And this will add this value to the old value before it then saves it back into that variable. So we add our score to the total score now in answer question. But now we have to make sure that in the quiz start file here, where we forward answer question to an answer, we actually make sure that we call answer question with the chosen score. And at the moment where we only point a reference, a pointer at that function, we're not doing that, because with just a pointer, we're not saying anything about the arguments that this function takes when it is called. And by default, Flutter will call it without any arguments, because we must not forget that our function here is bound to onPressed, and onPressed takes a function without arguments. So what do we do? In QuizStart, where I build my answer widgets, where I forward that pointer at answer question, instead of forwarding this, I can forward an anonymous function. And here I use this one-line arrow function syntax, which I also showed you earlier. Now, by doing this, I create a function on the fly, and to the answer widget, I automatically only pass the address to that function. So that function is created on the fly, stored in memory, and instead of storing it in a variable, which then holds the address, which I could use here, I automatically get back the address. So I do get the address here, and I forward that address to answer. Now the thing is, therefore, my answer widget still gets a function which takes no arguments, right? That is an empty list, and that then does something. Now here, however, on the right side of the arrow here, I'm in the function body of that anonymous function. So here I no longer want to just use the address. Here I instead want to call answer question. Why? Because this is now not executed when Dart parses this. There it will only create this anonymous function and store it in memory. But this is now executed when onPressed is triggered, right? Because it's an anonymous function where I forward the address to answer. The address is then bound to the button here. So when the button is pressed, this address is used to then execute this anonymous function. So this function body here is only triggered when the button is pressed. Therefore, when it is pressed, I do want to call answer question. And now, since I call it here, I do have access to my answer map here, to my answer object, and therefore also to the score. Because every answer through which I'm looping here, or for which I'm going here, every answer is just a map with a text and a score. And now I can access that score here. So I can now forward answer score here to answer question. And I know that this will be an integer, and therefore answer question here will receive my integer score. Here it is. I hope this flow is clear. It's really just about passing function references around, and here we're creating such a function and therefore also such a function reference on the fly. It only gets executed when the button is pressed though, so when it is pressed, I of course want to execute this function in here. So with that, I can forward the score to my answer question function here in main, and I do increment the total score now. I now want to forward that total score to the result widget so that I can show different results there. So in result here, let's add a final property, an int result score, or whatever you want to name it. Let's add our constructor, and now as a positional argument, though of course you could also use a named argument if you preferred that, but here I will take this as a positional argument, my score. So when we use the result widget here, we now have to forward the score, and that of course now is our total score. So now the total score, which we calculate here in the myAppState class with the help of our total score property and the answer question function, that total score is now forwarded to result, and in result, we now receive this here in the constructor, and we automatically, thanks to the shortcut here, store it in the result score property. Now I just want to output different texts here based on my result score. Now, first of all, let's assign some styling here. We did this earlier. I would do this with the help of the text style class here and the style argument on my text widget. And I want to set the font size here to, let's say, 36, and also set the font weight, we haven't done that before, to font weight.bold. Again, font weight is here a class, and that is a static property. Again, font weight therefore is basically a utility, a grouper class, which groups a couple of predefined values, and that is basically a value that instructs Flutter to turn this text to bold text. Still, we need different texts, and we got different ways of now generating this. I like the way of adding a getter here. A getter here is a special type of property. It's basically a mixture of property and method. You create a getter by, first of all, defining which type of value you want to get, you want to derive, and that would be a string because I want to get some text. Then you add the get keyword, and then any name you want, like result phrase. Now, unlike in a method, you now don't add parentheses because a getter is like a method that can never receive any arguments. You do add a body though, and in that body, you now have to return a string. You always have to return something in a getter. You use it, however, like a normal property. So down there, instead of you did it, I will use result phrase, and I don't use it with parentheses to execute it like a function. I'm also not using it as the address of a function because this is no function. This is simply a Dart feature. It's a normal property, but the value is calculated dynamically. And here, the value I want to calculate is calculated based on the result score. So in here, in my body of that getter, I'll create a new variable, result text, to avoid name clashes here. And I'll assign a default of you did it. But then I want to add an if statement and check if my result score is, let's say, smaller or equal than 8. If that is true, then here between the curly braces, I'll set result text equal to you are awesome and innocent. So I'm overwriting result text with that new value here. Else if, and that's now new, I mentioned it earlier, we haven't used it thus far. It's an else statement, which kicks in if that condition is not satisfied. But unlike the normal else statement, it does now not blindly execute the code between the curly braces, but it checks another condition first. And here I check if result score is smaller or equal than 12. So if it's not smaller or equal than 8, then maybe it's smaller or equal than 12. In that case, I would set my result text to pretty likable. Whoops, with an extra E though. If we don't make it into there, we can check if the result score is smaller or equal than 16 maybe. And remember that in the way I designed this quiz, higher scores mean a more negative personality. So in that case, I will set result text to you are strange. And then in all other cases, I will set the result text to you are so bad. Now, of course, since I have that overall else case here, we don't really need an initial value here because we'll never keep that. We'll certainly at least make it into this else block here. So we could also get rid of that. And in that case, as you'll learn, it's a good practice to define the type that will be stored in result text in the end, which is a string. Now here in the end, I do return that result text. And therefore now, when we use result phrase down there, that should be based on the result score we're getting, and we should be outputting different results, well, based on the choice the user made. So let's reload this application here. And now let's go for a negative personality. So I like black, I like snakes. And well, here everything is right. And we see you are so bad. Now that's good. Let's restart the app with the green button here. Of course, it would be nice to have a button here, but for the moment we don't have that. So let's wait for that to reload. And now let's go for a good personality, white. And then I like rabbits. And of course, I like myself. You are awesome and innocent. So that's nice. One thing, of course, I notice is the text itself is not centered. So we can quickly do that in the result Dart file. Here on the text widget, we can set text align to text align.center, something we also did earlier. And now if we save that, it is centered. So that's pretty sweet. And that's working as it should, as it seems like. We're now showing different results based on different choices. And now we have, well, maybe not the most awesome application we ever built, but a realistic application that we could fine-tune and already deploy to the app stores if we wished to do that. Now, to finish this up and make sure we can restart the quiz from inside that result screen, let's make sure that in the result screen we also have a button we can press to reset our question progress. And for that, we need to add a button below our text. How do we do that? How do we add things below other things, widgets below other widgets? Well, we need a column. So let's wrap our text in a column. And previously I did this manually, but actually with the Flutter extension installed in the IDE, we can do some automatic refactoring. For this, use the refactoring shortcut, which you can find in your key bindings if you're not sure which shortcut that was. And position your cursor, so click on the text here, and then press that shortcut. And you should now get a couple of options here. And normally one of them is wrap with column. If you don't have that, you can at least wrap it with a new widget and manually create a column. I do have it here, however, so I will press enter. And now we automatically have this wrapped in a column, and text is now already in the children array here. If we save that, now we see the centering is lost. That is the default behavior because the column by default takes all the available height of the viewport, so off the screen. And for the moment, we'll ignore that. We'll dive deeper into the depths of columns and rows and layouting in a separate section. So for now, let's live with that. And let's instead focus on adding an extra button below the text. We could add another raised button here, but I will add a flat button. Flat button is basically a button without a background color. Other than that, it's a normal button. It needs a child, which is basically the content displayed on the button. And here a text will do, and I will say restart quiz. And we also, just like on the raised button, need an onPressed handler. Now you know that onPressed needs a function reference, the address of a function. And restarting actually is some logic that probably has to be done in the main Dart file, because that is where we manage our current question index and the total score. And both needs to be reset to 0 in order to restart. So in the main Dart file, in the myAppState class, we can add a new method, reset quiz, or whatever you want to call it. And the goal here is to set both question index as well as total score back to 0. Because if we do reset that to 0, especially when we reset the question index, when we do that inside of set state, which we of course have to do, so inside of that function which we pass to set state, if we do that, then you know that the build method of this myAppState class will be re-triggered. It will rebuild that tree and therefore also re-evaluate that condition and find out that now our question index is smaller than our question length again, and hence not render the result anymore, but the quiz. And that's exactly what we want. So now we have a reset function that should do the trick. Well, we need it here in main Dart in our myAppState class, but we want to trigger it from inside the result widget. However, that is something we did before as well. We simply need to pass a pointer to that function to the result widget. So I pass reset quiz without parentheses to the result widget. And in the result widget, we now need to accept this. So I'll add another property, a function, which is my reset handler or whatever you want to call it. And I will accept this as a second argument. So here, whatever I receive as a second argument is now stored in reset handler. And that is now what I bind to onPressed. So here we can bind reset handler. And with that, if we now save this, we see restart quiz. If I press that, indeed, we restart. Now, to make this stand out a little bit more, we can add some color, some text color here to the flat button, and maybe use blue here so that we can see that button a bit better. So now if I press that, we can dive in again. This is all looking good. We can now reset this. I won't argue the user interface itself is not the most beautiful one I've ever seen, but we'll learn more about building user interfaces, styling your applications, and also layouting, so that we can also center vertically when we're using a column, something we lost for now. We'll dive into all of that later throughout the course. For the moment, we had an extensive look at all the core basics you need to know about Flutter. So in this module, we built our first little application. Now, as I said, of course, we can certainly build more beautiful applications. And that is something we will, of course, do throughout this course. No worries, we'll dive a lot into how you can style and lay out your apps, how you can change colors, how you can adjust all these widgets to your needs and preferences. What we did in this module, though, is we covered a lot of important things. We covered what widgets are, that there are stateful and stateless widgets, that you typically use more stateless than stateful widgets, and that they are both important and how they split work. You learned how to work with built-in widgets and where to find them in the official widget catalog, that you can also build your own widgets that actually compose more complex user interface building blocks from these Flutter primitives you get from these core basic widgets Flutter gives you. You learned how to manage some data, how to pass it around as arguments to constructors, and you also learned a lot about Dart and some of its core fundamentals. If you haven't done it already, definitely dive into the attached resources and text lectures, which you also find in this module. Also in the attachments to the last lecture of this module, especially also to compare code, because this will then allow you to dive deeper into certain things you struggled with or which might not be entirely clear yet. With all these resources, you should have a first understanding of what Flutter is, how it works, and how you work with it, and how you build widgets. Now, we'll of course continue doing that throughout the course and dive even deeper into other features and other things you can do with Dart and Flutter. So let's move on.